on data structures and algorithms, operating system, OOPS, computer networks, and problem solving skills is definitely important for cracking placements and job interviews. With that thought in mind, let us check our agenda for today's session. First, we'll be talking about what actually recursion is, because recursion is something which is the basic of data structures. Then we'll be talking about types of different data structures like array, array of structures, linked list, tree, and lot more. After each topic, we'll be also doing hands-on work to execute every data structure. We'll be also doing some hands-on work on different types of sorting algorithms like bubble sort and quick sort. At the last, we'll be also discussing about some common interview questions and answers which will help you to ace your interviews. So that's all with the agenda. Now let's start the session. But before we begin with the session, please like and subscribe to our channel and hit the bell icon for more updates from Intellipaat. Now let's begin with the session.
Let's start with what is recursion. So everybody might have solved jigsaw puzzle in your childhood, or you might be doing today also. So how the approach of solving a jigsaw puzzle is: first we try to find out the corner elements, then we try to fix it, and then we try to find out matching elements with those corner elements, and then keep on building the solution. Recursion is very similar to this. Recursion is identifying a smaller problem and solve the smaller problem and bundle the solution of this smaller problem to find the solution of a bigger problem. So how we are solving this jigsaw puzzle is, we are solving a smaller problem by finding out the corner elements, and then we are using that solution and finding out the related elements with the corner elements, and so on, so that we solve a bigger problem, which is a jigsaw puzzle. Recursion is much more similar to that. So for recursion, sometimes it's the best way to solve the problem is by solving a smaller version of exact same problem. Recursion is a technique that solves a problem by solving a smaller problem of same type. So why I'm using it as a smaller problem of same type? Because the problem that we have seen in jigsaw puzzle is attaching the pieces. So that is a problem, that is a small problem, and we identified that jigsaw puzzle can be solved by attaching the pieces. So we first solve how to attach two pieces, and then we solve how to use the attached two pieces to find out next two pieces, and so on. So when you convert this into a program, you will end up in calling functions that call themselves. So functions that call itself are known as recursive functions. So let me repeat it. Functions calling itself is a recursive function. So let's take an example of a recursive function. So here I am giving you a problem. The problem is write a function to calculate the power of 2. So given you write a function f, and you will be giving a number as an argument, and you need to compute 2 to the power of that number. Okay, in the screen I have shown you the solution also. So we'll be writing this solution, but let's see, I am using this function f. Okay, and here f is again calling itself. So function calling itself is a recursive function. So let's begin with understanding how we have to decide whether we have to write a recursive function or not. So let's break down into a smaller problem. So identifying a smaller problem is a recursive function. So when we say I need to write a function that can give me power of 2, so I have identified that I can get power of 2 by using this approach. 2 into function of n minus 1. In case n is equal to 0, I'll be returning 1. Otherwise, I'll be returning 2 into f of n minus 1. So again, f of n minus 1 will call its f only, and then we will proceed in a loop kind of manner. So for example, we will be calculating f of 4. So f of 4 will call 2 into f of 3, which is f of n minus 1. F of 3 will call 2 into f of 2. F of 2 will call 2 into f of 1. F of 1 will calculate 2 into f of 0. F of 0 will return 1. So from this we will be getting, so this piece will, f of 1 will return 2. Then we will be multiplying 2 with 2 and getting 4. We will be multiplying 4 with 2 and getting 8. We will be multiplying 8 with 2 and we will be getting 16. So this is how we are building our solution. Okay, if you see this call stack, first f of 4 is called, then f of in f of 4 we are calling f of 3 again and multiplying the result of f of 3 with a 2. Similarly, in f of 3 we are calling f of 2 and multiplying the result of f of 2 with 2, and in f of 2 we are calling f of 1. F of 1 we are calling f of 0. F of 0 will return 1, and then we'll multiply the result of f of 0 with 2. We'll be getting 2, and we'll be multiplying 2 with 2 and we'll be getting 4. 4 multiplied by 2 will be getting 8. 8 multiplied by 2 will be getting 16. The final result will be 16. So let's start with writing code for this. I'll be writing commands. I'll be adding preprocessor directives. Main function, I'll be declaring function f. It will return an integer and take n as an argument. This is our exit condition. Let's take an variable. Y equal to 2 f of n minus 1 and then we'll be returning y here. Let's call this method in main. Let me calculate power equal to 4, then power of 2 equal to, I'll be calling f of power I will be printing this in the console. 2 to the power of percentage d is percentage d. So 2 to the power of this is power of 2. Let's save and try to run. So we are getting a result 2 to the power of 4 is 16. Okay, so here what we are doing is we are calling f inside f and calculating the results as we have explained in the PPT. So this is how our function will look like, as I have already explained. So f will be calling itself to solve the problem. So key to identifying the recursive problem is finding the smaller subproblem. That is, if I can calculate this 2 into f of n minus 1, I will be ultimately getting f of n minus 1 and identifying the exit condition. So when should I exit my function? This is very important. So for example, n 2 to the power of 0 is always 1. So my exit condition is whenever I reach 0, I should return 1. If we don't find a proper exit condition, it will be very dangerous for a recursive function because it will end up in infinite loop and it will be very difficult to find what is the problem in our code. So these are the two keys for writing the recursive function: identify a subproblem and identify the exit condition. So let's take one more problem, coding for factorial function. So here we'll take similar approach that we have taken in the previous example. Let's solve a smaller problem, factorial n. So what factorial n, how can I solve factorial n is? So as we know, factorial n can be solved by n into factorial of n minus 1. So if I can solve factorial of n minus 1, I will be getting factorial n. So we'll be solving this recursively. So we find out a subproblem. And what is our exit condition? So whenever I reach n equal to 0 or n equal to 1, I will be returning 1. Okay. So as per the previous slide, we have done all the two things: identifying a subproblem and identifying the exit condition. So this is a sample code, that sample function for factorial. If n is less than equal to 1, return 1. This is our exit condition, and this is our subproblem. If n is not greater than 1, then we will be further going to solve subproblem, which is n into factorial of n minus 1. So let's write code for this. So let's write code for the factorial program. Write factorial of n. Okay, I'll be including stdio.h. declaring one function. Let me call it f for simplicity, and calling main method. Returning 0 in this method. We'll be calling f number equal to, say I'll be giving factorial of 3. Factorial equal to f of number, and I'll be printing the result. Factorial of number is factorial. Okay, let's write the function f. Int f, take n, sorry, it will take n. So let's write the exit condition first. If n is less than or equal to 1, then we'll be returning 1. Else return n into n f of n minus 1. Okay, let's save and run it. So here I am getting the result. Factorial of 3 is 6. So what we have done in this program is we are calling function f in itself, like here in this line number 18, we are calling f by giving a value which is n minus 1. So f will continue to call itself unless it reaches some value which is less than or equal to 1. If it reaches a value which is less than or equal to 1, it will return 1. This is our exit condition, and this is our sub problem. So let's see using this diagram how the factorial of 3 was calculated. So factorial of 3 will call factorial of 3, then from 3 I'll be calling factorial of 2, from 2 I'll be calling factorial of 1, then from 1 I'll be calling factorial of 0, and from 0 this will return 1. Okay, I'll be multiplying 1 with 1, this will return 1. I'll be multiplying 1 with 2, this will return 2. I'll be multiplying 2 with 3, this will return 6. So ultimately I'll be getting factorial of 3 is 6. Great. So what is recursion versus iteration? Like, why do we use recursive approach rather than iterative approach, and what are the trade-offs between using recursion and iteration? Let's understand these. So to sum up, yes, recursive functions are sometimes less efficient than iterative functions. Iterative functions are nothing but functions where we call loop instead of a function calling itself. So sometimes recursive functions are less efficient, so we need to consider the time and space complexity while going for a recursive function. So many of the times recursive function do leads to memory overflow or stack overflow, but it's not like recursive functions are useless, but we need to take care of our time and space constraint before using a recursive approach. And we should also analyze how much time and how much space will be taken when we are solving our problem with a recursive approach rather than with a iterative approach. So recursive problem can simplify the recursive solution can simplify our solution of problem, often resulting in a shorter and easily understood code. So if you write an iterative code, that code will be a bit lengthy code, and somebody else reading your code will take some more time to understand what is going on in your code. And compared to recursive, if you compare it with recursive code is much more simpler and easy to understand. So it has very limited number of lines, and it is easy to understand what is happening in the function. And very importantly, if recursive function is not written properly, it could result in infinite loop. As I have explained earlier, we should identify the exit condition properly for a recursive function. Otherwise, we'll end up in going in an infinite loop, and this will be very difficult to solve. So before deciding on a recursive approach, be sure to have these two in place: identify the subproblem and identifying the exit condition. So let's do some problems. We'll do these problems both in recursive manner and iterative manner. So let's try to solve this problem. Write a function to find sum of digits of a given number using recursion. So first we'll do with a recursive approach, then we'll do with a iterative approach. So let's write the code for this. First I'll be writing it with a recursive manner. Write for sum of digits of given number. So how this will work? If suppose I am given a number, say 345, the result should be 3 plus 4 plus 5, which is equal to 12. Okay, let's write it out. So let me include the stdio.h. and writing function sum and main method let's return 0 in main method. Let's define some number. Okay, let's call this function sum and print the result. Sum of digits of number is this. So we'll be giving arguments for this number and sum of digits. let's write it out, this function. Okay, so before writing it out, let's understand what should be our exit condition and how to solve the problem. Okay, so we need to identify two things. One is the exit condition, one is the sub problem in this. So here the sub problem could be so the sub problem could be n percentage 10 plus sum of n by 10. So here we have y n percentage 10. So let's solve this here. For example, and I will be finding out the remainder of the number when we divide it by 10. So let's take an example of number 3 4 5. When we take the remainder of this number, when we divide it by 10, we will be getting 5 plus sum of n by 10. So n by 10 would be 34. Okay, so we'll be taking out 5 and then we'll be solving 34. In the next step we'll be taking out 4 and we'll be taking it we'll be solving 3 and so on. And what should be our exit condition? If n equal to 0, then return 0. So this should be our exit condition. This is our exit condition and this is our sub problem. So let's write a code for this. If n equal to 0, let me take in n less than equal to 0 for safer side. It won't happen, but it's good to have in a safer side. Return 0, else and we'll take remainder and take div. So remainder will be n percentage 10 div will be n by 10, and now we'll be giving our result. So return remainder plus sum of div. Looks correct. Also, what happens if we are if in this function some improper values are given? So it's better to identify those values and not to execute those values in the function. So if you have seen, I have taken n is less than 0. So in this problem statement we are just considering the positive numbers. So in case somebody has given any negative number, exiting our code with and giving the result as 0. Okay, so it's also a good practice to identify the corner cases, like what all inputs I'll be getting in my function, and handle those corner cases so that in any case your code will not break while you run the code. So let's try to run the code. So here we are getting a result. Sum of digits of 3, 4, 5 is 12. Okay. So what if I give, say, minus of 3, 4, 5? Let me test my code with this, whether am I handling my corner cases or not. So in this case I am returning 0. So always just identify what is your problem statement given. Here the problem statement we are trying to solve is sum of digits of a positive number. In case you want to solve the entire range, you can modify this code and handle all the conditions, but it's I am telling this just to make sure that you should be aware like what inputs you will be receiving in your function and how to handle those inputs. Okay. So let's write the iterative version of the code. Let's try to solve the same code by iteration. So I'll be using same file. I'll be adding one more method, some in an iteration manner in 10. Okay, let me write it out this method. We'll copy it. So let's write it in an iterative manner. Okay, let me define some variables. Let me define some variable called sum. I have already taken sum, so I'll be taking sum of digits equal to 0 equal to 0. I'm taking dividend equal to 0, initializing all the things. Now while n is greater than 0, sum to remainder is div remainder equal to number percentage 10. This is our remainder equal to number by 10, and we are adding it to sum of digits, and then we will be returning.
Just a quick info, guys. Test your knowledge of C programming by answering this question. Which of the following is not a data type? A. Float, B. Int, C. Real, D. Imaginary. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
So what we have done in this code is we are doing some we have defined three variables. One is sum of digit, one is remainder, one is dividend, one is div, and we'll be looping it till n is greater than 0. If we find n is equal to 0 or less than 0, then we'll be exiting this loop. We'll be calculating a remainder and div and adding it to the sum. Okay, let's call it out in my function. I'll call it here only. Instead of sum, I'm calling sum of iterations. Okay, and we have not decremented n equal to n by 10, or we can say n equal to 3. Okay, it should be sum of digits plus equal to. Okay, so this sum of digits plus equal to remainder. Let's build and run it. So yes, here we are getting correct result. So this example shows how we can run, or we can find solutions using iterative and recursive approach. So this is the recursive function and this is the iterative function. So as you can see, there are very less lines of code in the recursive function, and in iterative function we need to write lot of lines of code, lot of declarations and all the stuff. We can take advantage of getting rid of declarations in recursive approach, and looks much cleaner. So it's up to the program logic where if we need a recursive or an iterative approach. So what is preprocessor in C? Before C program is compiled in compiler, a source code is processed by a program called preprocessor. So earlier in this tutorial we have covered how a C program is compiled. So first, all your C files and header files are taken to a preprocessor, and the preprocessor will run, and it will convert your file to a .i file. So what it does is whatever functions you have used in the libraries or other preprocessor directives that you have used, it will expand and mix into your code and generate a single I file. So this is how it is done. So command used in preprocessor are called preprocessor directives. So whatever we have used commands, for example, we have used hash include a lot while doing coding. So hash include is nothing but a preprocessor directive. Just to have a note of it, all the preprocessor directives start with hash. So whenever we have include preprocessor, for example, stdio.h, we have used hash include stdio.h. So hash is nothing but an identifier which tells C program that it is a preprocessor directive. So this is how we compile the program, when we compile the program, this is the steps that the program went through. So first, the source code is pre-processed and expanded source code is generated. For example, suppose we have written sample.c file, and we have used lot of preprocessors. For example, hash include stdio.h, or hash includes string.h, or hash defines, or if we have used lot of preprocessors, our source code is expanded. That means all the preprocessors are simplified and merged into a one file which is called .i file, and then it is compiled, assembled, linked and load. This we have already covered in previous sections. Just to revisit, once we got a .i file from preprocessor, compiler takes it and generate a .s file, .s file is nothing but assembly level source code which is taken by assembler. Assembler will take this file and generate a .o file. .o file is nothing but an object code file or a machine language code which is taken by linker. If there are multiple O files, linker links those .o files and generate your executable file. So what are the advantages of preprocessor? Preprocessor helps program easy to develop. So suppose we are using a hello world program and we are printing hello world in our program. So how preprocessors are helpful? We are adding a printf statement. Printf is defined in stdio.h, so we need not have to write printf again and again. We just have to use that one line only, and it will do all the functions of console writing and all. So this makes our program more and more easier, so that we don't have to write a lot of lines of code. So the advantages are easy to read, easy to modify. So in case we want to modify our function, for example, we want to modify a printf function, we just have to modify it in one place and it will be reflected wherever it is used. And also C code becomes more and more transportable between different machine architecture. So if we want to have a different version of printf in one architecture and different version of printf in another architecture, we can ship it with while doing a build with different versions, and it will become more and more transportable. So what are preprocessor directives? Here are the list of preprocessor directives, which are macros, header file inclusion, which we have already used a lot. Header file inclusion is nothing but hash include some header files. For example, we have include lot of time stdio.h almost all times. So this is example of header file inclusion. Conditional compilation, will be covering this and some other directives. So this is a map of how preprocessor directives are used. Uh, this is file inclusion, which we have used lot, hash include stdio.h. Macro substitution directive, where we define some variables or define some inline function or define some small functionality and which can be used in a program again and again. Conditional directives are like conditional compilation. For example, we have two different machines in which we want a program to be compiled, and one machine uh, uses a certain type of instructions, and one other machine uses certain type of instructions. So we can do a conditional compilation. We can say if machine type is 1, compile this code. If machine type is 2, compile this code. So earlier in this slide we have talked about C code become more and more transportable between different machine architecture. Um, these conditional directives are main facilitators for it, because it can do a conditional compilation, and based on a type of machine architecture, it will generate our output, so that we don't have to write two different codes. We just have to write a single code. We have to maintain a single code, and this will become life of programmer very easy, so that uh, if any change that has to be made in the file, it has to be made in one place and it will be reflected everywhere. Also, there are some miscellaneous directives, for example, pragma, error, inline. So mostly operators which are used in preprocessors are hash or double hash. So let's check what all are the predefined macros. So these are the list of predefined macros. For example, date, time, file, line, stdc. So what these macros does, date will give us the current date in mmmmdt 5 format. Time will give us a time in HHMMSS format. File will give us which current file we are using. Like if you are using sample.c, if you are writing this code in sample.c, it will give that we are using sample.c. Mostly this macro is used for logging purpose. So suppose we are having multiple C files and we want to use logging functionality, and this will help us in debugging also. Suppose there is some problem in our code and we analyze our logs. So from this file macro we can get which file is printing which piece of code, and we can get the root cause of the error by going to that file, checking our code. So this is very important macro. Line, this gives us which line number is executed. So it's a self-explanatory that contains the current line number which is a decimal constant. STDC defines as one when compiler compiles with an ANSI standard. So this is a standard which ANSI standard is used. Let's see one example. Consider this code. I'm printing the macros. Say printf file, which is underscore file, state, which is underscore date, time is underscore time, line is underscore line, ANSI is underscore type of ANSI, and this will be the output. That file is I'm using main.c file. Today is 1st of August. It's 1448. Line number is 8, and I'm using ANSI 1 standard. So this is how I can use the predefined macros. I'll suggest you should try this example in your own system and see what output it comes. So what are our other preprocessor directives? There are hash define, which substitutes preprocessor macro, hash include, which includes another file, hash undefined, which undefines a macro. Suppose we have defined some macro and later point of time we want to undefine. For example, we want to use hash define it for only a limited number of lines, and then we don't want to use it, so we can use undefined.
Just a quick info, guys. If you want to make a career in software engineering, then Intellipaat provides an advanced certification program on software engineering and application development by ENICT Council of IIT Guwahati. And it is taught by IIT Guwahati professors and industry experts. This course is designed to upskill and land your dream job. Now let's continue with the session.
If defined, if def is to check if a macro is defined or not. If n def is returns true if a macro is not defined. If hash if test if a compile time condition is true. So this is done at a compile time only. Else it's a standard alternative of if and if, and ends the preprocessor condition. Hash error prints the error message. Pragma issues a special command to compiler using a standardized method. So let's take one example. Hash include stdio.h. This here we have included the file we used hash include. So we'll be using library function stdio.h. Hash define height equal to 100. So this is the directive that we are using here. Hash define number equal to 3.14. Hash define letter equal to a. Hash define letter sequence abc. Hash define backslash character slash question mark. We print and we can use this. So these are nothing but it can be used as a constants. So for example, we want height to be equal to 100 throughout our program. We need not have to define it again or declare one variable and use it in different functions. We can do it with a hash defined preprocessor. Okay, if def else and if. So let's see this example. Hash include stdio.h. This here we are including the stdio.h. Hash defined hello. We have defined hello in main. So it will check if defined hello. If hello is defined, then it will print hello is defined. Else, if it prints hello is not defined. So this happens at the compile time only. So if hello is defined, this printf will be compiled. Otherwise, this printf will be compiled. So if, else, and if. So this is one more example of if, else, and if. So I'm defining hello. I'm including stdio.h. So if not defined, I'm using here if not defined. If not defined, hi hi. So hi is not defined. That means this condition will be true, and printf hi is not defined. So we are going to define here. So here we will define hi equal to 300. Else hi is already defined in the program, and so what this program will do, so it is checking if a particular preprocessor is defined or not. So in this case hi is not defined, so it will say okay, hi is not defined, let's define it. So it will define hi, and we'll go on. In case if hi is defined here, this piece of statement will not be executed, it will directly go to here. So this is a very straightforward way. Use of pragma. So pragma is a very important preprocessor, where suppose we have defined two functions here, function 1 and function 2. This place we have declared two functions, function 1 and function 2. Now pragma startup function 1. So before main function, function 1 will be executed, and pragma exit. So before exit, before our program is completed, that means after completion of main function, function 2 will be executed. So what in this case, what will be the output of the program, since we have declared pragma startup as function 1? So function 1 is called before main function call, then now we are in main function, then function 2 will be called, function 2 called just before end of main function. So this is how the pragma preprocessor works. You can try this at this code and see what output you get. Preprocessor operators, which are macro continuation, stringize, token pasting, and define operator. Let's see what all these. So macro continuation operator. So in case our macro is too long and it's not coming up in a single line, we can use a continuation operator. Continuation operator is nothing but it will just it will not break our macro, it will continue our macro. So in case suppose this is our macro and it is not fitting it in one line, we can use slash to say that okay, macro is not coming in one line, so this is my continuation operator. But so that the compiler knows that this is or the preprocessor knows that this is not a different macro but the same macro, so it will not throw an error. So hash define message for a, b, and continuation operator printf a and b, I love India. Okay, So this is what you can try it out. Uh, so this is stringize operator. Stringize or a number sign operator when used with a macro definition converts a macro parameter into a string constant. This operator may be used only in a macro that is specified argument or a parameter list. So this macro is used to convert a particular macro into a string. So how this macro is used? So in this example, I'm using both continuation and stringize. So here this is a standard stdio.h. Now this is my macro where I'm using a continuation operator. Now in main function I'm using a message for Carol and Deborah. So message for A B. So here I'm using A, here I'm using B. Now Carol will be replaced with A and Deborah will be replaced with B. So our final output will be Carol and Deborah. I love India. So this is my output of stringize operator. Define operator. Define preprocessor operator is used in constant expression to determine if an identifier is defined using hash define. So for example, let's see this code. In this code we have defined stdio.h. Now this check if message is defined or not. If not defined message, then define it and end. So this is kind of a method which checks if a particular identifier is defined or not. So if we can use it with defined and not defined functions also. So here in this case we are checking if message is not defined, then define a message, so that when we are using it in a main function we don't get any error like message is not defined or something like that. So now the next is parameterized macros. Parameterized macros are nothing but it accepts arguments and performs some function. So macro with argument must be defined using hash define. Argument list is enclosed in parentheses. So this is the argument list is enclosed in parentheses. Spaces are not allowed between the macro name. So we don't use spaces in between. So, the standard example is, for example, hash defined square of x, which is equal to x into x. So this is a macro square of x. Okay, and when we call this macro, ultimately we'll be calling this x into x. So it's like a small function which is also called as the inline function, where we don't have to define a function in our program. It's a macro which can perform small operations like calculating square or adding two numbers or doing some arithmetic operation. So for example, say we have a macro, say max x of y, which gives a value what is the maximum between x and y. So if x is greater than y, it will return x, otherwise it will return y. This is a very small macro which is called inline function also. So which now how we can use it in program. Max between 20 and 10 is just call max, give two values 10 and 20, and it will return the result. We need not have to write the function for this. We'll be doing some practical examples on how to use preprocessors in C. First program will be to find area of a circle. So how to find area of circle? The area of circle is equal to pi r square. So we'll be defining a constant called pi and doing some calculation around it. And then we'll be writing another program to find area of circle by passing an argument to a macro. So this will be like logic will be same, but there would be two variants of how to use macros preprocessors. So let's get started. So let's create a file for this. area so let's define hash define pi as 3.14, define some constant and main. Okay, so let me have a variable called radius. Let's take an input from user and one more variable float which says area. Okay, so let's take the input from the user. Radius printf slash n area of circle is, sorry, with radius percentage d is percentage f. Okay, so let's try to run the program. So program is compiled successfully. So enter the radius of a circle, let me give 2. So area of a circle with radius 2 is equal to 12.56. Okay, so here what it is doing is it is calculating the area based on the formula which we have given, which is equal to pi r square, pi into r into r. So this is how we use macro or a constant kind of thing, where pi is declared as constant, and wherever we use pi, it will be used as 3.14 throughout our program. Okay, so let's try one more variant where we write one more macro and we give input as input as a input parameter to the macro, and let the macro give us the value. For example, we'll not be using this formula in our main function, but macro will calculate this for us. Okay, so let's try one more variant for this. Yeah, of circle stdio.h info x into x
Just a quick info, guys. Test your knowledge of C programming by answering this question. Which of the following facilities does C programming provide? A. Input and output facility. B. No input and output facilities. C. Input facility. D. Output facility. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
So here what we are doing is we are defining a function kind of thing where whenever we call area with some value, it will give us the area of circle. Okay, so let me call it area of circle. So to be more precise, whenever we call area of circle with value x, it will give us the calculated value. So int main 0 radius printf enter radius of circle scanf which ampersand float variable area of circle radius. So it's like kind of a calling a function. Okay, this will calculate the area for us. Then printf so session. Okay, area. Okay, so this will be giving us area of a circle using a macro and passing the value of radius in a macro. Let me try to run the program. Area macro. Okay, so enter the radius of circle 2. So it gave area of a circle with radius 2 is 12.56. So this is how we use macro in C. This is how we use the macro as a where pi is used as a constant, and we calculate calculate the area in main function. And this is how we define a function called area, and we calculate the area of a circle using a macro function. What is an array? Array is a type of data structure. Why we call array is a data structure? Because it has a pattern of storing a data. Array stores a similar kind of data structure in a sequential manner. So if you are storing an integers in an array, the array will store all the integers in a sequential manner in a continuous memory location. For example, if you can see this example, here we have an array of integers where integers are stored in continuous location next to each other. 6, 7, 10, 32, 44, 5, 1, 4, 3. All these are integers which are stored in continuous memory locations, and this is called array. Array also has one more property, that it stores uh, elements of same type. So array cannot have integer and float data type in a mixed fashion, you have to have only a single data type or same data type in an array. So how to declare an array? Array can be declared in this manner. First you need to give the data type, what kind of data you want to store in an array, name of the variable, name of the array, open square bracket, size of the array, and close square bracket. For example, if you want to declare an integer array, you need to say int, then you need to give the name of the array. Here the name of the array is numbers, then this is the size of the array, 10 is the size of the array. Similarly, if you want to have a float array, then give it as float, name of the array is values, and 5 is the size of the array. For characters, name is the variable name, and 6 is the size of the array. So how to initialize the array? So array initialization can be done in two ways. First, we touch about inline initialization. The inline initialization is shown like this. You can have array declaration, for example int numbers 10, where you are specifying that your array will be having 10 elements and you will be giving values. So you will be giving 10 integers, so each integer will be stored as shown in the first slide like this. Each element will be stored like this. So first element will be stored at 0th position, second element will be stored at 1 position, third element will be stored at second position, and so on. Another type of initialization is where you don't give the size of the array. In this way, the array will automatically check or automatically initialize to the size of number of elements that we have given. So for example, we have given 10 elements here, so automatically the size of the array will be 10. For dynamic initialization, we need to do something like this. We have to declare an array. Say we have declared an array called ARR as an integer type, and we will be having a for loop, and for loop will ask user to enter the number, and that number will be stored in the array. One thing to point out is which is very important when we are learning the concept of array, is that every element in an array starts with 0 and the last element of the array will be size minus 1. Here size is the total number of elements in the array. So in this example, the first element is at the 0th position, the last element, which is the 10th element, is at the 9th position, which is 10 minus 1. So first and if you want to access third element, you need to give 3 minus 1, which is 2. So second position will be having the third element. So how to access an array element? Array element can be accessed with a subscript. A subscript is nothing but a number inside the square bracket. So suppose you have declared an array with ARR. So to access the third element of the array, you need to give ARR 2. So this will give you the third element of the array. So let's write a program to input 10 elements in the array and print it in a reverse order. Let's do some practical session. So here I am using Linux VI editor, vim array1.c. Let me give my file name as array1.c. Let's start with putting some documentation. Program to input array and print it in reverse order. Okay, let's include stdio.h. let's declare the main method. Let's declare the main method as this, like this, and returning 0. Let's declare the array, say 10. Size of the array is 10. Let's declare an int which can be used as a loop counter. Okay, I'm writing one loop. So printf enter in position %d, which is say I. Okay, I do scanf %d of I. Okay, so this will help me out in initializing my array. Now I'll be printing the array in reverse order. So before that, let me have some printf statement. Next line, array in reverse order. Int I equal to 9, I greater than 0, I minus minus. So this loop will be continued from 0 to 9. Then we'll be doing printf %d arr of I. Okay, let's save this. Let's compile this. So compilation is success. Let's run this. So okay, it's asking me to enter the array at position 1. I'm saying 5, 7, 3, 7, 8, 9, 4, 3, 7, anything I can give, and this prints my array in reverse order. So if you can see, this is the order in which I have entered my number, and this is the order in which it is printed. So this is the mechanism of printing the number. It does not reverse the array, but we have printed array in reverse order. So bound checkings. In C, there is no check to see if your subscript used in array exceeds the size of the array. So as I mentioned earlier, uh, the arrays are stored in sequential in a continuous memory location. So in C, we don't know, or there is nothing, any built-in function or any preprocessors provided to check whether the array size, what is the size of the array. So to do that, you need to do some manual coding. For example, you need to have some uh, variables saying size of the array, something like that, and you need to work around it so that you make sure you don't go beyond the size of the array. So in case you entered some subscript which is exceeding the size of the array, this will simply be placed in the memory location which is outside the memory location of array, and probably you will not get the proper data. It may give some unexpected results, or it may give some garbage value, it could lead your computer program to hang. Okay, so for example, if this is my array is of size 5. I have given numbers as 3, 2, 1, 4, 5. If I want to access a ARR of 4, I'll be getting 5, because by giving this subscript, this is pointing to the last element of the array, and I'm getting. But if I say ARR of 5, which means it is the scope of this is outside the array, so I don't know what element what value it will pick. It will not give any error, but it will give some wrong value or some garbage value, which is not useful for my program. So before working with array, you just make sure that you have proper you have things in place where you don't go beyond the size of the array. So pass by value and pass by reference. Passing an array to a function, this can be done by two ways: pass by value and pass by reference. Pass by value means we'll be having some function which will accept the type of data type, a single data type. For example, in this we are having an integer array, and we are having a function func, and this accepts integer type. Pass by value always passes the array or element of the array one by one. It does not pass the whole array. Pass by reference is using pass by reference, we can pass the entire array into the function. So if I have declared an array of size 5, and I have function func, and this function accepts the array, I can pass my array completely into the function and work accordingly. The difference is like whenever I'm passing the complete array to the function using pass by reference, this function may change the content of the array, so we have to be very careful while working with pass by reference. So let's write some code for pass by value and pass by function. So I'm clicking on file, array2.c. I'm giving some documentation example or pass by value, pass by reference. Okay, let me include stdio.h. and I'll having method declaration. Func1 will be passed by value. Func2 will be passed by reference. Okay, main. Okay, let me declare an array size say 5. Okay, then I'll be let me have here I'm printing whatever I have received. Percentage d. Well, now here I am using func2, defining it, reference size. So here I'll be having one integer for and having one loop. Okay. Here I'm printing the values. Here it is like stage D. This is also a pointer way of okay. This is the way of referring an array element using pointers. So in case you're not able to understand, just don't worry about it. We'll be covering this in pointer section, in a section where we are doing pointers in C. But at this point of time, just see that this is how we'll be using it. Okay, now I'll be using this in the main function. Func1 ARR of, say, I'm giving 3, and say func2 ARR of, I'm giving ARR, and size is 5. Let me have a printf in between so that we will be printing this in a separate line, otherwise the output will not be very clear. So be putting next line so that okay, so received value 5, this is func1, okay, and this is func2, where in func1 we are passing the value of third element of fourth element of the array, and in func2 we are passing the entire array. So this is a very minimal example of how we use pass by value, how we pass the array into function using pass by value and pass by reference. So multi-dimensional arrays. So what are multi-dimensional arrays? C programming language allows programmer to create arrays of array. So multi-dimensional array is nothing but arrays of array. What do you mean by arrays of array? Arrays of array is if you see this picture, here we are having 4 single dimensional array. This is one single dimensional array, this is one single dimensional array, this is one single dimensional array, and this is one single dimensional array. So if we combine all those 4 single dimensional array, we will be having a tabular kind of structure, which is nothing but a multi-dimensional array, or in precise a 2-dimensional array. So in short, arrays of array will lead to a multi-dimensional array. Okay, so if you see, if you want to access the element, you have to access in row and column wise, where row will come first and column will come second. So this element is first element of the first array. That means first array will be always be the row wise, and which element we have to access will be column wise. So first row, if you want to access element in first row and third column, so it will always be first row, third column. This will be the this is how you can access. You need to give a of 0 and 3. So how to use multi-dimensional array? So we are covering 2-dimensional array here. In this program, this is how we can declare a 2-dimensional array. It's like integer, it's a data type, array, and then we have to declare how many rows we want, how many columns we want. Okay, so for example, I am writing this main function. This is I am declaring row as 5, column as 5. Now here I am declaring a two-dimensional array. This two-dimensional array will result in this 5 rows and 5 columns, and I can write two for loops. One loop will iterate through the row and other loop will iterate through the column, and I can initialize my array. Okay, so let's write a simple program to do this. I'm creating a file. Okay, let's start with documentation. Let's declare preprocessors studio.h. Let's write main function. To return type. Okay, now let's define rows, say 3, columns say 2, array say row column. Okay, I'm defining I and j. For I equal to 0, I less than row, I plus plus. Okay, this will iterate through the row. For j equal to 0, j is less than column, j plus plus. This will iterate through the columns. Then it's a printf. Enter the value at row %d, column %d, I j, scanf %d, and of arr I j. Okay, now let's print the, this is how we can get an input. Now let's print it. Again we need two loops, I is then row, I plus plus. For j equal to 0, j is less than column, j plus plus. Printf %d arr of I and of j. I'm adding a printf here. I'm adding an extra line so that okay, let's compile it. Let's run it. Again it asks me the input. Give some values. Okay, so this is how it is printed. So this is my two-dimensional array of 3 rows and 2 columns. Okay, and the way to access is like this. It's a very simple program.
Just a quick info, guys. If you want to make a career in software engineering, then Intellipaat provides an advanced certification program on software engineering and application development by ENICT Council of IIT Guwahati. And it is taught by IIT Guwahati professors and industry experts. This course is designed to upskill and land your dream job. Now let's continue with the session.
Just a quick info, guys. Test your knowledge of C programming by answering this question. Which of the following is not a data type? A. Float. B. Int. C. Real. D. Imaginary. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
So we have covered multidimensional array. So let's do some practice. We will solve some programs related to arrays. So let's write a program to print the largest and smallest element in an array. Okay, let's create a file. Okay, let's write program to print smallest and largest element in an array. Let me include stdio.h. stdio.h. Let me have main method. Return 0. Okay, define the array. Let me define one array. Okay, let us take input from user. Printf enter value at position %d, which is I, scanf %d, and of arr I. Okay, now I'll be declaring two variables, min, max. Let me first find out the minimum element, min equal to arr. Let me initialize min element with the first element of array, I less than 10, I plus plus. So what we'll be doing is we'll be going through the array, and as and when we found any element which is less than min, we'll be assigning that element to min. So, and at the end of once we complete the scanning of array, we'll be having the minimum element. Okay, so we'll be writing an if condition. If min is less than or arr I is less than min, then min equal to arr of I. Okay, similarly for max, again we initialize it with the first position of array. We'll be running a loop, then I plus plus. Now here we'll be checking if max is or ARR of I is greater than max, then we'll be assigning max equal to ARR of I. Okay, so this way we will be finding min and max. Let's print the result. Slash n min array is percentage d and max is percentage d slash n min max. Okay, let's save the program. Let's compile it. GCC -o 4 4.c. Okay, program compiled successfully. Let's run the program. Okay, we need to give some values. Okay, we can give any value. So here it says that the minimum element in an array is 3 and maximum is 546. As you can see from here, it's very easy to find it out. So let's revisit the program. So here in the program we have used two loops. One loop to find the minimum element, one loop to find the maximum element. So let's put some thoughts on how to improve the program. So one way to do is not to use the two loops, but to make this condition also part of this loop. Okay, let's do this. I'll be writing max equal to error max equal to min equal to error 0. Okay, so if error of I is greater than max, then max equal to error of I. Okay, so here now we don't require this piece of code, so I'm commenting it. I'm not deleting it, but commenting it. Okay, let's compile it. Compilation is successful. Let's run it. Again, I need to enter some values. So here again I'm getting the minimum element in an array is 4 and maximum is. So this is how we can improve our program. So let's do one more program. Write a program to print sum of all elements in an array. So again let's create so one file. Let's see, this will be finding sum of elements of an array including stdio.h. main, let me declare an array, set n, let me initialize it so that we'll save some time. 534, this So we have initialized the array. Let's cross check. We have 10 elements. 1 2 3 4 8 9 10. Yes, we have 10 elements. Now we have some counter. We have variable which is sum. Initialize to 0. For I equal to 0, I is less than sum. Sorry, I is less than 10. I plus plus sum plus equal to ARR of I. Okay, let me print it. The result, sum of ARR is percentage D slash n sum. Okay, this is a very simple program. Let's save it, compile it. Okay, compilations. Okay, we have forgot to give the output file. Let's compile it again. Okay, now sum of array is, let me clear the screen and run. So here we will get the sum of an array. So using this program we can see how to access the element of array and do some logic around it. Okay, so let's do one more program. Write a program to reverse an array. So here we are reversing the elements in an array. We are not printing the array in reverse order, but changing the elements inside the array. Okay, let's write the code. Okay, reverse an array. Let's include stdio.h. main method. Let me return 0. Okay, let's declare an array. Okay, let me declare it. Okay, I have declared an array. So what I will be doing is I'll be having two variables in front and rear. Okay, front will be at the first position, rear will be at the end of the array. So we'll be having one variable size temp. So we'll be exchanging front and rear element of the array. We'll be looping around it until and unless front is greater than rear. Got it? So we'll be having some while loop while front is less than rear. Okay, temp equal to ARR of front, ARR of front equal to ARR of rear, ARR of rear equal to temp. Here we are exchanging the values of front and rear. Now we'll increment front and decrement rear. Okay, now we'll print the array again for let's have an integer, then I plus plus printf slash n percentage d. Let's have arr of I. Okay, and this will use some extra space at the end of the program. So again, I'll revisit the logic. We'll be having two variables. One is pointing to first element of the array, and rear, which is pointing to the last element of the array. And we'll be having a loop until front is less than rear, and then we'll be exchanging the values of front and rear. So this and once we have done one exchange, we'll be incrementing front and decrementing rear. So first we'll exchange 4 and 58, then I'll increment front, so front will point to this. I'll decrement rear, so rear will point to this. Then we'll exchange 5 and 6. I've not added comma, I have added dot instead. So let's do it again. Yes, compilation is successful. So this is the output of the program. We are accessing array from first element till last element, but we have reversed the array. So here we exchange the values of the array. Okay, let's begin with what are strings. So the strings in C language is a one-dimensional array of characters, and these one-dimensional array is terminated by a null character or /0. So this is a null character. Okay. To hold a character at the end of the array, the size of character containing the string is one more than the number of characters in the word. For example, if you are storing hello, then you need the character string of length 6, because it will be storing HELLO and the null character. So the total number of characters that will be stored when you are initializing a string, say hello, is 6. Similarly, you can initialize the string as hello. In this case, the compiler will automatically put the null character at the end of the array. One more thing is the data type string is not supported in C. If you want to use operations in C, you need to use the character array. Throughout the course, we will be using the character array and assuming that it is a string. So this is how the memory representation of string that actually is stored. As we have already discussed in arrays, like arrays is each and every element is stored in array is in sequential order, and it starts with 0. So here it's a character array in this case, and it starts with 0 character 0 in index 0. H is stored at index 0, 1 is stored at E is stored at index 1. Similarly LLO, and each index has an address associated with it. So how we will be using the addresses and all, we will be covering in a section called pointers, but there is some address associated with the variable. Okay, so let's do some practice. Let's write a very simple code to print a string in a C program. Okay, here I am creating a sample C file. Okay, sample program to print string in C. Okay, hash float stdio.h and main return 0. Okay, let me take a character array, character of say 6, and I'll give a name str equal to h e l l o and a null character. Okay, let's try to print it. So for printing we will be using %s, and we'll be giving one /n, and we'll saying str. So str will be printed in place of %s. Let's save this program and compile it. Compilation is successful. So let's run it. Let's run it strings.c, and it prints my output as hello. So just now we have seen how we can print a string in our program. So these are the operations that are possible in the C. This is an exhaustive table which says that what all operations are possible in the with the strings. So first operation is strlen, in which it accepts s1, and this returns the length of the string. So let's do the example side by side, and it will give us more understanding on how the strings are working. So let's try to use strlen in our program. Okay, let's use it. Okay, I'm modifying the same program only so that we don't have to write it again and again. One more thing is, to use the string functions you need to include strings.h. Now let's include string.h. Okay, so let's say printing using trlen. Okay, so printf length of string is percent. It will give me an integer %d str alien, and then I'll give the name str. Okay, let me give a /n. Okay, let me compile the program. So instead of %d we need to use %lu. So this will give me length of the string. Let me save it, compile it. Yes, I got a compilation success. Let me run it again. So here is the output. Length of the string is 5. So this is how we use strlen. Let's revisit the code. So if you want to use strlen, this is how you can use. If you want to print the length, you can print it as LU, or you can define an integer and take the length in that integer and print that integer. Either way is good. Okay. So next function is strcpy. This copies string s2 into s1. So suppose we have two strings s1 and s2. S2 is some string, and if you use this strcpy, it will copy s2 to s1. Okay, let's write the code for this. We'll be modifying the same file. Okay, let me declare one more character array, str2 with say length 6. Okay, then I use strcpy. I want str2 to have str. Okay, so str, the content of str will be copied to str2. Let's print the string str2. So printf, yes, percentage s. Okay, let's save it, compile it. Compilation is successful. Let's run it. So here, this is the output that we want. The string to str2 is hello. So strcpy copies string hello to str2. Okay, so let's use one more function, str and cpy. It copies the characters of string s2 to another string s1 up to the specified length. Okay, so whatever length we want to specify, it will specify, it will copy, provided str2 is bigger than the bigger than n. Okay, so let's use this function. So this is how strncpy is used. It requires the destination, the source, and till how many characters it has to recopy. Okay, and here I am printing the value of str3. Okay, so let's run the program and see what is the output of this program. Okay, compilation is successful. Let me run it. So after str and cpy, the str3 is HELL HELLO. So it copies the first four characters and whatever we have given, and then the complete string. Okay.
Just a quick info, guys. Test your knowledge of C programming by answering this question. Which of the following facilities does C programming provide? A. Input and output facility. B. No input and output facilities. C. Input facility. D. Output facility. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
So next function is strcmp. It compares two strings, and this function determines if two strings are equal or not. If both the strings are equal, if s1 and s2 are equal, it will return 0. If s1 is greater, if s1 is less than s2, it will return a negative value. If s1 is greater than s2, it will return a positive value. Okay, so the comparison is based on the uh, appearance of the character in the string. Suppose a and b. So if I use strcmp a b, it will give me a negative value because a comes first and b comes after a, so it will give me a negative value. If I compare strcmp b comma a, it will give me a positive value. If I compare strcmp a comma a, it will give me a value equal to 0 because both the strings are same. Stricmp compares two string s1 and s1 and s2. This function does not determine between the uppercase and lowercase. So this function works same as strcmp, but it will be a case insensitive comparison. So capital A and small a will be considered as same. So we will not, if you want LWR, that is string lower. So if I am having a string called capital A, capital B, capital C, and I say str LWR S1, I'll be getting small a, small b, small c. Similarly, str UPR, it converts a given string to an uppercase. Str DUP, this function duplicates the string S1 at the allocated memory, which is pointed by the pointer variable. Suppose you want same string again, like hello, you want to have a copy of hello, you can use strdup. Strchr, this returns the pointer to the first occurrence of the character in C. Like it gives, if I have a very long string, and if I say strchr and want to search a particular character, it will give me the first occurrence of the character. strcat s1 s2, it will concatenate the string s2 at the end of s1. I have missed this. strrchr, it returns the pointer to last occurrence of the character. So these two are kind of same, but strchr returns the first appearance of character C. strrchr returns the last occurrence. strcat will concatenate s2 to s1. strncat s1 s2 and concatenates s2 to s1 up till n characters. strrev, this is very important function, it reverses the string s1. So if you want to have a reverse of a string, it reverses the string s1. str s1 s2 returns a pointer to first occurrence of s2 in s1. So if you see here, this compares the character, but this function compares the string. So if you have a very long string s1 and you are given a very small string s2 and you want to find the first occurrence of s2 in s1, you can use this function str. Okay, so these are the exhaustive operations that you can perform in the strings, and all of these are kind of self-explanatory, and we will be using some of these in the program that we will be doing right now, and it will give you much more idea on how we use strings in C. So let's consider this example. I have added stdio.h, string.h, main. So str1 with of length 12, I am saying hello. str2 of length 12, I am saying word. str3 of length 12, I am not initializing it, taking a variable len. So if I say strcpy, str3, str1, so it will copy str1 to str3. So if I print str3, it will give me a value say hello. Okay. Similarly, strcat, if I say strcat, str1, str2, so what will be my output? My output will be hello world, because str2 is added after str1. My str1 is hello, my str2 is world, so I'll be getting an output says hello world. Okay, if I print this output, len will give, if I do strlen, I'll be getting the length of string, so I can print it like that. So this is the small set of operations that we can do in strings. exhaustive list is here. You can pick up any function, write it, and see it how it runs and how you can get the result out of it. So let's solve some problems. Write a program to check if a given number is a palindrome or not. So palindrome is a string which is having a special character wherein when the string is reversed, both the original and the reversed string are same. Okay, so for example, if I'm writing a string, say ABA, so ABA is a palindrome. Why? Because if I reverse ABA, it will again give me a same string ABA. So we will be writing a program to check if a given string is a palindrome or not. So let's write a program. So problem2.c palindrome. Zero. Okay, let's have a character str. Enter the string. Scanf percentages str. So let's have a length of the string. Alien. Please give me the length of the string. Okay, let me have two variables, int start, int end. I'll initiate start is equal to 0, then end equal to len minus 1. Okay, so while start is less than or equal to len, if str of start equal to str of end. So let's have a negative condition, then say int result equal to 0. Let me have a result declared as 0. I'll result equal to 1, then I'll break out of loop and then print result equal to 0, printf given string is palindrome, else printf given string is not palindrome, printf, let me have a slash n at the end. Okay, so what we are doing in this code, we are first we are getting an input from the user in str, which is character array. Then we have declared few variables. One is len, one is start, and one is end. I am initializing start with 0. Len, I am having array, not array length. Here I am getting a length of the string. I am initializing end equal to length minus 1. So I'll be starting with last element, which is always length minus 1. So I will be having two variables, start and end. Start will point to the 0th element, end will point to the last element, and then I am comparing if start element is equal to end element. I am running one loop. So if in any point of time the start element is not equal to end element, okay, then I am breaking out of the loop. That means, and saying that the string is not palindrome. I am identifying it with the result. Initially I am declaring the result as 0. If in case I didn't find this condition is satisfied, I'll be saying that my string is not palindrome. One more thing I will add, I'll increment start and decrement end, so that I will may not end up in infinite loop. Let me run it. So let me compile and run the program. Compilation is successful. Let me run it. I'll be giving a string a, b, c. So given a string is not a palindrome. Yes, abc is not a palindrome, because if I reverse abc, it will become cba, and it is not a palindrome. Let me run it again. I will be giving a, b, a. Yes, the given string is a palindrome. So this way I can check whether string is a palindrome or not. Also, with this code, this will give me a very good idea how to write my own string functions. So suppose if you are asked to write your own strrev functions, for example, you are working in some platform which does not support all the string functions, and you want to use strrev function in some of your problem, and if you don't have a ready-made program, you have to write it. So this is how you can see how you can write a existing function. Existing functions are nothing but some pre-written functions which we can use again and again, but if the function is not provided, you need to write it, which is a very known practice in software engineering. So I hope this gives you a very clear understanding of how to write inbuilt functions. Let's do one more program. Write a program to print a given string rotated n number of times. So what is the meaning of rotation? If suppose you are given a string abc, so when abc rotated one time, it will become cab. That means a will come to b's place, b will come to c's place, and c will come to a's place. So let's write the code to rotate a string at a given number of times. Okay, so
Just a quick info, guys. If you want to make a career in software engineering, then Intellipaat provides an advanced certification program on software engineering and application development by ENICT Council of IIT Guwahati. And it is taught by IIT Guwahati professors and industry experts. This course is designed to upskill and land your dream job. Now let's continue with the session.
let's write a code for this. hash include including string.h into main. Let's return 0. String character, let's take it as 10. Printf, enter the string, scanf, %s, str. Okay, let's have one more variable, say int n, enter how many times you want string to be rotated. Scanf %d %n. So let's understand this. We are inputting the, at this point of time we're just inputting the string and value of n. N is nothing but an input of number of times the string being rotated. Okay, let's take another character string, which is say character str2. This will be our resultant string. Okay, so also take one more integer for running a loop. Okay, let's have one more integer, length. So length equal to len of str, string length of str. Okay, now what we are doing is we are rotating the string and storing it into str2. That's why we have taken str2. I have taken to run a loop, because we will be requiring to run a loop, and length, we are storing the length of the string str. Okay, so let's write the code for int I equal to, for I equal to 0, I less than len, I plus plus. So what we have to do, let's build our logic. So if I have to rotate it with n times, so the new position of my character will be, let me take one more variable, int new position. Let me take a short name p. You can take long name also, but just to simplify, I am taking p. P equal to, it should be equal to I plus how many times you want to rotate, it's n. Okay, and taking a mod with length. So if I want to rotate any string by n number of times, I'll be adding the character position with number of times I want to rotate, and take a modulus operation with length. So resultant of the current character in new string. So str2 of p will be equal to str of I. Okay, now let's give a slash null character to str2. str2 of length equal to null character, like string termination. So let me print it. Rotate it. String is percentage %s str2. So let's compile and run this code. gcc -o problem3 problem3.c. Okay, let me run the code. Enter the string. Let me say abc. How many times I want to rotate it? Say 1. So the resultant string is CAB. So A will come to position B here, B will come to position C here, C will come to position. Let's take one more string, with one short string, say hello, and I want to rotate it 3 times. So here's the result. H will come to else place, E will come to O's place, and O will come and L will come to E's place. Again this one come to H place, and O will come to else place. So this is how we write the code. So let me give one more walkthrough with this code. We are taking one string character array where we are inputting a string n number of times we want to rotate the string. This is the resultant string. I is an integer that we have taken so that we can run a loop. Length, which will be storing a string length. P is nothing but an offset kind of thing, where this will be the new position of the current character in string 1. Okay, so this is how we are taking the input. We are running a loop. So what will be the new position? New position will be equal to current position plus n and modulus operation with length. This will give me the new position, and I'll be getting the result. So we have completed these 2 examples. So let's start with structures. So what is a structure? A structure is a user defined data type, which is collection of different data types to store a particular type of record. So assume it is a collection of the already defined data types. For example, if you want to have your own data type which has one integer, one character, one float to perform some operation, then structure is an answer to your question. I will give you one more example. For example, you want to maintain a student record of a school where each record contains a student name and student age and student roll number, etc. So we can solve this problem by using structure, where we can define our own data type called student record, and each record will have name, age and roll number, and so that we can work based on the data. Let's continue. To access a structure member in C, structure variable should be declared. So we should declare a structure variable. We'll see how to do that. Many structure variables can be declared for same structure, and memory will be allocated to each separately. So we just need to define a structure that we will be using this structure, and we can use n number of structure variables, and the memory for each structure variable will be allocated separately. And also it is a best practice to initialize the structure to null while declaring if not assigned any value to structure member. So if we are not using any structure variable, it's always good to initialize it by null so that it won't be having any garbage value. So what is the difference between structure and array? The difference between structure and array is that array is used to store a collection of similar data types. So I can have a array of 10 integers, but all the 10 elements should be integers. While structure can store collection of any data type. So I can have one integer, one float, one character, one long, one double, and so on. I can have multiple integers, multiple floats. So it's up to us how we define how we can have how we want to define our structure. So that is how that there is a difference in structure and array. So array stores similar type of data or same data type. Structure can store different data types or whatever we want. So declaring a structure keyword is used to define a struct keyword. This is a keyword that is used to define a structure. It is a data type which is a collection of different data types. So struct is nothing but a collection of different data types. So here is example. It's a struct, okay, structure name and data type and variable name, data type value. So data type could be int, char, long, float. The structure will be referenced by this name, structure name. Structure variable declared using normal variable as structure name. So if you want to use a structure or want to declare a structure, we have to use this name. We have to use this name to declare the variable structure variables. So this is the example. This is a structure of a student record. So this is our user defined structure. So this structure has integer which is saying marks. This structure also has a character array which says name and a float which says average. So this is a structure, and how we can define a structure in or how we can declare a structure in our program is like struct student and report. So this is our variable name and this is the data type.
Just a quick info, guys. Test your knowledge of C programming by answering this question. Which of the following is not a data type? A. Float. B. Int. C. Real. D. Imaginary. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
Initializing and accessing structure variables. So let's see how we can do that. So there are here we are touching upon two types of structure. Two types. Like one is a normal structure, which is a normal variable. One is a pointer variable. So let's see how the normal normal variable or normal structure variable is used. So report equal to, this is how we can initialize 100 AVI 99.5. So this is 100 is mark or marks, whatever we can say. AVI is the name and 99.5 is the average. If you want to use a pointer, we can do it like this. At this point of time you can ignore it, but if we declare it like this, then this variable will be storing the address of structure. So just say that there is some address associated with the structure, and pointers stores the address. So accessing is using normal variable. So how we can access the data? If you want to check marks, then you can say report.mark. If you want to get a name, then you can say report.name. If you want to say if you want to get average, then you can say report.average. To access the entities inside structure in using pointer variable, you need to have you need to use special type of operator which is called an arrow operator, and we can use like rep arrow mark, rep arrow name, and like this we can use. In this session we are mostly touching upon normal variables. Will not be uh, using any pointer variable. So array of structure, this is a very basic code of how we can use the array of structure. So let's go through the code. First I am declaring or I am including our preprocessors, and so here I am including stdio.h and string.h. This is how I am defining my structure. So a structure is having integer, character, and float. So in integer ID I can store anything. I can store roll number or student number or whatever I want. In this I can store character array, so this could be very feasible to store names. Floating variables say percentage, so what is the percentage student, percentage marks in the last subject, or average marks in all subjects, so that we can take. Let's see how we use it in main function. So integer I, now we declared a structure array struct student. So struct student, struct says that it's a structure, it's a student type of structure, and this is a variable name. Okay, and this is of the variable is of type array, and the size is 2. Okay, now in the first position, like record 0 dot id, so this is the first structure. We'll be initializing it as 1, and then copying abc into the name percentage as 86.5. Second element of the structure, id equal to 2, name we are copying it with xyz, and percentage with 90.5. So this is how we can use structure array. We can use loops also, or we can use n number of types of n number of ways of using arrays. So passing a structure in a functions, structure can also be passed in a function, and we can use the structure in that function. So let's see how we can do that. Consider this example. So we are having this structure, same structure, int id, character name, and float percentage. Now we have a function, void function, which accepts a structure. So struct structure of type student, variable name is record. Okay, so now how we are using this structure in a function is we are just doing printf. Okay, so let's suppose we want to we have declared a lot of structure, or structure is having lot of variables, and we want to print the structure. So we can declare a function that can print the value of structure. Let's see the main function. In main function we have declared one structure, struct student record, record.id equal to 1. We are copying abc into the name, percentage we are making it as 86.5. then we are calling this function. Once we call this function, the control goes here, and it will start printing the data inside the structure. So what will be the output of the function, output of the program. The output is of the program is this, whatever is printed by the function func. So the output is id is whatever we have given the id. Say id is 1, name is abc, percentage is 86.5. So this will be the output of our program. Nested structure. So we can have structure inside a structure. That is like, suppose our demand is to have very complicated structure like this, where we have student record. In student record we have student name, student age, and then we have a student address. So again, address is another type of structure, so we can declare address as the locality, which city, pin code, and also it is normal, or it depends upon how our, what is the problem that we want to solve. Do we want to have a nested structure or not? So if you want to declare, or if you want to use a nested structure, we can use like this. So if you want to access the locality, what we have to do is, whatever variable we have declared, for example, we have declared struct student um, abc. Okay, then if you want to address check the locality, how we can do is abc dot address dot locality. So this is how we can check. Let's move ahead. When we talk in uh, structure point of view, so type def is a keyword used to assign alternative name to existing types. So if you want to give a some name to our structure, or some alias to our structure, type def can help us out. It is very common when while using the structures, because defining a structure is a very like, you need to write a lot of characters. First you need to write struct, then what type of structure it is, and then the variable name. If we declare a type def, like if we declare an alias to the structure, then we can remove the dependency on writing struct and the type of structure. We can just use the alias and variable name. So let's see how to use the type def. Here we are using type def. Again, I'm including the preprocessors, then type def. Okay, I'm defining or aliasing this structure. So type def struct employee. I'm declaring a structure of type employee. Employee is having a name and a salary, and I am making the alias as emp. Now in the main function, how I can use this emp e1. So emp is nothing but struct employee. So instead of writing struct employee again and again, it is easier to write emp e1, and it is easier to refer this in our program and read it in our program. So emp is nothing but an alias to our alias to this structure, and this only helps in declaration part. Usage part will remain the same. So what is union? Union is also similar to structure. It is a collection of different data types which is grouped together. Each element in union is called a member. So anything inside a union is called a member of union. Okay. So union allocates one common storage space for all its member. Uh, as compared to structure, structure allocates memory for its member, or for the entities separately. So what how number of entities inside the structure is So the size of the structure depends upon the number of entities inside the structure. But in union, the size of union is dependent upon the biggest member inside the union. So suppose we have declared two members inside the union. One is say int, another is say float. So the size of the structure will be equal to the size of float. Sorry, size of union will be equal to size of float. So that's how we use union. We can access only one member of union at a time because union allocates one common storage space for all its members. Many union variables are created in a program and memory will be allocated for each union member. Union variable separately. So yes, we can use many variables of union, but for each union, the size of memory is equal to the biggest member in the union. So this is the example that we use in the union. So union is again same. It is almost similar as declaring a structure. Instead of struct, we use unions. Okay. Then we declare two variable, record one, record two. So then we are copying name and name and subject inside the record one percentage equal to 86.5. Okay, union values example. Then again we are printing it. Okay, now we are again initializing or printing the name as record to dot name, copying a subject, printing a subject, and then assigning a percentage to record to and then printing it. So what will be the output of the program? The output of the program will be something like this. One correction is the subject will come here, physics. Okay. So this is the difference between structure and union. Structure allocates storage space for all its members separately, whereas union has a common storage space which is equal to the biggest member of the union. Structure occupies more memory space, union occupies less memory space, obviously, because structure allocates storage space for all its members, union allocates memory space for only one member. All members of structure are accessible at a time, but in union only one member is accessible at a time. This is because again related to memory, where structure can allocate memory to all its member, but union cannot do that. That's why we can access only one element at a time in union. So this is how we declare structure and this is how we declare union. So memory allocation of for the above example. So how much memory will be allocated? Int will give 2 bytes, character we are using 6 character to so 6 bytes, so 6 plus 2 8 bytes. For the above case where we are using union, it will be equal to the 6 bytes because 6 bytes is the biggest unit. I'll give you one example or I'll give you one problem statement. This is based on the examples that we have seen in this session. The problem is write a program which declares a structure of student records. Field in the structure shall be name, age, roll number. So there are three fields in the structure. Name could be character array, age is integer, roll number is integer. Declare it in an array and take the input from user and initialize each record and then print the record in ascending order of the roll number. So just reshuffle or sort the array or write your own logic or decide on like how will you print those records in ascending order of roll numbers. Okay, so roll number 1 will come first, roll number 2 will come second, 3 will come after 2, and all those stuff. So let's get started. So let's create a file for this program. Let me create a student record.c. Okay, hash include let me have a max value. The max value will be defining how many number of records do we want to have. This will be our counter. Uh, so before that we have to define a structure. So uh, how the structure will be, let's define it. Struct student okay, so name, let's say it has 20 characters max, then age, roll number. Okay, so let's use this structure. Let's define an array of structure. Struct student say s. I'm defining it as uh, number of array elements is equal to whatever is declared in max. So it will be like this. Now let me run a loop equal to 0, I less than max, I plus plus, printf, enter. Scanf percentage s of I dot name. Here we are referring the ith index of this array and the name attribute. Okay, scanf d ampersand of s of I printf roll number of scanf percentage d ampersand s of I at ith position we will be getting roll number. Okay, so this way we'll be getting we'll be initializing the array of structures with the given input by user. Now let's write a loop again to print all the values. Max, I plus plus, okay, so here we'll be giving printf name will be percentage s, age will be percentage d, roll number will be percentage d, and then we'll be printing dot roll number. Okay, so that will be printing in a clear format. Okay, so this is a very simple program to demonstrate how to use the structure. So let's try to compile and run the program. So the program is compiled successfully. Let's run it. So enter the name of student, say I'm giving a only one character. You can give up to 20 characters. Enter the age of student, let's 21. Enter the roll number, say 20, say 1. Okay, so one record is here, the one record is completed. Okay, now this starts printing the second record. So enter the name of student, you can give anything. Enter the name of student, enter age, enter the name of student, age, age, roll number, again age, roll number, again name, or so at this position we have completed our uh, process of getting the input from user, and here we are printing all the records, all the student records. So we can perform any type of operation on the set of records. Here I am just printing it in a user readable format, a kind of a tabular format like this, where name, age and roll number are displayed like this. I'll recommend you to try this example on your own and try multiple variants. Uh, do some do some logic around whatever how whatever you want. Like for example, you can sort the records based on the age, or you can sort the record based on the name, or you can print the record in a reverse order, or find a find a record where uh, name of the student starts with A, and find the record where age of the student is greater than 20 or something like that. So it's up to you. Mm, you can try any combination of this problem, and uh, only by trying this problem you can get more and more understanding on how to use structures and all. So I hope this problem or this example is good enough to uh, make sure that you have a basic understanding of structures. So what is a file? So a file is used for data persistence. So if you want to store some data into memory and use the data for future use, you need to use a file. Files are stored in your permanent memory location, which is your hard disk. To read a file, you need to uh, do some operations on the file. For example, you need to uh, locate where your file is in your hard disk and provide the file path so that you can read it. Functions to handle file IO operations in C. Uh, what all functions we can do? We can create a new file. We can open an existing file. We can read and write on an existing file, and we can close an existing file. So to do a file operation in a particular file, we have to know the absolute path of the file where it is stored in our memory. Then only we can perform the file operation. File pointer is needed to communicate between file and program. So to do any operation in a file, we need to have a pointer of type file. So file is a keyword, and we need to have a pointer of type file to do file operations. This pointer will help us out in doing data manipulation in the file. So all the operations like creating a file, opening a file, reading from a file and closing a file, we can perform all these operations through file pointer. So let's see how to open a file using C program. To open a file, fopen function is used. So there is a function provided by C which is called fopen. We can use that, which returns a file pointer. So fopen returns a file pointer. Once file is opened, the file pointer is used to let compiler perform input-output operations in the file. So once we get the file pointer, any operation that we will be performing in the file pointer will be reflected in the file. So that is why we use a file pointer. The syntax of this function, fopen function, is like this. It requires a constant character pointer file name. A file name is nothing but an absolute path of a file that we want to operate. Anything that we want to operate, we need to have an absolute path and a mode of operation, like it in what mode we can operate that file. For example, we want operations in a read only mode or write only mode, or read write append, or there are various modes in which we can perform operations on file. These are the modes in which file operations can be performed. So R stands for read only mode, so we cannot do any other operation other than reading. W stands for write operations. A is for appending. R plus is open for reading and writing, which is started at the beginning. W plus opens for reading and writing, which is like overriding a file. A plus appends for reading and writing, appending if file exists. Okay. So these are the various modes. It depends upon what we need. We need to specify the mode. For closing a file, we need to use fclose function. So file should be closed after read write operation is done. Any operation that is performed on a file, if we are done with it, we should close the file. We can close the file using fclose function and giving a file pointer to it, so that file can be safely closed and it can be safely transferred to the secondary memory from primary memory. Fclose function returns 0 on success, or EOF if there is any error while closing the file. So if you are performing an fclose function and you get a return value as 0, you know that okay, your file is closed. If you don't get 0 or you get EOF, EOF stands for end of file. Generally, EOF is a keyword that we can use. So if we get EOF while closing a file, that means there is some error while closing a file. We should debug like what happens, or is there anything somebody else is also using that file, so that or any other program or any other process is using that file, then only we can get EOF error. This function actually flushes any data still pending on the buffer to a file, closes the file and releases any memory used for the file. So what the fclose function does is suppose if there is any pending operation which is there in the file, it flushes out the data for that. Like it don't store the file stream or a stream of data for that file. It flushes out every data, or whatever buffer we have allocated for that file. If it flushes out that buffer, it closes the file, and release any memory which is used for the file. So any memory which is used for the file, like file pointer or anything else, it just releases that memory back to the system.
Just a quick info, guys. If you want to make a career in software engineering, then Intellipaat provides an advanced certification program on software engineering and application development by ENICT Council of IIT Guwahati. And it is taught by IIT Guwahati professors and industry experts. This course is designed to upskill and land your dream job. Now let's continue with the session.
Just a quick info, guys. Test your knowledge of C programming by answering this question. Which of the following facilities does C programming provide? A. Input and output facility. B. No input and output facilities. C. Input facility. D. Output facility. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
EOF is a constant defined in a header file stdio.h. So any operation that we need to do, and if we want EOF to be used, we need to include this header file. Reading from a file. So reading from a file can be done in different ways. There are various methods provided in C to read from a file, and each method has a specific purpose. So it depends upon our need. What is our need? Based on our need, we can use a particular function. So first we see what is a getC function. A getC function reads a character from an input file referenced by a file pointer. So a getC reads the file character by character, each character at a time. The return value of character is read, or in case of any error, it returns end of file EOF. So fgetC function will just return continue to read the file character by character, and once it reaches to the end of the file, it gives us or it returns EOF value, so that we can know that okay, we are done with file reading and we can do some operation or close the file. To read a string from a file, we use getS function, fgetS. So this is the syntax of fgetS function. So fgetS function requires a character pointer, which is nothing but a string in C. Number of bytes that we want to use, number of characters that we want to use, like buffer size. It's nothing but a buffer size. A buffer size means number of characters that we want to use in this character buffer or a character array, and a file pointer. So the function getS reads up to n-1 characters from the input. So here we have provided n, that means it reads 0 to n-1 characters of the input stream referenced by file pointer. It copies the read string into the buffer. So whatever it read, it copies this into the character array, appending a null character to terminate the string. So once it is done with reading n-1 characters, it appends a null character, then we can read the file. So that's how we can use fgetS. There is one more function called fscanf, which we can use to read from the file. So fscanf is used function to read string from a file, but it stops reading after the first space character is encountered. So fscanf reads one string at a time. So it ends once it finds any space or tab or anything which is not a character from in a file. So it has different purpose. Suppose we don't know what is the size of a string, and we want to use string by string, we can use fgetS function. If you want to use the buffered approach, we can use fgetS function. If you want to read character by character, we can use fgetC function. So there are various ways where we can do read operation from file, and it depends upon our need, like what is the requirement of our program, and based on our requirement, we can finalize which method we want to use. Writing from a file or writing into a file, a function fputs is used to write into a file. So fputs writes a string to a file or string to a output stream referenced by a file pointer. It returns a non-negative value on success, or else it returns end of file in case of any error. So if any positive value is returned by fputs function, that means we are successful in writing our data to the file pointer. If we get any error, then we will be getting a negative value or EOF. So fprintf is also used to write data into a file. Fprintf function is used to write a string into a file. So what is the syntax of fprintf function? It requires a file pointer, a character array, in which format we want to write the data into a file. Okay, so we need to specify all the formats and all so that we can write into a file using fprintf. So this is the very simple program to read and write from a file. I have used conio.h here, which because we are using getChar function and getC function, so that's why I have used this header file. So let's go through this program. First we are declaring a file pointer and a character, then we are opening a file. So we are using fopen to open a file. We are giving a file name 1.txt. If we don't specify the absolute path, then the compiler takes that your file is stored in same path where your .c file is stored. So in this case 1.txt should be at the same path where this program is present. So in case if it is a different path, we need to provide the complete absolute path. So fopen, then file name and the mode, like write mode. Printf enter data. Okay, now ch equal to getChar, end of file is not equal to end of file. We are putting the character into a file pointer. So until we reach to the end of file, we are putting a character. Okay, then we are closing the file, we are opening the file again, and then we are reading the file. So here we are writing into the file, here we are reading into the file, and once we are done, every time we are closing the file. So here is one more example of reading and writing from file. In this example, we are using fprintf and fscanf function. So what we are doing is we are declaring a structure, file pointer pnq. It opens it opens same file in two mode, one in an append mode, one in an read mode. Then we are getting an input from user, and then we are appending or writing it into the file. See, we are writing fprintf in the pointer p. P is opens a file in the append mode. So we write the data into the file. We write it in this format, %s, %d. So it will write e.name, age. Then we are closing the file. Okay. Now this is the loop to read the file. So we are saying fscanf q. We are reading the file using this pointer, which is read only. we are reading in this format, name, age, and then printing the value to the console. So once we get end of file and get ch, you can ignore this. You should close the file also. Here in this program we don't have fclose function, but we should close the file also after doing the operations. So this is how fprintf and fscanf is used. This is one more example of reading from a file. We are declaring a file pointer equal to fopen. This is the absolute path of the file in a read mode. If the file pointer is null, that means we are having some error. That means file is not present, or we are having some problem in reading the file. We will not proceed any further. In case we are successful, we are reading from the file. We are reading an integer from the file and writing back that integer to the console and closing the file. It's a very simple program. This is one more program to do a file write operation, where we are declaring an integer variable file pointer, opening a file in a write mode, checking if file pointer is null, then we are exiting. We are getting an input from the user, enter n, scanf n, and then we are writing this n into the file and closing the pointer. It's a fairly simple example. So binary operations in the file, binary file IO. For binary file IO, we are using fread and fwrite functions. So functions fread and fwrite are used for reading from and writing to a file on a disk respectively in case of binary files. Okay. Functions fwrite takes 4 arguments. First argument is the address of the file address. Second is size of the data. Okay. Third is number of data or number of bytes to be read. Okay. And fourth is pointer to the file. So opening mode in a binary file are like this. These are the modes in which we can perform operations in the binary file: RB, RB plus, WB, WP plus, AB, AB plus. The only difference between opening mode on a text and binary file is that B is appended to the to indicate that it is binary file. So in the text file we are having mode like R, R plus, W, W plus and all. In binary mode we are appending a B to it. Okay. So fseek, there is one more function called fseek. Fseek function sets the file position indicator to a stream pointed by the stream. So fseek is nothing but it sets our offset or something like if suppose we are reading data from a stream and we want to skip some integer, skip some bytes, we can use fseek to just jump to a particular position and start reading from it. This is the program through which you can use binary IO operation in a file. In this program we have declared a structure. In the structure we have XYZ. Okay, and a counter, a file pointer, and we are declaring one structure. We are initializing a file like .bin file. So all the binary files are like .exe, .bin, or which are having which are non-text files. So we are declaring a file pointer. File name is test.bin in a write mode. Okay, if file pointer, if not of file ptr my file, then what happens is that means there is some error in opening a file, so we can say unable to open a file and we return it, or returns from the program. We don't go further. In case we are successful in opening the file, we are just running a loop from 1 to 10. We are initializing the x value to the counter, and then we do fwrite operation. We are providing the address, like what we want to write. We want to write some structure into the file, size of the structure, and number of number, like we want to write only one structure. We Here one means only one space, or only one memory segment is allocated which can accommodate the complete structure and pointer file. So in this case we are just writing the complete structure to the file, and then once we are done, we are closing it. So this is the operation that we can do in the binary file. So this is file IO is very basic thing in C programming, where we used to do some persistence, and we want to store something. And the operations in file are also fairly simple. We can perform read, write, close, open, and the combination of these operations we can do. Please try all these examples on your own, whatever I have explained, to get more and more understanding of how file works. Let's get started. tdio.h 0. Okay, so let's have a file pointer fp and I'll be opening it in a write plus mode. Now f printf file pointer and some text. Let me use fputs. This will also write some content into the file. This content, let me close the file. So this is how we will be writing it into the file. We'll be creating a file pointer, and then initializing it with the file name. You can give an absolute path or some path. Now if I just give the file name like this, it will create the file in the same folder where my .c file is, and I'm creating it in a and I'm opening it in a write mode, so that I can write the content into the file. First I'm writing some text, like this is a test content using fprintf command, and then I'm writing some other like this is another test content using fputs command. So let me save and compile the program. So this program is compiled successfully. Let me run it. Okay, program is run successfully. Let's check if there is any file called test.txt. Yes, it is there. Let me open it. So this is the content in the test file. This is the test content. This is another test content. So this is how you can use the file, or you can write the content into the file. Okay, so let's write one more program. Write a program to uh, read from the file. So I will be reading the same file. So I'll be reading same test.txt file. So let me write a program for it. First, let's create a file for it. Okay. Hash io.h mean. Okay. Let's have a file pointer. P assign fp to fopen test.txt. Okay, and in a read. Okay, now let's have a buffer. Let's have it with say 256 length. You can give any length that you want. Let's use fscanf. Okay, scanf file pointer vintage s. Here we are reading a string, and then we are reading string into buffer. Okay, so let's print yes buffer. So this is how we will be using fscanf. Let's use one more command. Let's use fgetters. So let me use fgetters like this. So then how much characters do we want to use? So let's give me 256 because our buffer length is 256, and then I have typecast it to file pointer f. So this is how we use fgetters to read the content from the file. And now, sorry, not fprintf, printf. More visible. So what this program will be doing? So this program will be opening a file in a read-only mode, and then we'll be reading a string from the file. So this line will read the first string till it reaches the any space or tab something. So first string will be read from the file and kept into the buffer. Okay, now this statement, what it will be doing, it will be reading the rest of the file till it reaches the end of the line, or till the buffer size is exhausted. So either 256 characters or till it reaches the end of the line. So in this way we will be using both the commands, both the functions fscanf and fgetters. So let's try to uh, run the program. Me see. So program is compiled successfully. Let me run it. So what this program does, it read the first string using scanf. So it prints this, and then it read the rest of the string using fgetS. So this is how we can use file reading operations using scanf and fgetS. So let's see how we store our data in the memory. So computer stores data in memory slots. Each slot has a unique address, and variables store their values in these memory slots. This table shows you how we use the memory slots, how variables are stored in the memory. Uh, Basically, if you see, we have declared two variables here. One is I, and one is we have declared array, and we are referring to the second element of array. So I is equal to 40. So here I is declared. I is declared as 40, and this is the address of I. So this is just a representation of address. This might not be the actual value of the address, but just to make you understand, we are assuming address to be 1000. The address could be different in different systems, so this is not exactly address, but just a reference to it. I mean, just a hypothetical representation of an address. So variable I having value is stored in address 1000. Similarly, a of 2 equal to z. So a of 2 having value z is stored in the address 1006. So this is how we store variables in computer memory. So pointers in C are nothing but they are referring to the address, those memory slots. So whatever memory slots we have here, this one, pointers are used to denote or point to the memory slots or these addresses. Pointer stores the address of any entity. So if you want to store the address of I, suppose I have declared a variable I equal to 40, and I want to know the where I is stored. I can declare a pointer for it, and pointer will help me out in giving me the address of I. So again, just to revisit, pointer stores the address of any other entity. Okay, it refers to a memory location. So here again, this example, I equal to 40, and the address of I is 1000. So if we say any pointer which is pointing to I, it will be nothing but it will be storing the address of I, which is 1000. So pointer stores the address of another entity. That means pointer, in this case, pointer is storing a value of I, and it refers to a memory location. So whichever memory or variable is stored, pointer points to that memory location. Just consider this very small example. Int I equal to 5, we have declared one variable 5. Now this is how we declare the pointer variable with a star over it. So this is an integer type of a pointer.
Just a quick info, guys. Test your knowledge of C programming by answering this question. Which of the following is not a data type? A. Float. B. Int. C. Real. D. Imaginary. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
So this declares a pointer variable. Star is used to declare a pointer variable, and the type of pointer is integer pointer. Pointer ptr equal to ampersand I. Now this ampersand represents the address of I. Okay, so if we want to get the address of any entity, we just have to give it like this, and of I. ampersand. Ampersand points to the address of I. If you say printf star ptr, like pointer equal to percentage d star ptr. So this how we interpret star and we will see later part of this session, but just to as of now, for our understanding, uh, and represents the address of operator and star represents the value of operator. So if suppose I am having a star ptr, like here I am using star ptr, that means I want I want value of ptr. If I am saying and ptr, I am saying it as address of uh, ptr or address of I, whatever it is. So why do we need pointers? Simply because it's there? No. Pointer has some meaning into it, and it is used in many circumstances in C, and it's very helpful. If you have remembered this example, or if any example that we have done in all the previous sessions, we have used scanf a lot, and the uh, syntax of scanf was like something like this: scanf percentage d ampersand I. So basically what does it do is scanf gets the value from user and store it into the value of the variable whatever we have given. So here in this case, if so, the 5 will be stored at the address of I. That's how we that's how we add n% at the while we using scanf function. So what actually is a pointer? A pointer is a variable storing an address. It's very simple. Pointer is a variable storing an address. Pointer is not storing the actual value. So pointer just store the address of a variable. It won't store the value of that. Let's see this example once again. Int I equal to 5. I'm declaring I as 5. Now I'm declaring a pointer, integer type of pointer, integer star ptr. Now I'm assigning a value to the pointer equal to address of I. Okay, how I am reading this ampersand I is pointer equal to address of I. Okay, so here pointer equal to address of I. Printf I equal to percentage d I, printf star ptr equal to now what, how I interpret this? I interpret as value at address of I, value at address of ptr. So value at address of ptr is whatever is stored in I. So value at address of I is 5. So it will print 5. Okay. Similarly, ptr equal to percentage p, and we'll say ptr. If we do like this, it will give whatever is stored here, which is the address of I. Okay. So it will give us the address or the location, physical location of variable I where we have stored it. So this is the output. So this address could be different in different machines. It is just a representation of an address, but every time when if I run a program, I can get a different value. So it is all dependent upon on our system in which we are running. So let's revisit what is ampersand and what is star. So here those ampersand and star are called as a twin operator in pointer. So ampersand is nothing but address of operator. So how I am interpreting ampersand? Ampersand gives me address of anything which is right to ampersand. So here ptr equal to address of j. So what ptr will be storing? ptr will be storing address of j. Here say ptr is storing address of j. Address of j is 1001. So ptr is storing 1001. Okay. Similarly, Star represents dereference operator or value of operator. So if I say value at address of PTR, I'll be getting 99. So suppose PTR equal to 1001, if I'm saying star PTR, that means value at address PTR, value at address 1001 is 99, so I'll be getting a 99. So pointers are also helpful in passing the value by reference. What is pass by reference? So let's consider these two examples. First we will see this example. So we have this function which returns void, function f which accepts j and assign and reassign the value. Okay, now we have another function g where I have assigned one value 3. Okay, if I call f of I, okay, what will be the output? I mean, or what will be the value of I if I call this f of I? Okay, so here let's walk through the code again. Int I equal to 3, I am calling f of I. So in f I am passing 3. So j will become again j will be assigned to 5, but nothing will be done here. So if I use I after this thing, I'll be getting I as a 3, not as 5, because whatever is changed here will not be reflected here. So this is an example of pass by value. We are not passing any reference or anything over here, so anything changed here will not be reflected here. This example shows pass by reference. So we have declared one function f which accepts an integer pointer, and what we are doing is we are changing the value at address ptr equal to 5. Okay, so when we are calling a function g, I am declaring int I equal to 3 and calling f and giving the address of I. Since I am using pointer ptr, I have to give an address something. If I just plain give I, if I just give I, it will not compile, or it will throw me some error at while I am running the code. So wherever I am having a pointer as a parameter of a function, I have to pass some address. So here I am passing address of I. So what it is doing is it is changing at address of I equal to 5. So whatever operation we do after that on I will always be taken as value 5, because here we are changing value at address of I. Here we are just doing some assignment operator into some other variable. So this will not change the value of I. Here the value of I will be changed. So this is how we use pass by value. This is how we use pass by reference. So pass by reference is also called as modified behavior in argument passing. So whenever we are writing any code which changes the behavior of the argument, we have to be very careful, because the further execution of the code will be very much dependent on our code. In this case, if whatever assignment we have done and all, it is locally to this function. So if anything wrong went into this function, this will not affect anything outside the scope of this function. But anything went wrong in this function will affect outside the scope of this function, because we are changing the value of I here, and that value will be used further, so the behavior of the program may change. So we have to be very careful while using pass by reference, and we should be very thorough what we want to do in pass by reference. So here I will be 3, here I will be changed to 5. So one more illustration we'll do. Let's say we have two variables, I equal to 5, j. So now what we are doing is we are declaring an integer pointer. So declare an integer pointer variable ptr. Ptr is an integer pointer. Okay, now we are having a double pointer like pointer to pointer. Declare a pointer to pointer to integer. Now here I am assigning ptr equal to address of I. So ptr will be assigned as address of I here. Pointer to ptr, pptr equal to address of ptr. Since it is a double pointer, so it will accepts the address of a single pointer. So ptr is a double pointer, it will accept the address of a single pointer. So what is stored in ptr is a address of a single pointer, which is ptr. Now we are changing value at address ptr equal to 3. So whatever is value at address ptr is 3. So the value of I will also be changed to 3, because whatever ptr is storing is address of I. So value at address of I will be changed to 3. Value at address pptr, so it will change. First it will get me what is the value of pptr, which is value of a single pointer, which is address of I. So how I'll execute this code? First I am getting address of ptr, and then I am changing the address value at address of ptr equal to 7. So now I will become 7. Again ptr equal to ampersand j, like ptr equal to address of j. So now ptr will point to 10. Now if I say value at address star pptr equal to 9, that means same operation, value at address ptr, that is address of j, will be assigned to say 10. Okay, so now star ptr equal to end of I, that means value at address pptr equal to address of I. So if we say here value at address pptr equal to address of I, so address of I is nothing but address of this, which is stored here. Now if I say star ptr equal to -2, okay, it will change the value of I as -2.
Just a quick info, guys. If you want to make a career in software engineering, then Intellipaat provides an advanced certification program on software engineering and application development by ENICT Council of IIT Guwahati. And it is taught by IIT Guwahati professors and industry experts. This course is designed to upskill and land your dream job. Now let's continue with the session.
So why the value is changed to -2? Because value of address ptr here, what ptr is storing, value of so ptr is having address of I, so value at address of I is equal to -2. So I ultimately I'll be changing the value of I. So this is how pointers are used to change the or do the reassignment or change the value by referencing to the address of a variable. So let's touch upon pointer arithmetic. So what is pointer plus 1? Pointer plus 1 is a next memory location. Next memory location in terms of it will not point to any random memory location, but suppose if I have an integer pointer and if I say pointer plus 1, it will allocate me it will allocate me that much bytes that an integer takes. Okay, so whenever we do an increment of a pointer, it always increments the size of a data type. So suppose my memory location is say 1001, and if I am saying pointer plus 1, it will not give me 1002. It will give me it will add 1001 with the size of an integer. Okay, so maybe suppose size of an integer is say 4 bytes, so it will give me 1001 plus 4 bytes. Similarly with ptr minus 1, it will decrement the memory location address with the type of pointer we are referring to. Pointer into 2 and pointer by 2, these operations are not valid. If we perform these operations, this will give us error. So just be sure that we should not use these operations in pointers. So again, let's revisit some example. Let's suppose we have declared two variable, float a4, float array of 4 as a float, a floating pointer. So here ptr equal to a pointer. We have not initialized it, so it has some, it does not have any value. So now ptr equal to address of a2. Okay, so ptr is pointing to address of a2. Value at address ptr equal to 3.14, so it will change a2 to 3.14. I am doing ptr plus plus, so what it will do, it will increment my pointer to next float, which is a3. Value at ptr equal to 9.0, so again a3 will be equal to 9.0. ptr equal to ptr minus 3, so I am decrementing my pointer with 3, so it will point to a of 0. Again I am changing a of 0 to 6. I am adding ptr equal to plus equal to 2, so ptr will point to a of 2. I am reassigning it to 7, so it will point to 7. So this is how all the operations are there. Here we are doing a plus plus operations. Here we are doing a simple mathematical ptr equal to ptr minus 3. Here we are doing a plus equal to. So all the combination of plus minus operations are possible. Only thing is that multiplication and division in pointers are not possible. So pointer arithmetic in array, how we do pointer arithmetics when we talk about array. So let's suppose we have a float array of size 4. Okay, we have a pointer, and pointer is pointing to address of a2. Okay, so type of variable is floating pointer. A2 is equal to, so this is how we reference an element in an array when we talk in terms of pointer. So a2 is equal to a plus 2, value at address a plus 2. So any array, suppose I have declared an array as a of 4. So if I say what is a is nothing but a is termed as a pointer to the starting location of an array. So a of 0 is nothing but star of a. So a is nothing, a is the starting point of a address at which our array starts. Okay, so since address at which array starts is a, and I am adding 2 to it, so it will increment my pointer with the 2, and value at that address will give me some value which is equal to a of 2. So this is how the behavior works. ptr equal to and of a, address of a of 2, or ptr equal to address of value at a of 2, or ptr equal to a plus 2. All these are equal. A is a memory address constant, so So A points to the memory at which our array starts. PTR is a pointer variable. So if I assign PTR equal to A, that will be a valid operation. A is the memory location at which our array starts. So that this makes a meaning A of 2 is equal to value of address A plus 2. So just to summarize our points, pointer stores the address of another entity. So another entity means a variable or an array, or it's generally is a variable. Address of operator is AND. So if we are using AND, we will be getting the address of that entity. Star is a dereference operator or a value of operator. So when we use star, we will get the value of that particular address. If we have declared an array, say int a5, so a is nothing but the pointer to a location from which our array starts, and we have touched upon pointer arithmetic. So what is pointer arithmetic? What all operations are possible in pointers? For example, addition is possible in pointers, subtraction is possible in pointer, but multiplication and division is not possible in pointers. So let's do some coding practice. Let's write some code. First problem is write a function to swipe two numbers. So let's use pointers to do that. This is the program which is swiping two numbers. What I am doing is I have declared one function, swipe function, which accepts two pointers, two integer pointers p1 and p2. Now what I am doing is in this swipe function I am declaring one temp variable, storing the value at address p1 in the temp variable. Now I am changing value at address p1 equal to value of address p2 and value of address p2 equal to temp. So what we are doing is in this operation we are changing interchanging the values which is stored in p1 and p2. So we are changing the values which is stored in address p1 and address p2. So when this function is finished, the changed value will be reflected in the main function. So what we are doing here in main function, we are having two variables a and b and inputting it from the user, calling a swipe function and printing it. So in the swipe function I am passing address of a, address of b, because we are accept we wants pointer here. So let's run the code. So let's compile the code. So code is compiled successfully. Let's run the code. Enter the value of a, let me give as 4. Enter the value of b, let me give as 5. So value of a is 5 and b is 4. So after we call swipe function, the value of a and b are changed. So this is how we use pointers when we talk about uh, doing some operations in changing the value. Also this is an example of pass by reference, because we are passing the address of a and b, and whatever is done in this function is reflected in the main function also. So this is how we do it. Let's take one more example. Write a C function to sort an array of 10 elements of 10 integers values in ascending order. Here we need to we will be given an array of 10 integers, and we have to sort the uh, array. So how we will do it? We can use a very simple brute force technique called bubble sort. Bubble sort will what it will do, it will run two loops. First it will run loop on element 0, and it will check all the elements from element 1 to element 10 or element 9, whether if element 0 is the least value. If whatever so from in the second loop which we are running, from 1 to 9, whatever is the least value, it will be assigned to element 0. Then we'll go to element 1, and the second loop will run from element 2 to 9. We'll find the least value from 2 to 9, and it will be assigned to element 1. Then we'll be running a loop from, then we'll be pointing our variable to 3 and so on, and we will be ending up sorting an array. So let's write a code for it. So this is how we write the code for sorting the array. So what I'm doing is I'm using a swipe function in a little different way, just to show that how it can be used in other way also, where I'm expecting a pointer variable, an integer I and integer j, x and y. Swipe function is like this. Uh, these are the parameters. So temp equal to value at address p plus x, px equal to py, value at address py equal to temp. So this performs swiping. So in this I have used all flavors of using pointer and array combination, where this px is equivalent to star p plus x, and I am using all these flavors in swipe function. So let's see what we are doing in main function. So in main function, what I am doing is I am declaring a variable, an array I and j. I am declaring. Now I am taking input from user. Okay, in this section what I'm doing, I'm running two loops. One loop runs from 0 to 10, second loop runs from I plus 1. That means whatever is the value at of I, it will start from position, uh, say suppose I equal to 0, this j will start from position 1 and so on, and till the end of the array, and say check if a of I is greater than a of j. If a of I is greater than a of j, then it will swipe the value. That means the swipe function will come into picture, where a of I will be swiped with a of j. So let's run the code. Okay, let's compile it. Compilation is successful. Let's run the code, give some values. So array after sorting is 23, 23, 434, 43, like this, and 133. This is the last element of the array. So this is how we print the output. So this gives us very illustrative way of how we can use pointers with array, and how we can use pointer arithmetics and all. So arrays from pointers perspective. Uh, Suppose we have declared one array, say arr 10. The name of the array, which is arr, is similar to the address of starting location of the array. So arr will always point to the memory location of 0th element of array. So we can make an initialization like this: integer pointer p equal to arr, because arr is a pointer which is pointing to the 0th element of array. Similarly, this is also same, integer pointer p equal to address of arr of 0th element. This is also same. So this is just a different type of representation, but the result will be same. Arr is same as and of arr 0. Star arr is same as arr 0. So what is star arr means? Value at address arr. So this is value at address arr plus 0, which is equal to arr of 0. Similarly, value at address arr plus 1 equal to arr 1. In general, value at address arr plus n equal to nth element of the array. So this is how we reference any element of array from pointers. Okay, let's consider this example. In this example, I have given two sections. One section is without using pointers and this section is with using pointers. So let's visit this section. Hash include stdio.h main. I have initialized an array 1 2 3 4 5 6 100 9 10. I'm taking one integer I for loop counter, declaring I equal to 0 to 10, running a loop from I equal to 0 to 10, then printf array of ARR of 1 and return 0. So this, the output of this program will be, I'll be getting I'll be printing 1 2 3 4 5 6 7 8 9 10. Okay, now consider this example. Here we are doing same thing. Int main, int ARR 10. I'm declaring numbers from 1 to 10. Again, this is a counter for loop. I'm running a loop from 0 to 10 and I'm printing a number which is value at ARR plus I. So now this is equal to ARR of I, as we have checked in previous slide, and return 0. So output of this program is also I'm printing a number from 1 to 10. So to make a conclusion, these two programs are equal. This is how we generally refer an array, and this is how we refer it in pointers perspective.
Just a quick info, guys. Test your knowledge of C programming by answering this question. Which of the following facilities does C programming provide? A. Input and output facility. B. No input and output facilities. C. Input facility. D. Output facility. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
Let's take one more example. This example mostly covers pass by value and pass by reference. So this is pass by value. So suppose we have declared one array from 1 to 10 and I'm running a loop and calling a method called display. In the display method, what I am doing is I am printing the number. So I am passing a number and printing it. I'm not doing anything extra from it. So what this program will do is this will print number from 1 to 10. What I am doing here is I'm using a function called display, and display will be printing a number which is passed to it. So I'm passing a value to this number and it is printing the number. Okay. In this program, what I'm doing is again I'm doing same thing. I'm initializing an array. Okay, having a loop counter, running a loop from 0 to 10. Now here I am passing a integer pointer or address of a and referring it here in this function, and what I am printing is value at address ptr plus I. So this will also give me the same output. So this is how we can use it in the functions. So let's write some code. Write a program to print to input a matrix and print. So we will be getting a value of each and every element of a matrix. A matrix is nothing but a two-dimensional array where rows and columns are specified. So here we are specifying row and column to some value, and then we will be inputting each and every element of the matrix from the user and printing it. So this is how the program will look like. Program will look like this. Hash include stdio.h int main. So I am declaring row 3, column equal to 3, int ij. I am declaring one array, two-dimensional array with 3 rows and 3 columns. Now I have to run two loops, one which iterate through the row and one more loop which iterate through the column, and then I am printing enter the value of which row and which column you want to get. Scanf, I am getting the value for that particular location. So this is how I get input from the user. To print the output from the user, again I need to run two loops, one for the row, one for the column, and then I have to print the value of the array. So this is how I can print the value or the complete matrix. So now in this program we'll use pointers to do the same operation. Nothing much change, but whatever the change we have made is specified by the red color. We made changes in the scanf statement, where scanf equal to value pointing to the address of which location we want to store the given number. So here we want to store at row I, column J. In this case we are not using pointers, we are using normal approach. Here we are specifying the addresses explicitly. Also, while printing, we are following this approach. We are first resolving which row we have to go, and in that row then we have to resolve which column we have to go. In this we are directly going to the row and column. So for the exercise question, I would like you to try out this problem on your own. Write a program to print a matrix in a spiral order. So what is a spiral order? Spiral order is this. Suppose this is a matrix, so you need to print the matrix in this order. Like first you need to go like this, then this, then this towards the center of the matrix. So if you go like this, then the output will be 1 2 3 4 5 6 7 8 9 10 11 12 13 14. This is the output that should be printed given this is the matrix. So if this is the matrix, this should be the output. So I will like you to try this example on your own, and this you just need to build a logic, but all the basic things that you need in the program is already provided in this example. You can use the same approach and write a code. This will give you more and more understanding and more clarity on how we use how we use pointers in arrays, and how we use pointers in multidimensional array. So what is dynamic memory allocation? So in case if any programmer wants some portion of memory to be allocated for his program, he can call some functions which will allocate that piece of memory or that amount of memory, so that he can use for storing the data and performing some operations. So just to state it again, programmers explicitly request the system to allocate memory, and once we request it, the function that we are calling will return the starting address of the chunk of memory which is allocated. So what is the starting address of memory allocated? Suppose we have asked to assign us say 10 bytes of memory. So it will give us the function that we are calling will give us the address of the first byte. What is required when we do dynamic memory allocation? The most important thing is when we use dynamic memory allocation, we should take very good care of freeing the memory explicitly. So suppose we have reserved 10 bytes of memory for our program, we should always be careful to free the memory, so that we will not run out of the memory when we run large programs, or we run a lot of programs. When not in use, the memory has to be freed. So how to allocate the memory dynamically? In C, we have a library function stdlib.h. In stdlib.h we have 4 functions that do dynamic memory allocation. First function is say malloc. So malloc allocates a requested size of bytes and return a pointer to first byte allocated to it. Calloc allocates space for array elements, initializes to 0 and then returns a pointer to memory. Free, as the name suggests, it will free the space whatever we have allocated. Realloc will use to reallocate the memory space. So what is malloc? The name malloc stands for memory allocation. The function malloc reserves a block of memory of specified size and then return a pointer of which uh, it can be used or typecasted into a pointer of any form. So here is a syntax. Pointer, say ptr equal to let's visit this portion, malloc of byte size, and this will return a void pointer, and then we need to typecast it to whatever type of pointer we want. So for example, ptr equal to malloc of 100 bytes or 100 ints, because we have given size of ints, so it will give us 100 memory which is equivalent to 100 integers, and then we will be typecasting it to a integer pointer. So this is how you have to use malloc in your malloc in your code. Calloc, the name calloc stands for continuous allocation. The only difference between malloc and calloc is that malloc allocates a single block of memory, whereas calloc allocates multiple blocks of memory, each of same size, and set all bytes to 0. So calloc will also do one extra thing, is it will initialize the memory, or it will initialize the bytes to 0. It will not just give the bytes as it is. It will clean up whatever is there in the memory space and give it to you. So this is how calloc is used. It is not much different from how malloc is used. We just need to use calloc, number of memory space we want, which data type we want, and then typecasting. So for example, we want space equal which can hold 25 float variables. So we'll say we want memory which is equivalent to 25 floats. So size of float 25, and then this will return a void pointer which we need to typecast it to float pointer. Free, so dynamically allocated memory with either calloc or malloc does not get written into its own. The programmer must use free explicitly to reserve the space, to release the space. So whatever memory we request from the system, we should give it back to the system. The process of giving back to the system is free, just called free pointer. So in this case, we are storing this address in this variable ptr. So whatever memory we want to free, just call free, and that pointer that which we have set up to hold the memory location. Relock. So if previously allocated memory is insufficient or more than sufficient, then you can change the memory size previously allocated using realloc. So what does it mean? It means suppose you want more memory uh, in your program, you can do realloc, or suppose you have reserved a lot more memory than you needed, then also you can use relock. So how relock works? It's same ptr equal to relock and ptr and the new size. Okay, so it will relocate, uh, it will increase or decrease the size of memory that you have already used, that you have already got reserved using either malloc or calloc. So here it is used ptr equal to relock PTR 10. So we are reallocating the PTR to 10. So this is how C code looks like when we use malloc function. Uh, for for using malloc, we should include stdlib.h. This is very important. Then it's a main function int n, int I, and a pointer ptr, and sum equal to 0. So enter the name of enter the number of elements that we want. Say it takes we are storing it in n, and then we are allocating memory up to of n number of integers. So this is how we are allocating memory allocated using malloc. So if pointer ptr equal to null, we are checking if whatever memory that we have got here is null, then we print error memory is not allocated. In case memory is not allocated, ptr will always be null. Print and we will be exiting our function. So if ptr is not null, we will directly come to here. So we says enter the elements in the array. It will do a scanf and allocate and assign each and every element, or initialize each and every element with whatever we want, and then at the same time we are calculating the sum also. So sum equal to sum plus value at address ptr plus I. Okay, so printf sum equal to sum, and once we printed the sum, we will be freeing the memory. So this is how malloc is used. It's very simple. We are allocating a memory, doing the operation, and then freeing the memory. So this is an example of how calloc is used. This is also same. The logic of program or operation of the program is same. It will calculate the sum of input numbers that we get input from the user. So here we are doing hash include stdlib.h int main. Again we are declaring integer n, integer I, integer pointer, and sum equal to 0. We are getting input from user that how many integers you want. Then we are assigning a memory of n integers into a pointer. We'll be checking if pointer is null, that means if memory is actually allocated or not. If memory is not allocated, that means ptr is null. Then we are saying that okay, memory is null, and exiting our program. If ptr is not equal to null, then we will be coming here and we will be getting an input from user. We'll be doing scanf and sum, and then we'll be printing the sum. And once we are done, we will be freeing the memory, free ptr, and return 0. So this is how calloc is used. Again, I'll reiterate. Most important part is including the library function, assigning the memory, and freeing the memory. So this is how realloc works. Hash include stdio.h, hash include stdlib.h, then int main. So we have pointer ptr equal to I, n1, n2. Enter the size of array, say n1. Now we are allocating a memory of n1 integers. The address of previously allocated memory is like this. We are printing at all the addresses. Now scanf, enter the new memory size of new array. So we will be getting an input in n2. Now we are reallocating ptr to n2, and then we will be printing all the memory locations that we got while doing the realloc. So this is what this program does. It will allocate memory of n1 size, prints the addresses, and then it will reallocate the memory of n2 size, and print the addresses. So this is a very basic example of how to use realloc. So what is a linked list? A linked list consists of a sequence of nodes. So what is nodes? Node is a segment of memory. So here this is a segment, memory segment, this is a memory segment, this is a memory segment. So linked list is a sequence of node. Node is a section of memory. Each node contains a value. So every node has a value and a link which is pointing to some other node. So this is the link part which is pointing to some other node. So that is why it is called a linked list, because each memory section is linked to some other memory section. So it's a chain that is being built upon, and the last node will contain a null. So this is how our chain terminates. So let's reiterate. Each node in a linked list has two sections. One is a data section, one is a link section. Each link points to some other node, and which constitutes the chain, and uh, that is why it is called linked list, because there is a link between one node to another node, and it's a linear format, so it is called a list. So linked list. So the list may have a header. It's good to have a header. Header is nothing but it says that from where my linked list is starting. So generally it contains the location of your first node. So here is a starting element of the linked list, or I can say the head of the linked list, which contains the memory address of the first node. So this is the linked list. This contains the first address of the first node. Then node A has B as the next node, B has C as the next node, C has D as the next node. So what is the terminology that we used in linked list? A node's successor is the next node in the sequence. So the next node in the sequence, this is the successor of uh, the node. So B is the successor of A, C is the successor of B, and so on. The predecessor is the previous node of the sequence. So A is the predecessor of B, B is the predecessor of C.
Just a quick info, guys. If you want to make a career in software engineering, then Intellipaat provides an advanced certification program on software engineering and application development by ENICT Council of IIT Guwahati. And it is taught by IIT Guwahati professors and industry experts. This course is designed to upskill and land your dream job. Now let's continue with the session.
Just a quick info, guys. Test your knowledge of C programming by answering this question. Which of the following is not a data type? A. Float, B. Int, C. Real, D. Imaginary. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
The list length is the number of elements in the list. So in this linked list we have 4 nodes, 1, 2, 3, 4. So the length of the linked list is 4. So this is what we used to call or we frequently use these words in the linked list. So let's touch upon how to create a linked list. So let's assume this is a linked list. Linked list has, as we have covered, that this is a memory segment, which is also called node. Each node is a structure uh, which has value and a pointer to the next node. The pointer to the next node is nothing but a pointer to the same structure. Uh, the data part, or the value part, whatever we call it, here we are using an int value, but it could be anything. It could be another structure, it could be another string, character array, it could be anything. So whatever we store here is a data, which could be anything. Here we are using integer. Whatever we store here is a pointer to another structure which stores the address of the next node. So this is how we define a node. Uh, to assign a memory to a structure, we have to use malloc. So this is how we assign a memory to the structure. Initially, when we declare any structure, it won't be assigned any memory. So we need to allocate some memory to the structure. So this is how we do that. Then once the memory is allocated, how we access the value part of the linked list is temp and this operator arrow, this we call as arrow operator, which is nothing but hyphen and a right arrow. So this is called an arrow operator, and temp arrow value. So temp arrow value will help me to access the value portion of the node, and we can store the value like this. So this is how we can assign the value. Okay, this is how we can access the next element of the, or the link part, or the next part of the linked list. We can assign it to some other node, or we can assign it to null. Okay, so struct node my list equal to temp. So here what we did is we created one node, one empty node, and then we assigned the root. This root will be pointing to temp. So temp will become our first node. Let's learn about traversing the linked list. So traversing the linked list is nothing but going through the linked list in a way how we, as and when we get the address of the next part. So for example, we have declared a structure like this, which has in data part as an integer and a next part. Then this is a root element, and then we generally will take a temporary variable which is and we assign it to a root, and then we run a loop which continues until temp is not equal to null. We print the data like temp equal temp arrow data, and temp is assigned to the next element. So temp will be keep on increasing, keep on increasing, keep on increasing, and until and unless temp becomes the null, or because at one point of the time, if we have a terminating linked list, like the last element of the linked list is pointing to null, so at one point of the time we will be hitting that pointer, and we will be getting null. So this loop will end, and we'll end up traversing entire linked list. So let's see how we traverse a linked list. Say this is our linked list. This is a data part, this is a link part. So suppose we have declared a temporary variable this. Now initially we assign temporary variable with a root, which will point to here. Then once we print this, we assign uh, this dot next, which is this, to the temporary variable. Now it will point to here. Again, the next part is assigned to the temporary variable, which points to this part, and again finally we end up getting a null. So this is how we traverse a linked list. So let's touch upon what all are the operations which are possible in the linked list. So there are two operations which are possible in the linked list. One is insertion in the linked list, one is deletion in the linked list. So insertion and deletion could have many flavors. One could be inserting at the end of the linked list, one could be inserting at the beginning of the linked list, one could be inserting at the middle of the linked list. Similarly, deletion could have many flavors, like deleting the last node of the linked list, deleting the first node of the linked list, deleting something in the middle of the linked list, and so on. So we have different flavors of insertion and deletion. So this is we are explaining more about insertion. There are many ways to you might want to insert a new node in the linked list. Insert as a first element, insert as a last element, insert in the middle. How you do insertion in the middle, like before a given element, after a given node, before a given value, after a given value. So there are many combinations that we can try out on insertion. So all are possible, but it depends upon what operation we choose, and each operation has its own difficulty level. For example, adding a node at the end of the linked list is easy. Adding a node at the middle of the linked list is a bit trickier. So it has each and every operation or each and every flavor of insertion in the linked list has a difficulty associated with it. So inserting after, how does this function works? Inserting after. So let's suppose we have this linked list and we want to insert a node 2.5. So find the node that you want to insert after. So let's suppose we insert our node after 2. So here we want to insert after 2. First, copy the link from the node that's already in the list. So you need to copy this link somewhere. Okay, so what we will do is 2.next equal to node.next and node.next. So what will happen is this 2.next will point to 3, node.next will also point to 3. Now we will have to do, we will have to make 2.next points to node. Change the link in the node that's already in the list. So we need to change the link of this to this. First we have to dereference it and assign it again. So this is how we can insert the linked list. So now when we traverse the linked list, it will be like this element, then this element, then this element, then this element. So let's do some practical example. Let's write some code for this. So this is the code for very basic operation of inserting into the linked list and traversing through the linked list. Here we have declared a structure of node. The data part is integer. The next, or the pointer which is pointing to the next node, is next. Then we have a declared two function, add, which adds a value to the linked list, and then we have a function called print, which prints the entire linked list. So let's go to these functions, add and print, then we come to main. So first go with the add function. This is our add function. So what we are doing is we are passing a pointer or we are passing the address of the root element, root or head, whatever we call it. Then we are passing the value what we want to store in the new node. So here we are adding a node at the end of the linked list. Just for simplicity, we are doing this operation. So now what we are doing is we are having a temporary node and assigning a memory to it. So we are allocating some memory to a temporary node. The node type should be struct node temp. Then we will be filling the data inside the node. Temp.data equal to value, temp.next equal to null. So why we are making temp.next equal to null? Because we are adding the node at the end of the linked list. So we want this node to be a terminating node. So that's why the next element should be null. Okay, now we are doing some checking, like if our root is null, if value at address root is null, that means our head or root or starting point of the linked list is null, that means our linked list is entirely empty. Then what it will do, it will assign value at address root equal to temp. So temp will be stored at the root, or root will be pointing to the temp. So this is the creation of first node of linked list. Now in case we already have something in the linked list, then what we are doing is we are declaring some temporary variable called list and assigning it to our root. Then we are traversing like this. If list dot next is not equal to null, we are assigning until and unless we get some node whose next is null. Okay, once we find that node, what we are doing is we are making list dot next equal to temp. So the last element of the existing list will point to the temporary element or temporary node, and in temporary node we already have the next part pointing to the null. So ultimately we end up adding the new element at the end of the linked list. So this is how we traverse the linked list. This is a function called print. It is accepting a root, a root pointer. So struct node, we are declaring a temporary variable here. Then while temporary variable is not equal to null, we are keep on printing the data at the node temp. So we are printing temp dot data and incrementing temp equal to temp dot next. So we are assigning we are jumping from one node to another, one node to another. So how the jumping works? Jumping works like this: temp equal to temp dot next. So until and unless temp becomes null, this loop will continue and we will exit out of the loop. So how we use this into the main function? Okay, this is the main function. We have declared struct root equal to null. So initially we have declared a root of our linked list and initialize it with the null value. That means our linked list is entirely empty. Now what I'm doing is I'm declaring a variable I which is used for loop. I'm running a loop from 0 to 10 or 0 to 9 and adding I to the linked list. So I am adding 0, 1, 2, 3, 4, 5, 6, 7, 8, 9 to the linked list. Then what I am doing, I am printing the linked list. So this is here I am adding elements 10 times in the linked list, one after the other, and here I am printing the entire linked list. So let's see how this program runs. GCC -o linked list.c. So I got a compilation success. Now /linked list. So if I run this program, what I am doing is I'm initially the nodes are getting added and then we are printing. So output of this program is we are printing the linked list. So this is how linked list will behave. Okay. So let's see one more program which is another flavor of adding the value or adding the node in the linked list. So here I am continuing with the existing program that we have discussed just now, and I am adding one more function called add after. So what this function will do, it will add a node after this value. So it will search for this value and add a node which has the data part as this value. Okay, so let's see this function, how this function behaves. Add after, this is a function add after. So I am adding value after x. Okay, so initially we are checking if root is null, that means our linked list is empty, so we don't have anything to add. We'll return safely. Say struct node temp equal to root, we just have a temporary node which is pointing to the root. Now then we are running a loop to find the value x. Okay, so we are doing two things. We are doing temp equal to temp dot next. That means we are jumping from one node to another node until we find null or we find x. Okay, so here is the jumping part, temp equal to temp dot next. Then once we exit out of the loop, we'll check if temp dot next is not equal to null. That means once that means it is, we arrived at a point where it is not the last element of the linked list or last node of the linked list. If this is the case, that means we are adding the node in between. We are declaring a temporary struct node p and allocating a memory to it. Then what we are doing is p dot data equal to value, p dot next equal to temp dot next. Okay, so p will p uh, the next element that will come after p will be temp dot next, and then we are assigning temp dot next equal to p. So temp will point to p and p will point to whatever the temp was pointing earlier. So we have added p in between temp and temp dot next. So that's how add after works. Let's see how we use it in the main function. So this is the part which we have covered earlier. So we have declared a root, we have added 10 elements, we printed the linked list. Now what we are doing is we are adding a value called 34 after 4. Okay, and then we are printing the linked list again. So let's compile and run this program. So we got a compilation success. I named this program as linklist1.c. You can name it with anything you want. So here is the output. This is the first print that we did. Like this is a normal linked list, or linked list where we have added the value from 0 to 9, and then I have added 34 after 4. So here what we got the value 0 1 2 3 4, then 34, then 5. Like earlier it was 4 is pointing to 5, now what is happening, 4 is pointing to 34 and 34 is pointing to 5. So we have added after the particular value, or we have added one node between the two nodes of the linked list. So let's see how deletion works. So in order to delete a node from a single linked list, you have to change the link of its predecessor. So predecessor means whatever node which is before a particular node has to point to the node which will come after the node that we are deleting. So little bit confusing, but suppose there is three nodes A, B and C. A is pointing to B, B is pointing to C. So we have in this case, if we want to delete B, so what we need to do, we need to change the link of A. That means the next portion of A. So A should point to whatever B is pointing to. So now in this case, B is pointing to C. So to delete B and maintain the linked list, A should point to C. So this is what we are going to say. The predecessor should point to the next element of the current node. It is slightly tricky because you can't follow a pointer backwards. So deleting the first node in a linked list is a special case because the node's predecessor is the list header. So let's revisit these 2 points. Why deletion is tricky? Because you don't have a pointer to the previous node since it is a singly linked list. There is a cases where we have a pointer to the previous node where we call it, where we have a doubly linked list, which we will cover later. But talking in terms of singly linked list, it is difficult to delete a node in between. So we need to write some logic so that we can have a predecessor's pointer, so that we can manipulate the predecessor's next portion to point to the successor's next portion. Okay. So let's write some code for deleting the node in the linked list. This is the code for deleting the node in the linked list. I have followed the first program that we have written. So we have two methods, add and print. Why we require these two methods is because we need some data in the linked list. So we have these two functions. The new part is this: I have added this function delete node. So what delete node will do is it will delete a node uh, which has value equal to VAL or whatever we will provide in the as a parameter. So let's see this function. So delete node, this is the function delete node. So what we are doing in delete node is we are maintaining two pointers, one is temp and one is previous. Okay, temp will point to will be assigned to root. Previous is we set previous equal to null. Then what we are doing is we are running a loop to find a node which has value or data portion as equal to val, and similarly we are jumping temp equal to temp dot next, and what we are doing is we are jumping the previous also. So what we are doing is previous is assigned to temp and temp will assign to temp dot next. So we are maintaining two pointers and we are moving two pointers. So we are maintaining a link to a predecessor and we are maintaining link to a successor. So if previous equal to null, then return. That means we don't find anything like our loop is ended and we didn't find anything. So uh, we return safely because there is nothing to delete. If temp dot data is not equal to val, like we found, our loop is ended, but the pointer which is pointing to temp does the data portion does not match with the value. So that means we reached to the end of the linked list, but we didn't find anything which is matching to value. So again we return safely. If none of the condition matches, then what we do is we make previous dot next. That means predecessor next pointer equal to successor's next pointer. So predecessor dot next will point to successor dot next, and then we will free the memory. So we now temp dot next is will be pointed by previous dot next. So there is no, and we need to delete the temp because temp dot value is equal to whatever value we want to have. So we can free the memory. So that's how we delete it. So let's go through the main function, like how we are using it. So in main function again, what I'm doing is initializing the our linked list from 0 to 10 or 0 to 9, printing the linked list. Then what I'm doing is I'm deleting a node 5 and then again reprinting the linked list. So let's see what happens. Let's run the code. C minus linked list 2. So we got a comparison success. So here this is the output. So this portion here, this is the first print where we have initialized the linked list and did a print. Now this is the print after we have deleted the nodes. So you can see we have deleted 5 here and 5 is not coming to picture. Earlier 4 is pointing to 5 and 5 is pointing to 6. Now 4 is directly pointing to 6 and we have freed the memory which is holding 5. So this is how we perform deletion in the linked list. So this is a small animation. To delete the first element, change the link in the header. So if you want to delete the first element of the linked list, our header should point to the successor of the first node. So this is the this is the linked list, and we remove the link, or we this variable does not point to this, but it points to this. So this is now our linked list will be like this. We will not be using this and we can free this memory. To delete some other element, change the link in its predecessor. So like this is the predecessor. So predecessor will not point to this. Suppose we are deleting this node, so predecessor will not point to this, but it will point to this. So this is how we traverse the linked list now, and we can free this memory. Delete node will eventually be a garbage collected, or we need to free the memory so that we don't overuse the memory. If we are not freeing it, it will be held up and will not be it's a memory loss. Okay, so let's touch upon what is a doubly linked list. So doubly linked list is nothing but an extension to a single linked list, where each node will be having two pointers. One is pointing to the predecessor and one is pointing to the successor. So here this is suppose consider this node. So this node has now three portions. This is a data portion, this is the next portion which is point to the successor, this has one more portion which points to the predecessor. So accordingly we will make changes in the structure. And how the doubly linked list will help, like in case of deletion we need to maintain two pointers. Now in this case where we have doubly linked list, and if you want to delete anything, we don't need to maintain two pointers. We just find the value which we need to delete and then go. Suppose we want to delete B, we find B and then we go to this element A. Then what we'll do, A dot next will point to C and C dot previous will point to A. So that's how we can do. It's a very simple thing. So each node contains a value, a link to its successor and a link to its predecessor. The header points to the first node and in the list, and to the last node of the list. So uh, header has two information. It depends upon how we build a linked list. It is not always mandatory that header should have information about the last node. Uh, it all depends upon our execution, like how we want to maintain. So it's up to us how we write a program, whether we want to maintain the pointer to the first element only, or we only need to maintain two pointers, one which point to the first element, one which point to the last element. So DLLs compared to SLLs. So before that, let's write some code for the doubly linked list. So this is the code for doubly linked list. So as you can see, we have a structure node. Earlier it was having data and next pointer. Now it has a previous pointer also, which points to the predecessor of the node. This points to the successor of the node. Then what we are doing is, while we need to modify add and print function, all not print function, but we need to modify add function also. So let's see how the new add function will look like. So this is how our new add function will look like. Again, here we are just initializing the memory. Now the temp dot data equal to value, temp dot next equal to null, temp dot previous equal to null.
Just a quick info, guys. Test your knowledge of C programming by answering this question. Which of the following facilities does C programming provide? A. Input and output facility. B. No input and output facilities. C. Input facility. D. Output facility. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
So here we are just keeping initializing a node which with the default values. Then we are finding if root is equal to null, that means it's an empty linked list. We are assigning root equal to temp. In case our linked list is not empty, we are having a temporary pointer and finding the and traversing till we reach the end of the linked list. And then what we are doing is temp dot previous equal to list. That means temp dot previous, like predecessor of temp, will point to the this variable list, and list dot next points to the temp. So that's how we add it. And we have also written one function called print reverse, which prints the linked list in the reverse order. So let's see how this code is. So this is a print reverse function. What it will do is, it will just uh, we pass a root to this element, to this function as a parameter. Then we have a variable which points to the root. So first we go to the end of the end of the linked list. Now here in this w linked list, we are not maintaining a pointer which points to the end element of the linked list. So if you maintain that pointer, then you need not have to do this step. So since we are not maintaining, we need to find the end of the linked list, and from the end we are jumping backwards and printing the value. So printing the value, jumping backwards, printing the value, jumping backwards until temp is equal to null. So this is how we do operations in doubly linked list. I'll suggest you try this and do some modifications, like add some element in the doubly linked list, delete some nodes in the doubly linked list, and have two pointers which points to start or the first node of the linked list, and one points to the end of the linked list, and do some operations uh, like add the values in the linked list and print the sum and do all kind of things operation. There are number of operations possible in linked list. So let's compare doubly linked list and singly linked list. So DLLs start for doubly linked list. Doubly linked list is short form of doubly linked list. SLL stands for singly linked list. SLL, singly linked list. So singly linked list is nothing but what we have discussed before doubly linked list, where any node points to the successor. It does not have a predecessor node. Okay, so advantages, uh, can be traversed in either direction. So doubly linked list we can traverse in either direction, front and back, uh, but we cannot traverse in from any direction front end. We cannot traverse in back direction in a singly linked list. Some operations such as deletion and insertion before a node becomes easier. So in a doubly linked list, it is easier to perform operations like add some node at the middle of the linked list and delete some node at the middle of the linked list. In the singly linked list, we need to maintain uh, two pointers, which one points to the predecessor, one points to the successor, and then we need to do some operations. So in doubly linked list, it is much easier. Singly linked list, we need to write some extra code. So what are the disadvantages of this thing? So DLL or doubly linked list requires more space, because now in doubly linked list each node has an extra link which is linked to its predecessor, so it requires extra memory. List manipulations are slower because more links must be changed. So if we want to do some manipulations or want to change links in bulk, this is tedious operation. So greater chances of having bug because more links must be manipulated. So if we perform this operation where we need to change most of the nodes in bulk, it may happen that we end up in some bugs which is not easy to debug. So we need to be very sure what is our requirement, and do we really need doubly linked list? Can we do operation with singly linked list? What is our performance impact in with the time complexity and memory complexity? So we should take care of these stuff before deciding what to use. So deletion a node from a doubly linked list. So node deletion from doubly linked list involves changing two links. In this example, we will delete node B. So earlier example we have set of three nodes A, B, C. Now in this example we are deleting a node B. So this is our linked list. We are deleting node B. So what we are doing is the link uh, the A's next link which is pointing to B is removed. Now A is pointing to C. C's previous which is pointing to B is removed. C's previous is now pointing to A, and that's how we delete it. So we don't have to do anything about the links for the B, and we can free the memory. Garbage collection will take care of deleted nodes. So we need to free the memory, and then it will be taken by the garbage collector. Deletion of the first node or last node is a special case. So if you want to delete the first node, then what we need to do is this node will point to this, and the previous of this will point to null or nothing. So we need to change the things, and similarly if we want to delete the last node, we need to adjust the pointers accordingly. So other operations that are possible in linked list are like most algorithms in linked list, such as insertion, deletion, and searching are pretty obvious. So you just need to be careful what linked list you want to choose and what operations are required in your program. Sorting a linked list is just messy since you can't directly access the nth elements. You have to count your ways through the lot of other elements. So if you want to sort a linked list, it requires some effort because we cannot directly access the uh, element through index as we can do it in array. We need to traverse through the linked list, find the element, and do the changes and also we cannot shuffle the value very easily. For example, we can shuffle two values in array very easily, But if you want to shuffle two values, we need to change a lot of pointers. So we need to be very careful in that also. So there is a special case called circular linked list. Circular linked list is nothing but it has one head element and it has uh, other elements like as usual, and the last element, the next portion of the last element or the successor of the last element is the first element. So while traversing the linked list, what we have to do is we just have to say where is my head, and we find the head, then we traverse like this 2 5 7 8 10. Now 10 points to 2 again, so this is, we will be revolving in a circular manner, so that's why it is called circular linked list. So circular linked lists are also very known data structure in computer science, and these are used for developing circular buffers and all. So but we need to be very careful while using circular list linked list, because we might end up in an infinite loop because there is no terminating condition here, because there is no none of the node is pointing to null. So if we keep on traversing a linked list, and we need to set proper conditions before our loop get terminated, so we need to be very careful in that.
Just a quick info, guys. If you want to make a career in software engineering, then Intellipaat provides an advanced certification program on software engineering and application development by ENICT Council of IIT Guwahati. And it is taught by IIT Guwahati professors and industry experts. This course is designed to upskill and land your dream job. Now let's continue with the session.
So what is a binary tree? A binary tree is a composed of zero or more nodes. In C, reference to a binary tree may be null. So binary tree is something like this. So any node has two references. So suppose this is a node, okay. This node has two references. One is the reference to left part, one is the reference to right part, and this is a data section, okay. So binary tree is composed of two or more nodes. Here we are having two nodes. One is for left reference, one is for right reference, okay. Each node contains a value, a reference or a pointer to left child, a reference or pointer to right child. So whatever be the reference that it has towards its left, this is called the left child of this node. Whatever the reference this node has towards the right, so this is called the right child of this node, okay. And if any node is there with no reference, then it is called as the root node, okay. So we always start with root in the binary tree. Then each node in the binary tree has two references, one is left, one is right, and we keep on building the tree. A binary tree may be empty. So in case if binary tree is empty, then this node will be null. So if root is null, that means binary tree is empty. If not empty, a binary tree has a root node. So if not empty, this will have some value, and whatever value it has, this will be called as a root node. Every node in binary tree is reachable from root node by a unique path. So every node in a binary tree can be accessed by root node through some unique path. For example, if you want to go to H from root, the only path you can go from here, root to H, that means A to H, is you need to go from A to B, B to E, and E to H. There is no other path that you can go from A to H. There is a unique path from root to every node. A node with no left child and with no right child is called a leaf node. So Suppose there are any nodes with no left child and no right child, for example, like this. So it does not have anything on the left, does not have anything on the right. So this is called a leaf node. Okay. So in binary tree, what all we have? We have a root node which does not have any reference upwards. Okay. And then for any node we have a left reference and right reference. The left reference is called the left subtree, right reference is called the right subtree. There is a unique path from each node from root. So if you want to go from root to any node, there is only one path. And if any node which does not have any left reference or right reference, then it is a leaf node. So this is a very basic binary tree representation, uh, and as and when we proceed, you will be able to understand these concepts more and more in depth, and this will give more understanding on what are binary trees. Okay. So let's continue with further explanation on binary trees. So in binary tree, the following two binary trees are different. So suppose this is a node and this is one more node. Both node has same values A and B, but these two are different binary trees. Why? Because here in this case B is the left child of A. Okay, but in this case B is the right child of A. So the representation of a tree in this diagram and representation of tree in this diagram is totally different. So hence we call it as a different binary tree. If the first binary tree in the first binary tree, node A has left child but no right child, correct? So it has left child but no right child. In second, node A has right child but no left child. Put in another way, left and right are not relative terms. Yeah, so left and right are not relative terms. We cannot just do some relation between left and right. So binary tree terminologies. Node A is the parent of node B if node B is the child of node A. So what is mean by parent and child? In this case, node B is child of node A. That means in hierarchy, node A comes first and node B comes after A. So A is parent of B and B is child of A. Node A is ancestor of B if A is a parent of B. So another thing is also called as node A is the ancestor of B. So whichever comes first from the traveling from the root will be the ancestor of the node which comes after that node. So A comes first and B comes after A, hence A is the ancestor of B. Node B is a descendant of A. So similarly B comes after A, so B is the descendant of A. Node A and B are siblings if they have same parent. So if A and B are having a same parent, like suppose there is a node called C here. Okay, let's say C is here, then B and C will be siblings because B and C will have same parent called A. So let's cover about what do you mean by size and depth of a binary tree. So suppose this is a binary tree. The size is the number of nodes in a binary tree. So here in this case, number of nodes are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So the size of binary tree is 12. Correct. The depth of the binary tree is the node to its distance from the root. So A is at depth 0. So because since A is the root, so distance from root to root is 0. B is at distance 1, C C is also at distance 1, E is at distance 2, H is at distance 3. So E is at depth 2, 0, 1, 2. This is the second depth. Also you can say number of hops that you need to do while reaching from to a particular node from A or root. So if you want to reach E, how many hops you have to do? 1 and 2. So 2 hops you need to do. So number of hops equal to the depth of a particular node. The depth of a binary tree is the deepest node which is present in the binary tree. So if you say what is the depth of this tree? So depth of binary tree is the depth of the deepest node. So here in this case, L is the deepest node because L is at the bottommost position. Okay. So what is the depth of this tree? Depth of the binary tree will be equal to depth of L, and what will be this value? Let's hop it from A to L. 1, 2, 3, 4. So the depth of this binary tree will be 4. Okay. So what is a balanced binary tree? A balanced binary tree is in balanced binary tree if every level above the lowest is full. Okay, so suppose this is the last level of a binary tree. So if every level above the last level is complete means every node has two childrens. So suppose this is considering this example, the level above this row is this row. So if this row is complete, say B and E, C and G, okay, and so this is called balanced binary tree. This is called unbalanced binary tree because the level above the lowest is not full, because again if you can see here, A is the root but A does not have anything on the right, so we cannot balance, we cannot, this is a balance, this is balanced because uh, all the nodes are present at the left of the tree, there is nothing present at the right of the tree. So there is one more concept in balanced binary tree, is that the left the height of the left subtree and height of the right subtree should not be greater than 1. Okay, the difference between height of left subtree and height of right subtree should not be greater than 1. It could be equal to 0 or 1. It should not be greater than 1. So what is the height of left subtree in this case? A is the root. The height of left subtree is height of B, which is equal to we need to go from B to I. So 1, 2, 2 hops. Okay. So height of left subtree is 2, 1 and 2. What is the height of right subtree? Height of right subtree is also 2 because J is the deepest node, and subtree starts from C. So C to J will be covered in 2 hops, 1 and 2. So hence it is balanced binary tree because height of left subtree and height of right subtree are equal. Now in this case, height of left subtree is height of B to I. Okay, so what is the height of height from B to I is 1, 2, 3, 4, and but at the right there is no right subtree. So the height of right subtree is 0, and the difference between height of left subtree and height of right subtree is 4 minus 0 equal to 4, which is greater than 1. Hence this is not a balanced binary tree. So there are many ways to find whether a binary tree is balanced or not. I have just explained two ways. And this concept is very important when we solve some few problems. It is in most application a reasonably balanced binary tree is desirable. So um, binary tree will become more efficient if it is balanced. If it is not balanced, then it is as good as a linear or linked list. Because if suppose every node is at the left child, every node is at the left of the tree, then it becomes a list kind of structure. It will not become a tree kind of structure. So to make more advantages, or to take more advantage of a binary tree, make sure that your binary tree is balanced. Okay, let's cover out about what is binary search tree. Binary search tree is a special case of a binary tree where each node has two children, left and right, and the value of left children is less than the value of the parent node, and value of right children is greater than the value of parent node. So this is the property of a binary search tree, and it is very helpful while doing searches because it reduces the number of times we need to iterate through the tree. Okay, so uh, let's see what is binary tree in picturization form. So this is a binary tree where each node has at least or at most two childrens. Yes, any node has at most two childrens. Okay, and value at the of the left child is less than the value of the parent. Yes, value of the left child is less than value of the parent. Value of the right child is greater than value of parent. Yes, value of the right child is greater than value of parent. And so there is one more important property in binary search tree is not only the immediate nodes but the left subtree or the right subtree is aligned according to value. So every element or every value in the left subtree will be less than 10. So here whatever value is there, however tree grows, the value at the left subtree will always be less than 10 and the value of right subtree will always be greater than 10. So this becomes kind of a balance. Okay, and how it helps to do the search we'll see just now. So also, if we traverse through a binary search tree in a particular manner, okay, we will see touch about how to traverse in a tree. But if we traverse a binary tree in a particular manner, it will always result in a sorted array or sorted form. Okay, so this is also very helpful. We will see how it is helpful to us. So binary search in a sorted array. So let's assume we have an array and say this. Okay, now look at the location of this array, which is low is the lowest element, lowest index, high is the highest index. So lowest index is 0, highest index is 6. So 0 plus 6 by 2 equal to 3. So 3, if we calculate this, we will get 3. So searching for, so 0 plus 6 by 2 equal to 3.
Just a quick info, guys. Test your knowledge of C programming by answering this question. Which of the following is not a data type? A. Float. B. Int. C. Real. D. Imaginary. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
Now, what is the, now we divide this array into two parts, this part and this part. That is, this will become root, okay, and this will be the left subtree and this will be the right subtree. So now when we build a left subtree, how we build? Uh, Low is 0, high is 2, low plus high by 2 equal to 1. So 1 will become the child of 3. Okay, left child of 3. Now let's again do one more round of iteration where low is equal to 2, high equal to 2, and low plus high equal to 2. So 2 will become the right child of 1. Okay, so using same approach we can build this array in form of a binary search tree which will look like this. So since we got the first element as 3, as at an index 3, so the value at index 3 will become the root. Okay, so 7 will be the root. Okay, now all the elements at the left, uh, all the element which has index less than 3, these index 0 1 2 will come at the left side of the tree. All the elements which has index greater than 3, that is 4 5 6, will come at the right side of the tree. So now we remain with this sub array, small array. Now to create, now to find a root in this sub array, we will again follow this same method, low plus high by 2. Here low will be 0, high will be 2. 0 plus 2 by 2 equal to 1. So 1 will 1, or the position at 1, which is equal to 3. This will become the left child of root node. So 3 will become the left child of root node. Again we follow the same approach, low plus high by 2. Then we get 5 will become the right child of 3, 2 will become the left child of 3. If we follow the same approach here, we will get this kind of a structure. Okay, now how this structure is helpful in searching? Suppose we want to search for 5. Okay, now we will see, now we will compare 5 with root. So 5 is less than 7, so definitely our 5 is not at the right side of 7, it will be at the left side of 7. So we will traverse left. Traversing left, what we find? We find 3. So what if we compare 5 and 3? 5 is greater than 3, that means we need to go at right, because every element at left of the tree will be less than the root element, and so we there is no way where we can find at the left side. We have to go at right side. Going right, we can find 5. So how many iterations that we need to do? We need to do 3 iterations. Let's suppose we need to find say 13. Okay, how we can find how we can find value 13? We just have to compare it with the root node. So 13 is greater than 7, yes. So there is no way where we can find our solution at the left side of the tree. We need to go at the right side of the tree. Okay, we need to go at right side. Now going towards right side, what will be the value we got? We got 13. Yes, we find 13. So how many iterations or how many comparisons we need to do? We need to do only 2 comparisons to find 13. 1 and 2. Okay, if suppose we have to do a linear search where we just have to iterate through the list and find out a particular element, how many iterations or how many comparisons we need to do? We need to do 1 2 3 4 5 6, at least 6 comparisons we need to do. But here in 2 comparisons we are able to find out our result. So this is how binary tree is very helpful in searching technique, because it reduces the amount of comparisons or amount of work that we need to do to search a particular element, or it will also tell whether a particular element is present or not. So for example, suppose we want to search say 15 in this. Okay, whether 15 is present on this binary tree or not, we just start with root. 15 compared with 7, 15 is greater than 7, so we need to go right of the tree. Going right of the tree, we find 13. Comparing 13 with 15, we found that yes, 15 is greater than 13, so we need to go further right. Further right, we found that okay, 17. 15 is less than 17, so we need to go left, towards the left of 17, but there is nothing towards left of 17. We reached till the leaf of the tree, so there is nothing at the left of 17, so that means our element that we are searching, which is 15, is not present in the tree. So we can say okay, our whatever we are trying to find is not present in the tree, and we did it with how many comparisons? 1, 2 and 3. If suppose we need to find this uh, in this array, how many comparisons we need to do? We need to do at least 1, 2, 3, 4, 5, 6, 7 comparisons, because we need to traverse till the end of the list to find out whether our uh, element is present or not. So this is how searching in binary tree works. So before going to the coding part, let's see how binary tree is represented. As we have seen in the linked list, binary tree is also represented in a structure format, where this is the data part, this is the reference to the left, and this is the reference to the right. Okay, this is a very basic node structure of a binary tree. Going towards more enhanced way, where we have some advanced kind of data in the data section. What we can have is, we can declare one more structure called data, where we can store whatever we want. Okay, and then we can have left reference and right reference. So this is how we can represent nodes in binary tree. So let's do some problems. So this is a program where we represent binary trees. Okay, so what we are doing is, here I am including stdio.h, stdlib.h. This is a structure for binary tree, where we are having a data portion, reference to the left node, reference to the right node, type define it with tree node, so that we don't have to use struct node, and tree node is very self-explanatory. We are having a function called add node, which is just adding a node to the binary tree. Okay, so add node will return a pointer to pointer type tree node, and this will add node at, we'll be passing root here, and it will add the value to the left to the node. Okay, so how this function will work? So add node will accept three things. One is a pointer to the array. Okay, this is array pointer. One is a pointer to array. So in this program, what we are doing is, we are passing an array and building a tree for the array. Okay, so this is array that I have declared, and I'm passing this entire array to the function, and forming a tree for the function, and I'm adding a printf statement here, that at each step what all elements we are adding, so that we can know which element is added at what preferences. So this is the uh, left index of the array, this is the rightmost index of the array. Okay, so this is a recursive function. In binary trees, if once we should be very good in recursions, because most of the solutions or most of the problems that we do in binary tree can be solved easily by recursion. Okay, so let's begin. So first we have an exit condition. That means if left index is greater than right index, then we will exit and return null. Then we will calculate a mid equal to left index plus right index by 2. So we will get a center index, and then we will assign it as a parent or root node. So we'll assign a memory here, and then we will add the values. Say we'll assign extra data equal to the mid value of the array. Then we continue building the left subtree first. How we are building left subtree? We are passing the index, what is the remaining part of the left subtree, which is left and mid minus 1. Okay, and we'll build a binary left binary tree, and then we'll build the right binary tree. So how we will build the right binary tree? We will build the right binary tree by passing the remaining portion at the right side of the list, like this. And now we are using this in our main function, which returns a root node, and this root node will be our primary node to work with. Okay, so this is how this program will create a binary tree and return a root node. To be more specific, this program will create, or this function will create, a binary tree out of a given array and return the root of the tree. So let's try to compile and execute this program. Okay, gcc minus o tree binary tree.c. So we got a compilation success. Let's run it. So this is how we are getting the output. First 5 is added, then 2 is added, then 1 is added, then 3 is added. So we are adding the left, first we are adding all the left portions. So first 5 is added. So what all are remaining in the left side of binary tree, or left side of the array, is 1 2 3 4. Okay, then 2 is added. Okay, because we pick one element as the root, so 2 is picked as one element as a root, and then left side of 2 will be added, which is 1. Then left, there is nothing on the left side of the 1. We will go whatever is the right side of the 2. So right side of the 2 is 3 and 4, so 3 and 4 will be done. So this is how we build the left tree. Then we reached 5 again, because it's a recursive function. And then after once we reach the root node, we will try building whatever is the remaining at the right side of the 5. Okay, so right side of the 5 is 6 7 8 9. So we'll follow the same approach, and we will end up building a binary tree. Okay, so this is our output, and this is how elements will be added. Okay, let's continue. So tree traversal, what do you mean by tree traversal? So tree traversal is like how we are traversing in the tree, or how we are print, if you want to, if somebody gives a question how to print values in the binary tree, so how you traverse the tree. Okay, so there are many ways to walk through the tree or traverse the tree. Okay, so tree traversals are naturally recursive. So we whatever approach we will be following on for traversing the tree, it will be a recursive approach. Okay, since a binary tree has three parts, one is root, left, right, there are 6 possible ways to traverse a binary tree. So there are, what all are the ways? First we traverse the root, then we traverse the right child and left child. So left child and right child are like left subtree and right subtree. Okay, so when in the traversing terms, what if we say left, that means always a left subtree and right subtree. Okay, so here first we are traversing root, then the left subtree of the root, then the right subtree of the root. Left root right, that means first we will traverse the left subtree of the root, then root, and then right subtree of the root. So what all the combinations we can try, and this will become, this is, it depends upon what is our problem and how we want to solve the problem, and what approach or what kind of traversal technique will be good to do. So let's see three very important traversing techniques. Okay, and we will be using flag method to solve it or to traverse it. So the order in which nodes are visited during the tree traversal can be determined by imagining there is a flag attached to each node as follows. So this is a pre-order, this is in order, this is post order. So pre-order means uh, first we begin with the root. Okay, in order means first we begin with left subtree of the root, then root, and then right subtree. Post order means first we uh, begin with right subtree of the root, then we come to the root, and then left subtree. To traverse in above three order, we need to collect the flags. So if we traverse this way, like try from start from root and start collecting flags, so we will end up in this path. We'll go from A to B, B to D, and D to E, and then A to C, F, and G. Like this path will follow. So what is this? This is a pre-order traversal where we traverse the root first and then the left subtree, then root first, then left subtree. Once it is done, then right subtree. Okay, and so pre-order is nothing but traversing the root first, then the left child, and then the right child. In order, in order is traversing the left child first, and then the root, then the right child. So this is how we do the in order traversal. We visit left subtree, we complete the left part of the tree, then we go to the root and then complete the right part of the tree. Post order traversal. In post order traversal, we complete the right part of the tree first, then we go to the root, and then we complete the left part of the tree first. Okay. So let's do some practice. Write a program to create a binary tree from a given array. So this we have already completed. We just did one program which creates a binary tree from a given array. I'll advise you to try this program on your own without going to the code that I have given. In case you find any difficulty, just go back to the code, refer it, and try it on your own so that you can get more expertise. Write a program to find a specific element in a binary tree or binary search tree. So let's write this code. Let's try to solve this problem. So this is a very simple code to create a binary tree out of given array, and find a particular element in the binary search tree. Okay. So again we are having the same kind of structure where we are having integer data and then left reference and right reference. We are having two methods. One is add node to BST, which will create the binary search tree. Okay, and we will have one function which is called find value. So this function will give us 0 or 1. If 0 is written, that means the value is not found in the binary tree, and if 1 is given or 1 is returned by this function, that means value is found in binary tree. Okay, let's try to see what these functions are. So add node to the BST is a function. So this is add node to BST. this function will create a binary tree. Okay, and this is a recursive function. So uh, whatever first we need to give a root pointer or reference to a root pointer, which is address to root pointer, and a value that what we want to add. And this function first check if root is null, that means our tree is empty. What it will do, it will just assign or create one node, fill the value, that data part equal to val, left child equal to null, right child equal to null, assign the root to this value, like x is assigned to root, okay, and return it. In case if root is not equal to null, then we will say if value is, or whatever value we want to add is greater than the data part. Okay, if value is greater than the data, then we need to add the element at the right. Okay, and if the value is less than data, then we need to add the element towards the left. Okay, so here in case we found any value which is greater than the root, then what we are doing is we are again doing a recursive traversal, or we are again calling this function with the with the right child of the root node and adding this value to the right subtree. Okay, and in this case we are adding the value to the left subtree. So the value will be added at the leaf part, so it will keep on traversing till we found a exact condition, and then we will add the value. So in main function, how we are using is, in main function we are declaring one array. This is how the array is declared, and then we are running a loop. Okay, first we are having a root pointer declaration, where we are declaring bst equal to star root, where we are declaring a pointer variable to this structure and assigning it to null, and then we are iterating through the loop and adding this value. So this is an unsorted array. Okay, and we are creating a bst out of it. So once the root is created, now what we are doing is we are using a find val function. So let's see what find val function does. Now the find val function will find a particular value in the binary tree. If a value is found, then it will return 1. If the value is not found, then it will return 0. Okay, so if the root is null, it will return 0. If value is found, like if value equal to root dot data or root arrow data, then we return 1, that means we found the value. Otherwise, what we will do, if the value is less than root data, then we will go to the left portion of the binary tree. If value is greater than, that means it will come into the else condition, then we will go to the right side of the binary tree. So this is iterative function where find val is called itself, and we will be returning some value. So where we are returning the value, if we find any element which is null, like we are traversing and we didn't find any element, we will return 0. In case if we find the element, we will return 1. And return type is equal to, we are always returning an or value. That means if nothing is found, we will returning 0, because 0 or 0, 0 or 0 is equal to 0 only. And if something is found, we are ORing that value with 1, that means final result will be 1. So this function will return 1 when anything is found, or whatever value we want to search is found in the binary search tree. If the value is not found in the binary search tree, we will return 0. Okay, so let's see how we are using this in the main function. So in the main function, let's declare one variable int x equal to 9. Okay, now we are declaring one more variable, say v, and calling find val function, like what if find val function is returning any value uh, for 9 or not. We are comparing if v equal to 0, that means value is not found. If v equal to 1, then value is found. We are using a conditional operator here. Now we are again assigning x equal to 78 and saying that okay, if value is found or not. So let's try to run this program. ECC -o bst.c. Okay, we got compilation success. Let's run this program /bst. So this is the output. We have added all the values or all the uh, elements in the array. Then we searched 9. Once we searched 9, we got 9 is found. So yes, 9 is present, 9 is found. Then 78 is not found. Yes, 78 is not there in the list, so 78 is not found. So this is how searching in binary search tree works. Again we go. So if the root is null, that means that it is not, the value is not present. If value is equal to the data present in the root, that means value is found. If value is less than whatever is data present in the root, then we need to go through left subtree. If value is greater than, that means else condition, then we need to go through the right subtree. So this will reduce our scope of search and will help us out in enhancing the search performance. So I suggest you should try this program at your own and try some different variants, like you can try out having a larger array and creating a binary tree from it, and then you can have instead of declaring whatever we want to search here, you can get value from user and do searches and all. So you can just try out and do as much as practice as you can, so that you can get more and more hands-on practice on binary search tree, because binary search tree is a very important data structure, and understanding this data structure takes some effort. It's not an easy data structure to understand. Only you need to do a lot of practice to get mastery over binary search tree. So why sorting, or what is sorting? Sorting is arrangement of data sets in a particular order, ascending order or descending order. It all depends upon how you want to arrange. So the process of arranging is called sorting. It is estimated that 20 to 25%, 25 to 50% of computing power is used for sorting activities. So sorting is very much required or vastly used in our programs. Mainly, any complex program, if you are solving, it might require some kind of sorting. So it's good to know good sorting algorithms, and should have some hands-on practice on basic sorting algorithms. Why sorting is so much of required? Because many applications require sort. Many applications perform sorting when they don't have to. Many applications use insufficient sorting algorithm. So why it is important for us to learn sorting is, if we have a very large data set, and we are not able to sort the data in a proper manner or in a efficient manner, this could lead us to a very inefficient program, and our performance of the program will be very poor. So it is always better to apply a proper sorting technique as and when it is required. Don't apply sorting where it is not required. Apply sorting wherever it is required, and apply the proper algorithm. So some kind of applications which require sorting is examples like prepare a list of student ID, names, scores in a table for easy checking. Now this table can be sorted by ID or name. So it depends upon how we want to perform our operations. Other type could be to prepare list of scores before grade assignment. So scores can be listed in an ascending or descending order. To produce a list of horses after race sorted by finishing time for payoff calculations. To prepare an originally unsorted array for ordered binary searching. These are the just very few examples of where sorting can be applicable, but this is just four instances where sorting is used, but there are a number of instances where sorting is required, and it also depends upon your need, like whether you want sorting or not, and it depends upon your architecture, it depends upon your logic of solving your program. So it's just make sure whether our programs require sorting or not, and apply the sorting technique as and when it is required. So let's start with the selection sort. So selection sort performs sorting by repeatedly putting the largest element in the unsorted portion of array to the end of this unsorted portion until the whole array is sorted. So it's very simple algorithm where it starts with a complete array, finds the largest element in the array, replaces the largest element, pushes the largest element at the end of the array, shrinks the array by one position, and then again in the next iteration tries to find out the largest element in the shrinked array, put it at the end, shrink the array again, and so on until the whole array is covered. So this is how selection sort works. So this is the algorithm of selection sort. Define an entire array as an unsorted portion of array. Okay, while unsorted portion of an array has more than one element, that means we have some elements in an unsorted array.
Just a quick info, guys. If you want to make a career in software engineering, then Intellipaat provides an advanced certification program on software engineering and application development by ENICT Council of IIT Guwahati. And it is taught by IIT Guwahati professors and industry experts. This course is designed to upskill and land your dream job. Now let's continue with the session.
Just a quick info, guys. Test your knowledge of C programming by answering this question. Which of the following facilities does C programming provide? A. Input and output facility. B. No input and output facilities. C. Input facility. D. Output facility. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
Find its largest element. Okay, swipe the largest element with the last element, reduce the unsorted portion of the array by 1. So this is a looping kind of behavior where we will be finding a largest element from the unsorted portion of the array, replacing it with the last element, and then again our array is reduced by 1. So we will be continuing this process until we don't have any element in the array or any element in the unsorted portion of the array. So this is how sorting will work. Selection sort. Before sorting, this is our array. Okay. So this is our unsorted portion of the array before sorting. Okay. So after the first pass, we found that the largest element in this unsorted array is 17. So what we'll do, replace 7 by 17, like 17 is moved to the last position, and we swipe with this position. So now this will become our unsorted portion. This highlighted portion will not be considered. So this will be the unsorted portion of the array, In this unsorted portion, we again find the largest element. So 14 is the largest element. We again swipe 14 with 7. So 7 comes here, 14 comes here, which reduce our unsorted portion again. So in this unsorted portion, 10 is the highest element. We replaces 10 with 3. Now in this portion, we find 7 is the highest element. We replaces 7 with 1, because the last element of unsorted portion is 1, so we replace 7 with 1, and we continue this process till we find there is no element left in the unsorted portion. So at the end we will end up in a sorted array. So this is the sorted array. If we follow this procedure, this will be the sorted array. So the code for this, very simple code. This in this code we are having we are expecting a data integer array and size of the array. Then we are declaring two variable temp and max index. We are doing a loop which is from end of the array to the 0th element of the array. Then we are assigning max index equal to 0. Now we are running one more loop which is from the first element to the rightmost, which is this one. Okay, from first element to the rightmost element. Then what we are doing is we are just comparing if the current portion is greater than the maximum portion, then we are interchanging max index equal to current. Once our this loop is completed, what we will be doing is we will be swiping the value of the max index with the rightmost element. We will be swiping the value, and this process will be keep on continuing until we exhaust it with the unsorted portion, which is represented by the outer portion of the array. Okay, so this is our array before sorting. Okay, now what we will be doing in the first portion is we will be finding the largest position in the unsorted array, which is 17. We will be replacing 17 with the last element. So 17 comes here, 7 will be replaced with 17 because 7 is the last element, 17 is the greatest element. So 17 and 7 will be replaced. Again, this will be our unsorted array or unsorted portion. What we will be doing is we will be finding the max element in the or max value in the unsorted array, which is now 14. We'll be replacing we'll be putting 14 at the end, so 14 will come here, 7 will come here. Again in this portion we'll find the max element. Now the max element is 10. We'll be putting 10 here and replaces and 3 will come to the 10th position. This will be our unsorted array now, and in this unsorted array 7 is the highest element. 7 will be pushed to the end, which is replaced by 1, and so on, so that at the end we are sorting the array in increasing order. This is very simple example and very well known technique for sorting the array. The complexity of this program is O of n square, big O notation of n square. Why n square? Because we are running two loops here. Suppose we have an element of say size n, so maximum time that our code can take to sort the array will be equal to n square. Okay. Bubble sort. So bubble sort examines the array from start to end. Okay. Anytime it finds the largest element before the smaller element, it swipes the 2. So while traversing itself, it keep on swiping. In this way, the largest element are passed towards the end, Okay, so whatever is the largest element, it keeps on swiping, and it passed towards the end. The largest element of the array therefore bubbles to the end of the array. So that is why it's called bubble sort, because every time, every iteration, we are swiping the variable or swiping the largest element, and it will be passed to the end, or copied to the end portion of the array. This process is repeated until the unsorted portion of array is exhausted, or we don't have any unsorted portion of the array. So again, this is very similar to selection sort. Only thing is that it keeps on swiping the element and keeps on pushing the largest element towards the end of the array. So here's the algorithm. In bubble sort, what we are doing is defining an entire array as an unsorted array, while the unsorted portion of the array has more than one element. For each element in the unsorted portion, swipe the next neighbor if it is larger than the neighbor. So we are comparing two neighbors. Which one is the largest? We will be swiping. Okay, suppose value at position I is say 1, and value of position I is say 10, and value of position I plus 1 is say 9. Then what we are doing is we are shuffling this or swiping the position of I and I plus 1, and so on, still we find the end of the unsorted array, and we'll copy the unsorted portion of the array, or sorry, we copy the largest element at the end of the array. Once the first iteration is done, we reduce our size of the unsorted array by 1, and we keep continuing this operation until and unless we are done with our array, or until and unless there is no unsorted portion is left in our array. Okay, so let's see how this works. Bubble sort. So this is our unsorted portion of the array. Now outer will represent the last index of the array, inner will represent the first index of the array. We will check whether the neighbor of whether the neighbor of inner and inner we will find the largest element between inner and inner plus 1, and then if inner value at inner portion is less than value at inner plus 1, we will swipe the value. So here we'll compare 14 and 2. 14 is greater than 2, so we'll swipe 14. Then we compare 14 with 10. 14 is greater than 10, then we'll swipe with 14. We will compare 14 with 5. 14 is greater than 5. We will swipe 14. 14 compare with 1. 14 is greater than 1. We will swipe the value. 14 compare with 3. 14 is greater. We will swipe 14. 14 compare with 17. 17 is greater, so we will not do again. Now our index comes to here, and then 17 compares with 7. 17 is greater, so we will move 17 here. So at the end we have moved our largest position, or the largest element, to the end of the array. So 17 will come here. Now we are left with this array as the unsorted portion. Okay, now we will again start with the unsorted portion. We'll compare 2 with 10. It's okay, 2 is less than 10, so we cannot do anything. Now 10 is compared with 5. 10 is greater, so 10 is moved here, 5 is moved here. 10 is compared with 1. uh, 10 is greater, so 1 is moved at 10's place, 10 is moved here. 10 is compared with 3. 10 is greater, 10 is moved here. 3 is moved here, 10 is moved here. 10 compared with 14. 14 is greater, so we will not continue with 10 anymore. Now again our uh, comparison portion will become 14. 14 will compare with 7. 14 is greater, so we'll swipe 7 and 14, 7 will come here, 14 will come here. So this makes our unsorted portion as this one. Again we start with 2. So our unsorted portion will be this array. Again we'll continue with 2. 2 compares with 5. There won't be anything to do because 2 is less than 5. 5 compare with 1, 5 is greater, so 1 and 5 are interchanged. 5 compare with 3, 5 is greater, so 3 and 5 are interchanged. 5 compare with 10, no result. 10 compare with 7, 7 is lesser than 10, so we'll swipe 7 and 10. So we are left with this this portion is the unsorted array. And now 2 is compared with 1, 2 is greater, so we'll interchange 2 and 1. 2 compared with 3, 2 is less than 3, so we'll move ahead. 3 compare with 5, 3 is less than 5, so we'll move ahead. 5 compare with 7, so we'll not compare 5 with 7 because this is our unsorted portion. So we have ended up that we don't have to make any more comparisons. So at the end we are left with the sorted array, and this is how the bubble sorts works. Bubble sort algorithm is let's revisit the algorithm. Define an entire portion as the unsorted portion of the array, while the unsorted portion of the array has more than one element. Okay, so while the unsorted array has more than one element, this is whatever is not shadowed, like in this color, this is the unsorted portion. For each element in the unsorted portion, swipe the next neighbor for its larger next neighbor if it is larger than the neighbor. So if uh, if this current element is larger than its neighboring element, we will swipe the value. So like this we will be shuffling all the bigger values towards the right portion of the array, and we keep on doing that and reducing our unsorted portion of the array by 1, and we keep on pushing the largest element at the end, and finally we end up with the sorted array. So this is the code for bubble sort. Uh, so this is the code for bubble sort. So in bubble sort we declared one function, or we defined one function called bubble, which accepts integer array and size of the array. Now we have one variable temp. We are running to loop. Outer equal to size minus 1, outer is greater than 0, outer minus minus, inner equal to 0, inner is less than outer. So we are running from 0 till outer, we are not considering outer. So last but one element, and inner plus plus. So if data at inner is greater than data at inner plus 1, swipe the element. Okay, so we will keep on swiping the element till data at inner is greater than data at inner plus 1, and we will continue once the inner loop is finished. Once the inner loop is done, the largest element in the unsorted array is swiped with the last element of the array. Okay, so this is how one iteration is done. We will be keep on doing this iteration until our size of unsorted array is 0. So this is the code for bubble sort. I'd like you to try this code on your own and try to solve the problem, or try to sort an array using bubble sort. This will give you more understanding on how bubble sort is used. So quick sort. Quicksort is the fastest known algorithm, or fastest known sorting algorithm in practice. That is why it is named as quicksort. The average case of quicksort is O n log n. Worst case is n square. but the worst case is like it is very rare to happen. But on an average, a quick sort can sort our element in n log n time. Other algorithms that we have covered, like bubble sort and selection sort, these algorithm solves the problem in n square time. So definitely n square is greater than n log n, and hence quick sort is more efficient than these sorting algorithm. And whatever other sorting algorithms are there, quick sort is the most efficient algorithm for sorting the array. So let's see how quick sort works. Quicksort works in a divide and conquer technique. So divide and conquer is a very known technique in solving or developing an algorithm. Divide and conquer majorly work in a recursive manner where we divide our solution to a smaller solution and solve the smaller solution and use the result of the smaller solution to solve the bigger solution. That is how the divide and conquer works. Any big problem divided into a smaller problem, and we solve the smaller problem, use the result to solve the big problem. So this is how the quicksort works. In quicksort, we pick any element as pivot. Okay, so we selected, suppose this is set of elements, okay, and we have selected one pivot as v. Pivot is any element in the array. Okay, now partition s so that all the element at the left of v are less than v and all the element at the right of v are greater than v. So we have divided this array into two parts. We have selected one pivot and we have divided the array in two parts. One part has all the elements which are less than v, one part has all the elements which are greater than v, and we will solve this problem again. We will pick up one pivot from this and try to partition this array again and again. So, and we keep on doing this solution, keep on doing this divide partitioning as until we get all the partitions in a sorted manner. So conquer step is recursively sort s1 and s2. So here we divided the array in two part. Conquer will be solve this one, solve this one. So earlier what we have, what our problem is to solve this one. After division, what our problem is reduced to solving this one and this one. So we keep on dividing, until and unless our problem statements is become smaller and smaller, and once we got very small results, we'll propagate the solution upwards so that we can solve the bigger solution comparing with the result of the smaller solution. So combine the combine step, the sorted S1 followed by V followed by the sorted S2. So sorted S1 followed by V followed by sorted S2. This is our final solution. So this is the pseudocode of quicksort algorithm. So how quicksort works? Quicksort is we have an input array. Now we have a quicksort method. So and if a left is less than right, that means we have a valid condition. We'll select one pivot uh, and we'll partition our array, or we'll partition our array with the pivot. So we have two portions. One is left as left index and pivot minus 1. One is left as pivot plus 1 and the right index. And we perform quicksort on these left portion and then quicksort on right portion. So this is a recursive approach where we are keep on solving this. We are keep on dividing the solution till we reach some position where we have only single portion, and there is nothing to solve in a single element or single portion, so we propagate it up and solve it. So this is how pictorially we can represent quicksort, how it solves. Assume this is a bigger set. We select one pivot element, say 65, and we divide our array into two portions. One portion is less than 65, one portion is greater than 65. We solve this smaller portion and combine the solution of the this smaller portion to get final result, which where our entire array is sorted. So let's write some code for quick sort. Let's try to solve or write a program to see how quick sort works. So let's write some code to understand how quick sort works. So this is a program how quick sort works. I have written two methods. One is a method called quick sort, which actually performs quick sort. One is a method partition, which partitions our array for a given pivot value. Okay, so let's see how quick sort works. So this is how quick sort method is looks like. So I have taken two variable p and r. P is the starting position, r is the pivot value or end position. We are in this example we are considering pivot as the last element of the array. So this is our exit condition. If p is greater than r, then we are returning. Then we are calling partition method, which will partition our array from start to the end element, where end element is the pivot. This is how partition method works. So we are having two variables, I equal to p minus 1, j equal to p, and temp and temporary variable. We are running a loop where from j till r, where until j is less than r. If at any point of time a of j is less than a of r, we will be swiping the value. We will be incrementing I and swiping the value of I and j. Okay. Once we are done with this loop, we will be swiping the value of I with r, incrementing the I and return. So I will be our partition. Value from p to I minus 1 will be partitioned, and value from I plus 1 to r will be partitioned, and I will be placed at the correct position. Okay, so here the partition method returns an integer or the correct index of our pivot, and then we call quick sort method in a recursive manner to sort our array from p to part minus 1, and subsequently calling quick sort to sort the part plus 1 to r. So this is our left portion, this is our right portion. So the part, whatever the value which is written by a partition function, will be the correct position of a pivot in an array when we sort the array. We this part position divided the array into two parts. One part, like this part, will be having all the value which is less than the element at this position, and this part will be having that, like part plus 1 till r will be having all the values which is greater than the pivot element, and so on. We will be continuing iteratively, and ultimately we will be sorting the array. So in main method, what I am doing is I am declaring an integer variable, integer array of size 10. You can see this is an unsorted array. Okay, we are calling quick sort, where we are giving the array 0th position and the end position of the array. So this quick sort method will sort our entire array, and then we are printing our sorted array. Okay, so let's try to compile and run the program. Compilation is successful. Let's try to run it. So we are getting an array in a sorted order. So let's revisit the program again. We have two functions, quicksort and partition. Will perform quicksort on the partitioned array.
Just a quick info, guys. Test your knowledge of C programming by answering this question. Which of the following is not a data type? A. Float. B. Int. C. Real. D. Imaginary. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
So partition method will do nothing but partition or array or give an index which partition or array in two halves. One half is less than one half has all the elements less than pivot, one half has all the element greater than pivot. Once we get this index, what we are doing is we are again performing quicksort on the remaining halves, which is equal to start and part minus 1, part plus 1 and r. So this is how we can solve we can solve quicksort using divide and conquer approach. And this is divide and conquer approach is very helpful in these kind of techniques. Okay, browsing through the list of words and arranging them in a data structure and performing search operation. In this project we will be getting a list of words, and we will be arranging them in a certain manner so that we can perform our search easily. Binary search tree is very efficient in performing search operation. We'll be storing those list of words in a manner in a binary search tree so that we can perform a search. So what will be our approach? We will be having a linked list. In that linked list will act as an input to us. In that linked list we will be having a list of words. We will be iterating through that linked list and storing the words in the linked list in a binary search tree. Then we will be performing search on binary search tree based on the input given by user. We will be taking input from the user as a command line argument. Also, we will be writing a binary search tree and linked list in a separate header file so that those can be acted as a library functions. So, and in big projects and when we write complex code, it is much easier to divide our code in such a manner that most of the code can be easily reused and well organized, and header files are very efficient way of dividing, reusing and organizing our code. So we will be writing two header files. One header file will be of linked list, which will be performing operations on linked list. One header file will be of binary search tree, which will be performing operations on binary search tree, and one header file will be of not header file but one C file, which will be having main function, and we will be using both the header files in our C file. So let's start coding. So first I'll create a linked list header file. So to create a linked list header file, we have to use .h. We have to append our file by .h. So let's say I'm creating file list.h. Okay, hash include stdio.h hash include stdlib.h. okay, then we will be defining our node. Then I'm defining a linked list data structure. This is our data part. This is our link part, and we'll be calling it as list. Let's define the list. Initializing it by null. And then let's say I'm writing a function add to list, and I'll be adding a string which is nothing but a character pointer. Here I'm creating a temporary node. Allocating a memory to it. Malloc. X dot data, x arrow data equal to s, x next equal to null. If head is null, that means nothing is there in our linked list. Then what we are saying is head equal to x, else what we'll be doing, we'll be declaring one more temporary variable equal to head, while temp dot next not equal to null. Temp equal to temp next. So we'll be iterating through the linked list till the end. And then assigning the next element of list to x. So in this way we are appending a new element to the linked list. Okay, let's write one more function called initialize. So here what I'm doing is I'm initializing our list with some string so that this can be used as an input. We can use any form of input, for example reading from a file or downloading some data from the some stream or anything. So for simplicity what I'm doing is I'm just using linked list as a data store for us. Let's call add to list and call hello add to list. Let's call word add to list today add to list. Let's call it is to list. Beautiful. So I have initialized my list with say 1 2 3 4 5 6 strings. we can initialize it with as much bigger string as bigger list as possible, but just for simplicity I'm using only 6. You can try it out on your own and have a bigger set, but for as of now we will be initializing only with this. Let's write one more function which return this pointer get list header. It will return head of the linked list. Okay, so this is our header file for linked list. What we are doing is we have declared a structure of linked list, then we have written a function that will add a given string at the end of the linked list. So this string will be added at the end of the linked list. Then what we do is we initialize our linked list with some default values, and I'm writing one function which can give me the head of the linked list. We will be using this function get list header in our C file which is having a main function. So let's write our tree header file. stdlib.h. Let's declare the structure. We'll have a data as a string, left pointer, right pointer. Okay, so let's write a function called add to tree, which will accept root and data to add. So if root equal to null, what we are doing is we'll be creating a temporary variable, allocating memory to it. Okay, x data equal to s, x left equal to null.
Just a quick info, guys. If you want to make a career in software engineering, then Intellipaat provides an advanced certification program on software engineering and application development by ENICT Council of IIT Guwahati. And it is taught by IIT Guwahati professors and industry experts. This course is designed to upskill and land your dream job. Now let's continue with the session.
Right equal to null. Okay, and then we'll be assigning root equal to x, and then return. Else, if our root is not equal to null, then temp equal to root. If, and then we'll say let's have a val temporary variable val which will compare two strings. So strcmp temp data s. So this function will compare the data stored in our node and the data that we have provided. So if val equal to 0, then return. That means the string that we want to add in our tree is already present, so we are not adding it. That means we are not duplicating it. Else if val is greater than 0, that means whatever data that is present in our so that means whatever data that is present in our node is greater than the data that is passed to the function. So it has to store at the left side of the tree, or to be more precise, left side of the node. So what we are doing is we are recursively calling this function add to tree, and we will be passing the address of left, and the character pointer. Similarly, if our value is greater than, if our val is less than 0, that means the data stored in our node is less than the input string, then we have to store the data at the right of the node. So we will be adding it to the right part of the node. And right and s. So this will add our, so this function will add our input or given string to the tree, or it will create one node in the tree. Okay, so let's write some function to which can give us the search result. Okay, so let's suppose we are returning an integer variable. So if this function will be called as search string, so where it accepts root and input string. So let's write some comments over it so that it will be clear. This method will return -1 if string is not found, and 0 if string is found. in tree. Okay, so in case the string is not found in the tree, we will be returning -1. So this will also be a recursive function. So if root equal to null, that means we have reached till the leaf of the of our tree, so we will be returning -1. Okay, else our root is not null, so we have a let's take one temporary variable. We do string compare with root data and s. So if val equal to 0, that means we found the string, both the strings are equal, we'll be returning 0. If val is greater than 0, that means whatever string present in the tree node is greater than the given string, which is greater than this, so we will be traversing to the left side of the tree. So we'll be calling search string and instead calling return search string root left s. Okay, else if value is less than 0, then we will have to go towards the right side of the tree. Okay, so what we are doing in this function, we are taking input as a root of the tree and which string we want to search in the tree. Then we are checking if root is equal to null, that means we reached either our tree is empty or we reached to the leaf of the tree or we reach to the any node of the tree where uh, mm, or next node is null. So that means the string that we want to search in the tree is not present in the tree, so we will return -1. Otherwise what we will be doing, we will be comparing the data present in the root present in the node with the input string. If data is equal, that means value equal to 0, we will be returning 0. That means 0 means string is found in the tree. Else if value is greater than 0, that means the data present in the node is greater than the data given by the user, so we will be going towards the left side of the tree, otherwise we'll be going towards the right side of the tree. So this operation we are performing a recursive search. Okay, so let's do one more thing. Let's include string.h because we are performing strcmp. Now let's write our C file. Let's call it our file as search.c. Okay, so let's include stdio.h. Now we will be including our header files, custom header files, hash include. To include our custom header file, we need to use quotes. So list.h tree.h. Let's see what we have named them here. Okay, b3.h. So we should be very careful with the name, because whatever name we have given, we have to give the same name here, b3.h. Okay, and main. Now in this main function we will be receiving arguments from the user. So how to receive the arguments from user? uh, we need to declare two variable. We need to parameterize our main function argc. Argc means argument count, means just character enter argv, that means argument variable, and it will be a character array, not character array, array of strings. So whatever uh, so this value says that how many arguments we have got, and this will contain the list of arguments. So any argument that we want to check, like we can get it from this array. I'll show you how to do that. So first let's call initialize method from the list. Okay, so initialize method will initialize our linked list. Okay, then we'll get list header. So this will give us the header of the list. Then we define one more variable, tree null. Okay, so now let's iterate through the linked list. So while h is not equal to null, here we will be calling a function to add whichever as add we'll be iterating through the linked list and adding the string present in the linked list into the tree. So let's call the method add to tree. They will be giving address of root and the data. Then we'll be jumping to the next node, h equal to h next. Okay, so in this way we are adding each and every string which is present in the list to the tree. Then we'll be saying user as wants to search %s in our list. %s will be argv and 1. So our program arguments always starts with 1. Why? Because when we run our program, suppose we compile this program like this, gcc -o search space search dot c, so it will create our output file as search. Then we will be running /search and giving some arguments. So /search will be the first argument. We don't want that, but whatever strings that user has given after that, we want those strings. So we'll be taking first string here and printing like user wants to search this percentage s in our list. Then we will call search sorry well search string will be giving root of the tree and argv1. Okay, then what we are doing, if val equal to 0, printf percentage s found in the list argv1, else that means our output is not 0, then printf slash n percentage s is not found in the list argv. So this is how we will be doing. Now what we are doing here, first we are calling initialize method of the linked list that will initialize our linked list with the default values that we have given. Then we will be getting the header of the linked list. Then we will be defining or declaring root of the tree. Here we are iterating through the linked list and adding whatever is present in the linked list to the root to the binary tree, so that we can form our we can do efficient search. Then what we are doing is we are taking input from the user in the form of command line argument and performing search using this function search string. And then if our value is equal, if our search result is equal to 0, that means string is present. We will be printing that the given string is found in the list, otherwise it's not found in the list. Okay, so let's try to run this program. Before that, we'll be printing an extra line. Okay, and then returning 0. Okay, so let's try to run our program. gcc -o search.c. So we got a compilation success. So let's try to run the program. So we are calling search.
Just a quick info, guys. Test your knowledge of C programming by answering this question. Which of the following facilities does C programming provide? A. Input and output facility. B. No input and output facilities. C. Input facility. D. Output facility. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
What we want to search? Let's say we want to search hello. So this is the output. User wants to search hello in our list. Hello found in the list. So we already have hello in our list here. If you see initialize method, we already have hello in the list. So what all we have? Hello world, today is beautiful day. So let's try to run it again. So let's say world. So user wants to search world in our list, world found in the list. Let's try to find something which is not there in the list, say mountain. So user wants to search mountain in the list, mountain is not found in the list. So as we can also write our very small utility function where we can read a file, or we can read any data source and create a formatted data structure such as linear search tree, so that if we want to perform too many search operations, we can use it easily. So most of the times, whatever are the command line utilities are C programs which try to run and take input from the user as a command line argument, as we have given in this scenario. Let's try to do some validations over it, so that our program is more efficient. Suppose I forgot to give any argument. So here what I'm getting, I'll be getting a segmentation fault. That means my program is trying to search for the command line argument and I'm not getting it. So showing a segmentation fault is a wrong user experience, because user don't know what wrong he has done. So as a part of a project, or as a part of a complete program where we have to think about the user experience and all, we should show a correct error message to the user. Like if there is an error done by user by giving the input, we should tell him in advance before running our program, or before making any advancement, or before making any expensive operations in our program. Okay, so let's modify the program. So we'll do validations here. So if argc, so argc will give us the argument count. So if argument count is not equal to 2, sorry, less than 2, then we'll say too few arguments given by user, please provide a string that you want to search. Then return say 1 if argc is greater than 2. That means too many arguments are provided by user. Okay, then we'll say return 2. We can print any error message here. So we'll be proceeding with the creation our expensive operation, like initializing our list, then creating our tree, only when we have a correct input. So it is a good practice to always validate your input and check whether all the inputs are correct before doing any expensive operation. So let's try to run the program. GCC minus O. Okay, so let me give a correct input. So user wants to search hello. Hello is present in our list. Let me not give any argument. So I am getting a message that too few arguments are given by user. Please provide the string that you want to search. Okay. So let me run my program again. I'll be giving hello world. So I'm giving more arguments here. So what I'm getting is too many arguments to perform the operation. Okay, so in this case I'm validating my input before doing any operation, so I'm not getting any fault whatsoever. So this is a very efficient way to the or it is very efficient way to write a program where just we need to validate our input, we need to see whether we are ready to perform our logic or not, whether we have correct sets of input and all those stuff.
Now we'll start with this video on C versus C++ versus Java. To C++, it is a general purpose programming language created by Bjorn Strostrup as an extension of the C programming language or C with classes. So this is about a quick introduction to C and C++. Now let us look into Java. So Java is a high-level programming language developed by Sun Microsystems, and Java programs are interpreted by the Java Virtual Machine, or we can call it as JVM, which runs on multiple platforms. This means all Java programs are multi-platform and can run on different platforms including Macintosh, Windows and Unix computers. Now, as we saw what is C, C++ and Java, let us look into the actual differences between them. So there are certain objectives and certain points on which we will discuss the differences between C, C++ and Java. So the first one is programming type. So talking about C, it is a procedural language, whereas C++ is an object-oriented programming language. And Java is purely based on the concepts of object-oriented programming language. Now coming to translator. So in C, the translator is compiler only, and same with C++. Now coming to Java, it is an interpreted language, so it has a compiler as well as an interpreter. Then coming to platform independency, so C is platform dependent, C++ is also a platform dependent programming language, whereas Java is a platform independent language. So once you write the Java code, you can run it anywhere. Now coming to code execution, so we can directly execute C code, C++ code, but in Java, the code is executed by the Java Virtual Machine, that is JVM. Now coming to keywords for these three programming languages, so C supports 32 keywords, C++ supports 63 keywords, and Java supports 50 defined keywords. Now let us move on to the next difference, which is inheritance. So inheritance is not supported in C programming language, whereas in C++ inheritance is supported. Talking about Java, it supports inheritance except multiple inheritance. Then comes overloading. So in C there is no overloading, and in C++ it supports function overloading, that we can also call it as polymorphism. So in Java, operator overloading is not supported, whereas overloading and overriding is supported, that is decided on the basis of runtime polymorphism or compile time polymorphism. Now let us move on to the next point, which is pointers. So pointers are used to store and manage the addresses of dynamically allocated blocks of memory, and such blocks are used to store data, objects or arrays of objects. So most structured and object-oriented languages provide an area of memory, and these are called heap or free store, from which objects are dynamically allocated. So pointers are supported by C and C++, but it is not supported in Java programming language. So by not allowing pointers, Java effectively provides another level of abstraction to the developer. So no pointer support make Java more secure because they point to memory location or used for memory management that loses the security as we use them directly. Now coming to allocations. So in C programming, we use malloc and calloc, and in C++ we use new and delete, whereas Java has a garbage collector. Then comes exception handling. So exception handling is supported by Java programming language as well as C++, but it is not supported in C. Now let us move on to the next difference between these three programming languages. which is templates. So templates are only supported by C++, whereas in C and Java, templates are not supported. Now coming to destructors. So destructors are supported by again C++, and in C programming language there are no constructor or destructor available, whereas in Java also destructors are not supported. Now coming to multi-threading and interfaces, so it is only supported by Java programming language, whereas in C and C++. Now coming to the most important difference, that is database connectivity. So it is only supported by Java programming language, and C and C++ language does not support database connectivity. So Java is considered as the best programming language for developing any application because it requires database connectivity to build a full-fledged application. Then comes storage classes, and in C++ it also supports the storage classes, whereas in Java it is not supported. Now these were the actual differences between C and C++ and Java. Now you might have doubt that why do we use C, C++ and Java. So let us look into this. So first we'll see why do we use C programming. So it is a structured language. It gives us free movement of data. It is highly portable and it is used for scripting system applications. So there are certain benefits of using C programming language. As a middle level language, C combines the features of both high level as well as low level languages, and it can be used for low level programming such as scripting for drivers and kernels, and it also supports functions of high level programming language such as scripting for software applications and many more. So C is a structured programming language which allows a complex program to be broken into simpler programs called functions, and it allows free movement of data across these functions. So there are various features of C including direct access to machine level hardware APIs and the presence of C compilers as well. So deterministic resource usage is one of the important benefits of using C programming. So dynamic memory allocation makes C language an optimum choice for scripting applications and drivers of embedded systems. Now C is also a highly portable and it is used for scripting system application which form a major parts of Windows, Unix and Linux operating systems. Also C language has a rich library which provides a number of built-in functions, and it also offers dynamic memory allocation that actually helps for memory management. Now we'll see why do we use C++. Now C++ is a powerful programming language and it can be used to develop operating systems, browsers, games and so on. So C++ supports different ways of programming like procedural, object oriented as well as functional and so on. So this makes C++ a powerful as well as flexible programming language. So basically it is used for these types of application development. Also it is powerful as well as it is fast. So like C programming, the performance of optimized C++ code is exceptionally well. Also C++ is used to develop games, desktop applications, operating systems because of its performance. And one of the major benefits of learning C++ is it will become much easier to learn other programming languages like Java, Python, etc. once you learn C++. Also it helps you understand the internal architecture of a computer and how actually computer stores and retrieves information. Now let us move on to the next part, why to use Java. So Java is an easy language that is easy to write and easy to run. So when you write Java once, you can run it almost anywhere at any time. So Java can be used to create complete applications that can run on a single computer or be distributed across servers and clients in a network. Also as a result, you can use it to easily build mobile application or run on desktop applications that use different operating systems and servers such as Linux or Windows. So once a developer is familiar with installing JDK, setting up path and understanding how class path works, they will be able to build code easily. So there's a lot that you can do in Java and you can find libraries that do almost anything. So with Java there are better GUI systems that helps to develop applications. Also you can connect to database using JDBC, that is Java Database Connectivity, and for these reasons the developer community is providing to be the strength of the language and its platform. Also Java is an all-round universal programming language So it has a high level concurrency, and due to its solidity and scalability, Java is found on mobiles, desktops and large scale industry servers as well as the applications. Further, till now we saw the actual differences between these three programming languages as well as why do we use C, C++ and Java. Further, let us move on to the job scope and salary in this field of programming. So first we'll discuss about the job scope, then salary, then companies who are hiring. After that, the location of jobs. So starting off with the job scope. So in the United States, the number of jobs for a programmer are more than 22,000 in coming 2021. Then according to Forbes, in India there are 25,000 plus jobs available for a programmer in 2021. So this shows the popularity and the number of opportunity a programmer has in the field of software development. Now let us move on to the salary part. So in India, the average salary paid to a programmer is 6.25 LPA. In the United States, it is $75,000 and in UK, it is 60,000 euros. So also the salary according to the expert level for a fresher and for an intermediate professional is given over here. So if you have a good experience in the field of programmer, whether it could be a Java programmer or you have the skills of C, C++ for developing the application, it could be mobile application, desktop applications, operating systems and many more. So you can get a high pay according to your experience. Now this is about the salary structure of a programmer. Now there are certain companies who hires programmers for developing their applications and working on their software projects. So these are few of the top companies who actively hires Java as well as C++ programmers, and they are Oracle, Google, Siemens, IBM, Amazon, TCS, Infosys, then Fractal, Ola, Unisys, and there are a lot of companies in the queue. So you can get a lot of job related to programming if you have the right set of skills, whether it could be Java programming, C++ programming or C programming. Now coming to location part. So over the past decade, IT sector has expanded a lot. So you can get the job for a programmer in every part of the world. So you just need to have a right set of skills to land in your dream job.
The first question will be, what are data structures? Data structures are actually methods and techniques which are used to handle and store data in an organized manner. Basically, when answering this question, make sure not only to explain about all of the data structures that are present, such as linked lists, stacks, arrays, and whatnot, but make sure that you have an understanding of what data structures are. Basically, all of these data structures are used to attain a common goal, that is to either build dependency in terms of data entities, to build and manage relationships between the data entities, or to even produce meaningful connections in between data. So basically, these are the entities, methods, and techniques which are used to store data in an organized manner. Coming to question number 2. What is the difference between a file structure and a data structure? A file structure is an entity which gets stored only on the hard disk drive or only on the local storage. But then when you're talking about data structures have the ability to natively be stored both on the RAM, that is the random access memory, and the hard disk at the same time. Then coming to the second point, there are certain policies which guide the storage of data. So with respect to file structures, we have the standard file storage policies which works across based on the operating systems and how the data is supposed to be stored. But then when we work with data structures, there are customized storage policies which make the use of data structures very efficient and increases the read-write capability, where you can access it faster, read the data faster, and write it faster as well. And then coming to the third point basically talks about the compatibility when you're working with external applications. There is a low compatibility when you work with file structures because of point number 2, one being it has standard file storage policies, and the second thing being that so most of the applications are basically written based on the individual unit entities whenever data is in concern. So whenever data is supposed to be stored, each individual entity of data is actually in concern when developing policies and when finding out methods to basically store them. But then with data structures, it provides a high compatibility whenever you're storing with external applications, because this unit entity that we just spoke about is basically already optimized in this particular case. That brings us to question number 3. What is a linked list? Well, this has to be one of the questions that will surely be asked, because linked lists form a very vital aspect of data structures, and linked lists are nothing but the most used data structures in today's world, because these form very nice methodologies and these provide very nice ways the user can store and handle data, where every individual element in a linked list is called as a node, and each of these nodes form a chain like structure whenever you connect it to other nodes. Each node will have the data present to it and a certain address associated with it. This address is used to basically access the data, and then of course the data can be changed however required. There are many types of linked lists. There are single linked lists, there's double linked list, there's circular linked list, and more. And with that, we have question number 4. Well, where are data structures primarily used? You can answer this question based on multiple factors. One being that you can find data structures almost everywhere around you in the world. Data structures are an integral part of almost everything with respect to information technology. Everything from numerical computation, operating system design, artificial intelligence, compiler design, all the way until statistics. Data structures pave to be one of the foundational concepts which are very much required in today's world to handle data and to find the most efficient way and the easiest way to do it. See, at the end of the day, you're converting raw data into useful information. Finding the most effective way to do that in a structured environment is where data structures shine the most. So make sure to quote at least 4 or 5 places and concepts where data structures are used, and it would of course be advantageous if you could explain on where it is used. For example, if you're talking about data structures are used in database handling, just don't state database handling. Just go on to explain 1 or 2 lines where you're stating that they are used to form entities such as linked lists. It can be stacks and queues, and these stacks and queues provide a way to have organized access to data. So make sure to elaborate a single point based on the usage that you have mentioned. Coming to question number 5. What are the types of searching methodologies used in data structures? Well, there's 2 main types of searching whenever you talk about data structures. It's linear search and it's binary search. Linear search, as the name suggests, is basically moving across the data in a linear fashion. Linear fashion basically means one after the other in a certain order. When you talk about binary search is a better form of searching because it's more efficient, number 1. Number 2 is that it splits the data in the middle, and then it just forms 2 entities where it can search on the left side of that and on the right side of the data if the number is lesser or greater respectively. More on binary search in the next couple of questions, but then at this point of time you need to know that there are 2 types of searching, linear and binary, where linear is a simple form of searching in a set order either from left to right or right to left, and binary search involves breaking the data into smaller chunks, searching in that, break it again if required, and search, and this can be performed many number of times. Coming to question number 6. How does binary search work? Yes, this would be a very important question which has a very high probability of being asked. Well, binary search, as the name suggests, it's 2 entities. The first thing you have to always remember when you work with binary search is that it will only work on sorted data. Well, your data either has to be sorted in the ascending order or the descending order compulsorily. And once you have the ordered data, basically you have an array. Let's say you have an array. And basically, if you have to search an element in this particular array, the first thing you'll do is you'll find the middle element of it. If it's an even number, your middle number will be considered as the average of those 2 numbers. But then if you have an odd number, you will find one singular middle element. So then the data is basically split into the left side and the right side. Now, if you arranged it in the ascending order, let's say we have top 7 elements, 1 2 3 4 5 6 7. 4 will be the middle element, right? So if you're searching for 3, then of course you already know that you don't have to search.
Just a quick info, guys. If you want to make a career in software engineering, then Intellipaat provides an advanced certification program on software engineering and application development by ENICT Council of IIT Guwahati. And it is taught by IIT Guwahati professors and industry experts. This course is designed to upskill and land your dream job. Now let's continue with the session.
Up and above 4, because it won't be there. Your data is already in the ascending order, so you'll of course search below 4. Then again you will split it into 1, 2, 3, 4, where 1 and 2 can be put into one side, 3 and 4 can be put into the other side, and search. So this goes on in an iterative order. It's basically all dependent on the order of arrangement and what value you are searching for. Binary search is really simple to implement, considering that you know how the process of iteration works and how it can be put into effective use. Coming to question number 7. How are individual elements accessed in an array? Well, whenever you talk about arrays, there is a concept called as indexing. Indexing is basically denoting the position of elements in an array. And whenever you talk about arrays, and in majority of the programming languages out there, the first position will always begin with 0 rather than 1. So if you have an array size of say 10 elements, the last element will not be 10, it will be 9, because if n is the number of elements in the array, then the last element is n minus 1. It is n minus 1 because we are starting from 0 and not from n. And then whenever you talk about indexing, you can access any element that you desire from this array at any point of time. If you want the 6th element, let's say you have an array which is of the name A, and you want the 5th element to it. If you want the 5th element of array A, you'll be accessing A of 4. A of 4 because A of 0 is the first one, A of 1 is the second one, A of 2 is the third one, and all the way until A of 4, which becomes the 5th element basically. So yes, individual elements can be accessed. And when you talk about multidimensional arrays are basically spanned across rows and columns and more. So a row entity will have a separate index, a column entity will have a separate index. So when you have these two indices mapped side by side together, A of 2 comma 3, or A of course it'll be in brackets, A of brackets 2 big brackets 3, this will denote a specific element, say in that particular column and in the particular row in discussion as well. So I hope I was clear with that. Now coming to question number 8. Question number 8 says, what is a queue in data structures? Well, a queue is one of the most used data structures, in fact in real life as well. So the data structure entity such as queue was basically based on the real life fact that we use queues everywhere. So whenever we talk about queues as a data structures, you need to understand that it is all about accessing something in order, adding an element to an array in order, or removal. So order is everything when we talk about queues, because as a literal queue, let's say whenever you go to the shopping mart or to pick up anything, you get in from one direction, you pick up something, there are people behind you, and you get away from the front of the queue, right? So basically that it's basically first come first served. If you're first in the queue, you are served and you are sent off. If you're last in the queue, then you have to work your way towards the front end and basically get your order done, right? So that's exactly how queues work here as well. Of course, whenever we talk about queues in literal, there's elements such as the top element, there's the front element where the data exits, the top element is where the data comes in, and much more. Of course, you can choose to write a tiny piece of code which will denote an array and how a queue can be implemented as well. This will effectively improve your candidature there too, and of course it will impress the hiring manager as well. Coming to question number 9. What is a binary tree? A binary tree, as the name suggests, it's basically a tree-like structure which has one primary node, and then this primary node or the main node, or it's called as a root node as well. So this root node is split into two nodes, and one is on the left and one is on the right. Hence it's binary. Every single element here will have entities which are on the left and on the right, and each single node can have only two other nodes as well, and these two nodes of course can have two more nodes, and it will go on exponentially. But then a binary tree will consist of two nodes left and right to the root node. And of course, if you're wondering where binary trees are used, or if you're wondering why is a binary tree required when we have something such as a linked list, understand that binary trees provide an ample number of advantages whenever you're using a linked list. And of course, it is considered as an extended linked list for the same reason as well. Now, coming to question number 10, what is the meaning of a stack? A stack is literally, again, as the name suggests, like a stack of books or a stack of cards. This is another data structure which has been implemented based on real life implementation. So, whenever you're working with queues, you have to understand the data can exit, enter, and do anything it wants in both of the directions, left and right, front and back. When you're working with a stack, data can only be worked within one point of time. For example, if you're placing 10 books on your table right now, to linearly and easily pick up a book, it can only be done from the top element. Of course, you can slide your hand under and pick up any number of books you want as well, but that is not the concept here. The concept here is that to easily able to lift without disturbing other books. So in that particular case, you can only lift the top one, and once that's gone, you can pick up the next one, right? So if you think about putting the books in order, if you put book number 1, it will be at the bottommost. 2 is on it, 3 is on 2, 4 is on 3, and so much more. So if you have to delete an element, you have to pick up the 10th book first. The last book which went in is the first book that comes out. Again, we're going to discuss this concept in the next couple of questions. And with this, pretty much stack implementation is again very easy, and of course we'll be looking at that in detail as well. Now, coming to the thing that we were talking about, question number 11 states, what is the working of LIFO? Well, LIFO, as you can look at it, is an acronym which stands for last in, first out. LIFO is basically telling the user or giving guidelines on how data is accessed and worked on. Because whenever you think about LIFO, think about two data elements and compare it. If you put in something, it means that if it goes in at the last, it's the first one to come out. Well, now this sounds very similar to question number 10, right? Because in a stack of books, the last entity is the first one to come out. Of course, LIFO is the governing principle of how a stack works as well. If an element is pushed in at the last, it's the first one to come out. And of course, if you have a requirement where you want to get the first element stored, then you have to retrieve all of the above ones, and then only the last one, which is literally the first one, will come out. And with that, we move to question number 12. Question number 12 states, what are multidimensional arrays? As we discussed, multidimensional arrays are these arrays which span in more than one single direction, more than one single dimension. It will have a specific set of rows and specific set of columns, just like a matrix in real world. And with this comes more than one index variable, because one index variable is for the rows, one index variable is for the columns, and more. So the interviewer might ask, saying, why do we require multidimensional arrays? Well, one good reason of why you would require multidimensional arrays is when you cannot represent an entity in just one dimension. See, whenever you talk about, let's say, GPS coordinates, latitudes and longitudes, as you might have studied in your college or school days, whenever someone asks for a location, an exact numerical location, you cannot just provide the longitude and say, I am here. You'll have to provide a latitude and a longitude to represent your position as well. So these two entities cannot be split into two data steps, right? To bring it together into one is again a very, very good example of a two-dimensional array. And now coming to question number 13. Question number 13 is again asked a lot, so pay attention. It says, are linked lists linear or non-linear data structures? Well, the answer is it's best of both worlds here, because it primarily depends on how you're using, what the storage policies are. See, it can work in a linear fashion as well, in an ordered data set or in an ordered fashion. And of course, it can work in the non-linear structure where, position can be picked up, random data can be picked up based on where it is, what are the strategies that are put into retrieving the data. And basically, this is what forms to give it that linear behavior, as the name suggests. So yes, whenever you ask this question, so make sure to tell them that it can be used both as a linear data structures and as a non-linear data structure as well. With that, we come to question number 14. Question number 14 asks, what is a binary search tree? We saw what a binary tree was. Well, what is binary search tree? Well, again, Just like a binary tree, it consists of two primary nodes from the root node. So one root node where one of the child nodes is on the left and one of the child nodes is on the right. But if you're talking about binary search tree, and since the data is always numerical whenever we work with trees, the value in the left structure of the tree will always have to be less than the root node, and values on the right side of the root node will always have to be greater than the root node itself. This is one important thing that makes a binary search tree what it is. Let's say if you have 5 as the root node, elements between 1 and 4 will compulsorily be on the left subtree, and elements 5 and above will be compulsorily on the right subtree. And then again, in another step where you're breaking the tree into further subtrees, the same rule applies. The primary root node of that little subtree that we're talking about should have values which are greater than the left subtree and less than the right subtree as well. And this is how the entire tree can be generated. With this, we come to question number 15. What is the meaning of FIFO? We saw LIFO, right? Last in, first out. FIFO is basically first in, first out. First in, first out is how queues work in real life. You go first in, you're served first, and then you are outside first, right? So you're first in, processed first, and you're outside first. Well, remember it like that. If you're ever confused between what LIFO stands for or where LIFO is used, FIFO is used, and please do not mug up these concepts. It's pretty easy to remember. If you go first in a queue, you're served first. Think of FIFO, think of queue. And then if you put 10 books on the top, the last book you put as the first one you'll remove. Hence LIFO, last in, first out. Right. So coming back to FIFO, FIFO is basically, again, just as I mentioned, you'll be served first based on the order. And it's pretty much as simple and as straightforward as that, right? And you can, of course, take a real life example to show the interviewer that your understanding on the concept of FIFO is concrete. Now, coming to question number 16. What is the difference between void and null in data structures? Well, both of these sound very similar, right? Void is like, deficient of something, and null says nothing. So basically there is a small difference. Whenever you talk about void basically says that whenever there is a certain data which has been declared, let's say a variable has been declared, but then if it does not have any value associated with that while initializing, it means that there is no size. It means void in computer science terms. Now when we talk about null is actually a value. It is a value which has no physical presence on the memory, but then it's saying a particular state of that element or of that data structure at that given point of time. Void says that there is no size involved, but then null says that hey, I am a value, I have no physical presence, but I denote something. This is the very simple difference between void and null. Coming to question number 17. Question number 17 states, what is dynamic memory management? Well, dynamic memory management is a way, it's a methodology where, all of the storage units which are basically used to store your data changes. What I mean by this is that, as the name suggests, since it's dynamic, memory is basically managed as in when the data occurs. See, if you buy a hard drive worth 1 terabyte, but then if you only store data worth 1 gigabyte, it won't make sense. Now, if you have to store 1 terabyte, but then you have a hard drive worth 1 gigabyte, it's impossible, right? But then if you could find out what your data size is, and if you could go on to match and store the data into the hard drive one element after another, where let's say size is unlimited in both of the cases, this is exactly how dynamic memory management will work. Each of these entities gets separated or combined to eventually be stored, and whenever you separate it or combine it, they form entities called as composites, and these composites are used as entities to be stored on the final data drive as well. And these composites basically change in case if your data is changing, so make sure you mention that. Now coming to question number 18. Question number 18 is of course the most asked question in all of data structures interviews. What are push and pop operations in data structures? Well, a push operation is when you add an element into the data structure. A pop element is when you remove an element from the data structure. So whenever you think of push, think of it that you're pushing an object into something else, and whenever you're pulling, you're removing one from the other. This is the most simplest way that I used to remember push and pop operations way back in the day. So whenever you think push, think of adding elements. Whenever you think of pop operation, make sure that you're thinking about removal of data from the data structure. It is as simple and straightforward as this. Coming to question number 19. How is a variable stored in memory when one is using data structures? Well, see, whenever a variable has to be stored in memory, you have to understand the value that is associated with the variable and how much of space is required to actually manage the memory for that particular entity. So, whenever your quantity of memory is assigned, say, you know what, I need 10 bytes of data to store this value. Well, firstly, it depends on the data structure that's being used. And the second thing, now, whenever you're using dynamic allocation, what basically happens is that it understands and knows that 10 kilobytes might not be the only size that the variable will have. It can have 10, it can have 100, it can become 1 gigabyte in 10 seconds and much more. So a dynamic allocation will ensure that it will provide ample number of space and it will provide the extra legroom which is required to store this variable. And in fact, even if there are rapid changes in the size of the variables, that it can be stored very well in an effective and an efficient way, as we discussed in the previous couple of questions as well. So make sure to mention that too. This brings us to question number 20. Question number 20 states, what is merge sort? Well, as the name suggests, you might guess that since it has the word sort, it has to do something with sorting elements in a certain order. Merge sort is one of the merge sort is one of the popular methods used to sort elements whenever you have a linear data structure. Now, let's say you have an array where you want to perform merge sort on it. The main working of merge sort is this divide and conquer approach. This is one very important thing that it'll add a lot to your candidacy if you mention. It's the divide and conquer approach. So basically, each of the entities in a merge sort will be adjacent to each other, right? So the elements will be next to each other, and these entities will get merged together, and these tiny mergings or these tiny entities which are formed after merging will be sorted. And then these sorted lists are kept aside. Another couple of elements are taken. These elements are again sorted and then put to the left. Think of it like taking a chunk of colored rubber bands and then sorting each of these color rubber bands into their final color and then putting it aside into separate units. Well, that is how merge sort works as well. You merge a certain set of elements, you sort it out, you put it to the left. You take in more, merge it out, sort it and put it to the left. And now when you combine the entire thing, everything from the left to the right will have been sorted because you took individual elements and sorted it, right? That is how merge sort works. And now coming to question number 21, why should heap be used over a stack? Well, heap is another wonderful data structure which is very helpful whenever you are working with data structures because it provides the user with an efficient way to work with. Again, when we talk about data structures, when we talk about efficiency, you might be wondering, is this have to do something with dynamic memory allocation? Yes, heaps are data structures which are basically used whenever you have the data which requires a dynamic memory allocation requirement, and where the data is removed and added as per the requirement as well. So the access times and the storage methodologies, the policies and whatever govern heaps in the back end of it, which of course you should not be concerned with at this point of time, makes it very effective. It makes it very efficient to use, whenever you compare it to a stack. But then with the extra added dynamism, with the extra added efficiency in read-write speeds, if you directly compare it to a simple stack, the memory time is actually a bit slow. Why is this a bit slow? Because you have to have all of these things working in the back end to make sure that dynamism is maintained. It is efficient, no wonder. A complex heap will be efficient when you compare it to a simple stack. But then if you're very hardcore about time complexity, then of course a simple stack will win. So make sure to mention that as well. Coming to question number 22. What is the meaning of data abstraction? Well, data abstraction is it's a tool, it's a concept which is widely used in data structures. Data abstraction is a concept of simply breaking down complex entities into smaller problems, then solve each of these smaller problems, and then eventually you will have solution to the entire problem. So this approach, this tool, this technique is called as data abstraction, where you take a complex entity, you break it down into simpler steps, and further you can break down those simpler steps into even more simpler steps to work with. So it isn't the similar working analogy as a tree data structure. You have one entity, you break it down into two, you break the two into four, and much more, right? So think of it like that. Coming to question number 23. What is the meaning of a postfix expression in data structures? Well. Postfix, prefix, and in order traversals are very important questions which are asked in data structures interviews. So make sure you understand each of these. Coming to postfix expressions first, where postfix expression is a situation where each of the operator that you have, whatever operation you're performing on, operator plus, minus, multiplication, division, whatever it is, this is basically preceded by its operands. Operands are the numbers which you're working with. So why we use prefix postfixes to basically ensure we have to remove all of the parentheses or to remove any sub expressions wherever you're working with operators, because this forms a very vital thing. Number one, with operator precedence. Number two, if you're performing any sort of lexical analysis, you're working with postfix and prefix expressions will add a lot of value there as well. So with that, question number 24 is again another very high probable question. What is the working of selection sort? Well, selection sort, as the name suggests, is another way of how you can sort the data. Selection sort is very simple. Let's begin directly by understanding how it works. So whenever you're working with selection sort, let's say if you're working in the ascending order, it will directly select the smallest entity first inside the entire array after traversing it once, and it will make sure to set the index of that to 0. So what happens is, as soon as that is done, this element will be compulsorily the first element. Next, it finds the next smallest element, puts it on the right of the first one. Next, again, look at the entire thing, find the smallest one, put it in its final place. Iterate through the entire thing, find the next smaller one, put it into its final place. So basically, by iterating through the entire array, you will be putting the element directly into its final position by putting an index value to that. This is what is the simple working of a selection sort, and of course that is done until all of the elements are sorted. Now coming to question number 25. What are signed numbers in data structures? Well, signed numbers, again pretty simple. As the name suggests, it is numbers which will have a bit in the beginning which will basically denote if the number is a positive number or a negative number. This bit that we're talking about, it is called as a sign bit. And since we're talking about binary, if the signed bit is 1, it means that the number is negative in terms of binary. And if we talk about the signed bit being 0, it means that whatever number you're working with is a positive number. So if the signed bit is 1, it indicates the number is a negative number and the presence of a negative sign. If the signed bit is 0, it indicates the presence of a positive sign. And with this, we come to question number 26. Question number 26 states, what are the minimum number of nodes that a binary tree can have? Well, before we move on to the question, can you take a quick guess about the minimum number of nodes a binary tree can have? Well, you might have guessed right. A binary tree can have 0 nodes. Yes, 0 nodes, or of course a minimum of 1 and 2 as well. So a binary tree is not a compulsion of having 2 compulsory nodes. A binary tree with just a root node is also a binary tree. A binary tree with 1 node is a binary tree. A binary tree with 2 nodes is another binary tree as well. And if you're thinking about how it can be 0 in another perspective, if there is a null value in your tree as the root node, again, your binary tree is considered to be having 0 nodes as well. Coming to question number 27, what are the data structures that make use of pointers? Pointers. These form to be very, very important foundational concepts you have to know whenever you talk about data structures. So pointers are basically entities that are used to point to an address of an element. Well, why do you want to point to an address of an element? To make sure that you can access it from one part of the memory, right? So let's say if you want to visit your friend who's staying probably 1 or 2 roads away, and if you know just the person but you've never gone home, you will need an address to go to meet this person, right? This is exactly how data works as well. You need the address of where the data is located to work with it, to pick it up, delete it, add to it, remove it. So pointers are used for that. And then when we talk about the use of pointers in data structures, it is used everywhere. Binary trees, linked lists, stacks, and queues to denote where each of the elements are and what are the addresses of each of those elements present in these concepts. So make sure you mention at least 3 or 4 data structures where pointers are used. Coming to question number 28. What is the use of dynamic data structures? Well, dynamic data structures, as we have discussed, is very similar to the working of dynamic memory allocation. Here, the entire data structure provides the user with a flexibility where data can be stored and manipulated based on the amount of data. You can work with it. So basically, it is so flexible that you can change the entirety of the inflow of data, the amount of data, etc. before it enters into an algorithm where it's worked on, or before a program is executed as well. So a dynamic data structure is very similar to the working of dynamic memory allocation. And then, of course, I'm pretty sure you guys can elaborate on this as well. Now, coming to question number 29. What is a priority queue? We know what is a queue, but what is a priority queue? Well, a priority queue, as the name suggests, is a queue where each of the elements have a priority associated with it. Now, let's say you're stuck in the traffic. Each of the cars that will move is one after the other, right? Now, if there is an ambulance or an emergency vehicle, a firefighter vehicle in the back, we're pretty sure that all of us will move to the side and give the highest priority to these firefighters or ambulance vehicles, right? This is exactly how it works here in data structures as well. So a priority queue is basically a regular queue, but then each of these elements have a priority. If an element has a higher priority, it means that it will get processed quicker than the element with lower priority. So when you're working with priority queues, well, it can be a question on its own. What is the minimum number of queues that are required to work with a priority queue? Well, you will have a queue for the data, and you will have another queue where you're storing the priority of the associated data. You get it, right? You have 10 elements on the left side, which is the actual data, but then you'll have another queue on the right side, which is basically another 10 entities, but then this is not the data, but the priority to the data. So if you asked a question saying what is the minimum number of queues required to implement a priority queue, make sure to answer it as 2. It is not just 2, it's a minimum of 2. You can of course have more, but then these get into the complete range of complex data types. But at this point of time, make sure you answer it as a minimum of 2. Now, coming to question number 30. Pointers allocate memory for data storage. True or false? Well, we discussed pointers to be addressing elements, right? Of course, the answer is false. Well, pointers basically work, as we discussed, by pointing the governing data handler to a basic respective location. It does not mean it can allocate memory on its own. Well, memory is allocated entirely in a different procedure, but then the memory is later accessed using pointers. We hope that's clear to you. And of course, whenever you talk about memory processing will mostly work in a dynamic environment only when the program begins its execution, because only when you're executing it, you will understand what the data is required, how much data is required, and if it changes, how you can handle that as well. So the answer to if pointers can allocate memory for data storage is true or false is false. Now, coming to question number 31. Question number 31 states, what is the meaning of DQ? We saw a regular queue, but then what is a DQ? A DQ is very simple. It's a double-ended queue. It means that, very simply, you can add or remove data from any of the two sides of a queue. Of course, if you're wondering if we can implement this on a regular queue, yes, you can implement this on a regular queue and basically use it as well. So what this does is, when you're talking about linked list, there's a concept of doubly linked list or circular linked list. Here you will have the data element and a left pointer and a right pointer and much more. So whenever stuff is double-ended, where data has to be accessed from both the ends or removed from both the ends, you will be implementing a DQ, or in short, for double-ended queues. Now, question number 32. Differentiate between linear and non-linear data structures. Well, we discussed this in the very first couple of questions, right? Now let's get back to that in a little more detail. As I've explained before, a linear data structure is when data is stored next to each other in a linear fashion, in an ordered fashion. A non-linear data structure is basically an entity which is stored in memory where it's not next to each other, and it's stored in a haphazard way when you look at it literally. See, for example, each of the elements in arrays, linked lists, stacks, and queues are stored right next to each other. Of course, they can be stored anywhere in the memory. We're not talking about the addressing of the memory. We're talking about them literally being there. So in linear, the data is stored next to each other. But then when we're talking about graph data structures, when we're talking about tree data structures, it is non-linear. And of course, when you go on to visualize both of this, you will get a clear-cut picture of what the difference is between a linear data structure and a non-linear data structure. But then one important thing, make sure you give examples to support your claim and your understanding of this as well. With this, we come to question number 33. Question number 33 states, what is the meaning of an AVL tree? Well, we saw regular trees, we saw binary trees, and we saw binary search trees. Now, what is an AVL tree? An AVL tree is basically a simple type of a binary search tree itself. Well, an AVL tree is different from a regular binary search tree in a way where it's only one part of it is being balanced. Not the entire tree it has a compulsion to be balanced like a binary search tree. Now then, what is balance? Balance is basically when you're directly comparing the height of the subtree from its main root node, right? So if the balance is off in a binary search tree, it can be considered as an AVL tree. But then if the entire tree is perfectly balanced and if it's non-ambiguous, it can be called as a binary search tree. That is a simple AVL tree. Coming to question number 34. How does the Huffman's algorithm work? Again, this is a very widely asked question. The Huffman's algorithm, basically, whenever you're working with Huffman's, you have to understand that you will require one table which stores the frequency of occurrence of elements. If you have like 10 elements occurring 100 times each, you will have one table in Huffman's algorithm which will basically state that, hey, this element is occurring these many times. So why is this required? Well, whenever you're constructing extended binary trees which will have a lot of subtrees or which will have only minimum weights, you will require a method to keep a track of this easily. Huffman's algorithm is the governing entity which helps you keep a track of this by giving you the frequency of occurrence where each data entity or each element presence is denoted in a structured format. And of course, you can explain this with an example using a sheet of paper as well. That will add a lot to your candidacy. Now, coming to question number 35. What are recursive algorithms? Recursive, as the name suggests, is a methodology where you're doing something in an iteration. You're doing something again and again in a loop. So a recursive algorithm is an algorithm which will work by taking a complex problem and simply breaking it down into simple problems. And these simpler problems are worked down in a loop format in an order one after the other to solve the eventual big problem. So when you talk about recursion, the output of stage 1 of recursion will be the input of stage 2 of the next loop of the same thing. Now the output of the second one is the input of the third one. So that is how recursion operations work. Whenever you talk about recursion, you're talking about looping and you're talking about how data moves in such a way that the complex problem can be broken down into simple entities and handled at the easiest way possible. And this brings us to question number 36. Question number 36 has to be the question that's been asked probably in all of the data structure interviews, right? Well, question number 36 states, how does bubble sort work? Well, bubble sort is basically another sorting methodology which is applied to arrays where elements are next to each other and values are compared. The working of bubble sort comes when the adjacent elements, two elements right next to each other, are compared, and based on where they're supposed to go, they're directly changed. This is a very simple understanding of, let's say, if you have an array which says 1, 3, 2, 4. Now you compare 1 and 3. 3 is greater than 1, so the 3 stays right there. Now you compare 3 and 2. You realize that 3 is greater than 2, but 3 is on the left side, but 2 is on the right side. So you just swap 3 and 2, and that's how it works in an iteration. That is how bubble sort works simply. And so if you're wondering why a bubble sort is called as a bubble sort, it's only because of the direct comparison between a bubble floating to the top of the water, but then anything heavier than a bubble will of course be sinking to the bottom end, right? If you're thinking of comparing a bubble to a rock, and when you throw it inside the water, the bubble will float above the water while the rock will sink. This is exactly the working of how you can understand the working of bubble sort as well. With this, we come to question number 37. Question number 37 is an interesting one. It says, which is the fastest sorting algorithm that's available? And in fact, this question is very subjective because there is no fastest, sorting algorithm that's available, which is one algorithm which does everything. So when you're working with data structures, you're trying to solve a very specific niche problem. This particular problem that you have can be sorted very quickly using bubble sort, but then you will have another program or another problem you have to solve, which can be solved the fastest using merge sort. So the answer here is that it directly depends on the data and how the algorithm processes the data as well. So there is no single fastest sorting algorithm. It is based on your data. It is based on how the algorithm works as well. And the concept of time complexity is used here to track what is efficient and what is not. With this, we come to question number 38. What is the postfix form of the expression you see on your screen? X plus y is multiplied by z minus c. Now again, if you remember, we're doing the prefix and the postfix expressions to basically keep the data ready for lexical analysis and to remove the presence of brackets as well. So here the operators are preceded by their operand. As you can see, x, y, then we have the plus, and then we have zc where we have the minus after the operands. And then of course there is a simple formula, there is a simple structure that we'll be using to work with postfix expression as well. So my advice here is to make sure you take up certain examples on your own, see what the formula is, and then solve it. Because if you are given a random prefix or if you're given a random expression by the interviewer to solve, you will of course have the ability to do so as well. But then to keep it simple in this question, we have given you the output as is. But then make sure to practice on how you can get here as well. With this, we come to question number 39. Where are tree data structures used? Well, as all of the other data structures, even tree data structures are used in a lot of places. But then these are some of the most important places where tree data structures are sort of championed. Whenever you're working with lexical analysis, whenever you're working with hierarchical data modeling, step-by-step data handling, whenever you're working with something called as a symbol table, where when you're creating a symbol table, you will be using a tree. And then whenever you're handling basic arithmetic expressions as well, tree data structures are used. If you want to perform traversals in order, pre-order, post-order, you can do so in a tree data structure as well. So whenever you ask this question, make sure to give 2 or 3 examples of where it's used. Of course, more than 3 will again be an added advantage, but make sure that they are accurate and not incorrect as well. This brings us to question number 40. What are the data structures that are used to implement graphs? Well, whenever we have to implement a graph, we are literally not drawing a graph using programs here, right? A graph is a data structure. Now, when you have to implement something called as a graph, you need 2 important data structures here to implement one data structure such as graph. Basically, we're talking about adjacency matrix and adjacency list. So adjacency list is used to tell you, and it's used to represent the data which will go in, and the adjacency matrix is to basically tell you if your data is sequential and how you can go on to work with and store the sequential data as well. So whenever you're asked saying how are graphs implemented, make sure you mention 2 things: adjacency matrix, which will show you the sequential data representation, adjacency list, which is used to represent linear linked data. Well, this is pretty much the most straightforward answer to this question. With this, we come to question number 41. What are the data structures that are used in DFS and BFS algorithms? Well, DFS and BFS are again acronyms for depth first searching and breadth first searching. These are again concepts which are used to perform searching operations when you're working with data structures. But then know this, when you're working with depth first searching, you will be basically using the stack data structure, and whenever you're using breadth first searching or the BFS BFS technique, you'll be using a queue. So if it's depth first, it's stack. If it's breadth first or BFS, it's going to be queues. And of course, if you think this might get a little confusing, just try to see if you can find a way to remember it in a simpler way. But then if you have actually worked with data structures, or if you've had experience using these, then it becomes quite literal of why a stack is used in DFS and why a queue is used in terms of BFS as well. Now, coming to question number 42. What are the time complexities of linear search and binary search? As I mentioned, linear search and binary search are basically two forms of searching, and each of these are different in its working. And of course, binary search is more efficient than a linear search. And how do you track this part where you say it's more efficient, right? So basically, with time complexity, we can understand that with each iteration of how the working is. So we have something called as the big O notation, where we consider how fast an entity can execute for that particular values as well. So at this point of time, to answer the question and to keep it concise, basically you need to understand that the time complexity for a linear search is O of n, but the time complexity for a binary search is O of log n. And then O of log n, you don't have to explain the working of it. It's basically the working on the logarithmic scale. But then in quite literal terms, it means that the binary search is of course more effective. It takes lesser comparisons to search, and it takes eventually lesser time to find an element in an array. With this, we come to question number 43. Question number 43 asks, where are multi-linked data structures used? Well, multi-linked data structures are very, very important in two concepts. When we talk about multi-linked data structures, make sure you understand that it is used wherever you require a sparse matrix and wherever you have to create an index, wherever you have to perform any operations with respect to data handling. So when we're talking about sparse matrices, and if you answer this question with saying that it's used to generate a sparse matrix, the interviewer might ask you what a sparse matrix means. So basically, a sparse matrix is a matrix which will contain minute number of non-zero elements. So it is a matrix which will consist mostly of zeros and less number of actual elements. So it's basically used as a way in numerical analysis and scientific computing, where it denotes only the functional components which are required in a matrix while omitting the ones which are not. So in case if you are asked a follow-up question saying what sparse matrices are, you can use that answer as well. So coming back to the original answer, a multi-linked data structure is used in the generation of these sparse matrices, and it is used whenever you have to create indices for data entities as well. With this, we come to question number 44. What is the methodology that is used when you have to perform in-order traversal? Well, in-order traversal is when you have an operand on the left, the operator on the middle side, and another operand on the right side, in case if you're working with binary operations. But then if you're working with trees, the question is asking you about trees, right? Of course, when you talk about traversals, mostly it's trees. So the tree is basically sought out and traversed through from the leftmost subtree. After the left subtree is processed, the root node is processed. After the root node is processed, the right subtree is processed. This is how it will work in the individual subtrees as well as the entire tree on the whole as well. First, the left is processed, the middle element of the root element is processed, next the right element is processed. Now, if you break the tree down into another subtree, again there left, center and right is the rule which will go on for the working of in-order traversal as well. And then there is a good chance there is a follow-up question which would state, what is post-order traversal then? Well, post-order traversal is basically when you traverse the left subtree first, and then instead of going to the root node, you will traverse the right subtree. After the right subtree is visited, you will come back to the root node. So instead of left, root and right as in-order traversal, with respect to post-order traversal, you will do the left first, the right subtree the second, and then come to the root node. So make sure you understand these subtle differences, because understanding them and remembering them is simple, but once you start implementing them, it can slightly get confusing. So with that, we come to question number 46. Question number 46 states, are there any disadvantages to using queues, or what are the disadvantages when you're implementing queues when you're using array? Well, whenever you're using an array, you need to understand that with queues, you might have any number of elements which can be added or removed, right? So if you're standing in a queue at your favorite restaurant to get your table or something, it's not like five people stand there at a time, right? So you can have five people standing, 10 people standing, 100 people waiting for their tables. So with array, whenever arrays are created, their sizes are not dynamic by default. Of course, you can have dynamic allocation, but then so it provides a situation where there is a discrepancy when you're creating the correct array size, because you do not know how long your queue is going to be, and in this case how many elements you will have when you're working with queue. That's one disadvantage. The second disadvantage is that whenever you store queue elements, right, it cannot be reused. So it's basically stored once, and if you have to reuse it, you cannot. Why is this? Because whenever you think about working with queues, literally as the name suggests, insertion will happen only at one point of time. When you insert data at that point of time and keep pushing your data one onto the other, you can use it only once. You cannot use it more than once, and this will cause memory dumps where you're just making it a little less efficient, because you are adding a bit of discrepancy here too. So whenever you asked about the disadvantages of implementing queues using arrays, make sure you talk about array sizing and memory dumps. Now with this we come to question number 47. How can elements be inserted into a circular queue? A circular queue is where one entity of the queue is connected onto the other, and the last one eventually is connected to the first one as well. So it's placed in a circle. Now, if you're asked about how elements can be inserted in a circular queue, make sure that you talk about two conditions, two cases. So basically the first case is when the front value is not 0, but then the rear value is max minus 1. When you talk about this particular condition, it means that your queue is not full. That is what rear is equal to max minus 1 states. If your queue is not full, then of course you can start implementing and inserting elements at that point of time. The second case is where your rear is not equal to max minus 1. If rear is not equal to max minus 1, it means that the queue is not full, and this indicates that you can add on the values wherever you require. But then since we're talking about queues, you will only have to add these values at the rear end of it. That's why we're checking if the rear end is either less than max minus 1, or in fact if it is not equal to max minus 1. Now these concepts are, if you're wondering about why it's been named like this is exactly a standard structure that is used to go on to write code with respect to handling queues or handling stacks or any other data structures as well. Of course it can be anything else, but then to keep readability at its high, the namings have been given as such. So make sure you mention these two cases. With this we come to question number 48. Question number 48 states, what is the use of void pointers? We know what regular pointers are. They're used to basically address and index an element in memory. Now what is a void pointer? A void pointer is basically an entity that is used whenever you have to store another pointer. Well, a regular pointer points to data. A void pointer will point to another pointer. It has the ability to store up data of a pointer, right? So it's pretty simple. It's as simple as that. A void pointer is an entity which is used whenever you have to store another pointer inside of it. And this pointer which gets stored inside, of course, it can be a regular pointer where it's pointing to the variety of data that it is usually used for. So where is void pointer used? Well, it's basically used whenever you have to implement multiple linked lists which are not similar to each other as well. So now if you have a case of implementing these linked lists in multiple programming languages, and if you have to bring it together at once, you will require one pointer which is pointing to another one where you're storing the data of that pointer as well. In that particular case, you will be using a void pointer. With this, we come to question number 49. What is the meaning of the stack overflow condition? Well, stack overflow, as the name suggests, that your stack is literally overflowing. It means that your stack is completely full, and whenever you insert any more elements, it is not possible to store it into that stack. So an easy way to remember this is to remember a stack which is actually overflowing. So let's say you have 10 books in your locker, or you have 10 books on your bookshelf, but then you don't have space for the 11th one. So this means that you have hit Stack Overflow condition. And of course, this is a direct analogy of how it works here as well. But then, if you're asked to state the condition where Stack Overflow happens, well, when the top element is equal to the max size minus 1, it means that the stack is full and the overflow condition has been hit. So make sure to mention that condition if asked. Now, question number 50. Have you earned any sort of certification to improve your learning and your implementation process? Well, it is of course advantageous to have a certificate in whatever concepts that you're looking at. It might not be just data structures, it can be anything: data science, Python, data visualization, so whatever it is. A certification will, of course, boost your candidature a lot. You're just basically proving to the interviewer that you have put in a good amount of time, you've put in a good amount of effort in learning new things and implementing them, and that you would want to do that for a good amount of time in your life as well. So basically, when you ask this question, make sure you talk about your certification attempt, what you learned in that certification, the projects that you did, and how you solved real world problems as well. Because with this, you're telling the interviewer that you have a strong aspiration to progress in that field, and that you're an effective learner, followed by having interests to build your career on that. So this is a very important question where you can, change the direction of the interview as well. So list all of the certifications if you have, talk about what you did in the certifications, talk about what you learned and how it's been helping you to apply, in fact, for this job that you're interviewing for as well.
Just a quick info, guys. If you want to make a career in software engineering, then Intellipaat provides an advanced certification program on software engineering and application development by ENICT Council of IIT Guwahati. And it is taught by IIT Guwahati professors and industry experts. This course is designed to upskill and land your dream job.